Welcome to APEC. It's February 17th, and I'm your moderator, Tim Ventura. I want to thank everybody for joining us on today's call, along with everybody watching us on YouTube. Mike Waters is going to be discussing ZPE Breakthrough Implications. Christopher Provatidis will be presenting a review of Inertial Propulsion Devices. Andrew Beckwith will discuss dark matter, Axion Rockets Neutrinos. Justin Pearson is going to walk us through a proposed spaceport he is working on in Aruba, and John Brandenburg will be describing the Martian Thermonuclear Holocaust. He has a lot going there that he's talked about in past conferences. We're also going to have some updates from our lab partners and finish off the event with an open discussion by conference attendees. Just a couple of quick notes. So Mike McCullouch was the scheduled presenter today, and we are very excited to have him. He's had to push back 1 month until March. He is actually sick with a cold, and he can't talk very well. So we're pushing that back 1 month. So that's kind of what held us up. So if you're here for Mike, we have amazing stuff for you, but he will be 1 month out. The other thing that is really exciting is, as you guys know, if you're following APEC, the lab work that is going on with Mark Sokol, Jared Yates, all of our team is moving forward so rapidly. It's just one thing after another after another. So in terms of lab updates, I'm not sure who will be here to present with us, but again, it's truly exciting and compelling. And, hey, we're just waiting to see how things go. So today's event uses StreamYard. We are broadcasting through the Alt Propulsion YouTube channel, as well as simulcasting through the Alien Scientist channel. If you haven't subscribed to our channels, please do so now. You can ask questions using the live chat feature on the right-hand side of the page. We do our best to ask them to presenters depending on time constraints. Also, you can view conference replays, details, and speaker info on our website at altpropulsion.com. If you haven't visited the website lately, we are always doing work on it, and we have all 60-something conference sessions, and these are averaging like 8 hours each, right? So all of those are up on the website. A tremendous body of work by a tremendous group of scientists, innovators, engineers, and garage builders. So without any further ado, I want to introduce our first presenter. Mike Waters has worked in advanced energy research for over 22 years. He will be discussing several approaches to zero-point energy systems that are currently being developed, as well as potential synergy with propulsion breakthroughs such as the QEM VEM drive and the EM drive. Mike has developed a technology-backed physics model based on system definitions that correct some poor assumptions about modern physics. These definitions have enabled teaching classically trained physicists and engineers in minutes. So his ZPE work appears to synergize with theories proposed by John Brandenburg, Mike McCullouch, Paul LaViolette, and others. So I am really, really pleased to have Mike here. I think a couple of the big takeaways are not only his work, but also the way that he explains the ZPE model in a way that's acceptable to scientists and engineers who are otherwise somewhat stodgy. We'll use that word. So let me bring Mike in. Mike, welcome, sir. Okay, and I'm going to, there we go. Okay, I'm going to add your presentation to the stage, and I'm going to take myself out, but people will be able to hear you. Just say next when you need to do the next slide. And again, thank you very much for presenting for us.
Oh, you're welcome. And I'll be looking off to the side at the screen occasionally here, but thanks for having me. And it's a great opportunity to talk to everyone here. I realize this is not your typical crowd. And it's a sweet spot for me because I started in propulsion physics really more than CPE a couple of decades ago. So this is actually my first love. And that little picture on the screen there is actually a toy I designed around 18 years ago, anticipating both ZPE and propulsion breakthroughs, and thinking, well, what's something I could build that hides the fact that I'm playing with these technologies. So that's why I chose to put that up there. I haven't given a presentation for over 10 years. I think partly because I tend to focus more on research, and I'm naturally a little bit introverted. But I also realize that this is an important time, and there's some things that we've learned that really should be shared. And the other reason to talk to everyone here is that there really is a tremendous synergy between, obviously, zero-point systems and propulsion systems. When Tim invited me on, I've actually got three people to thank for this. I just happened on a discussion between Tim and Mike McCullouch a few days ago, and realized there was some synergy between, sorry, not Mike McCullouch, John Brandenburg, and realized there was some synergy there between what we discovered, and thought it might be a good idea to talk to him. So I called Tim. I don't think we talked in a couple of years, well, 10 years. And then suddenly Mike McCullouch kindly got sick, and I found myself filling his slot. So I'm dealing with a little COVID brain fog, so I'll try to muddle through. It's funny, 'cause I haven't worked with PowerPoints in a while, and I was my paper takes about 14 minutes to read, and I've sent that to Tim so people can read it if this gets a bit if this isn't clear. But it takes less time to read the paper than I found that I was rehearsing using the PowerPoint. So I'll try to be succinct. And since I didn't know what I was getting into, I looked at last month's APEC and was very impressed with Dr. David Pear's talk about the QED and the VEM. And I couldn't help but think about the potential of combining our breakthroughs with that technology, because you'd essentially have unlimited range and you wouldn't have to transport fuel. A very brief background, because I think that I sent that in, but much of my past was involved in aviation and aerodynamics. I built a few aircraft. I'd flown several hundred different types, a lot of experimentals, so I'm probably lucky to be alive. I also got into robotics, adaptive manufacturing, disaster recovery, custom homes. So thermodynamics was a big part of my life before I sort of fell into this. And then around 2000, I realized that something was really wrong with our civilization. And the more I looked, the more concerned I became. It seemed that for whatever reason, the civilization was systemically unsustainable. And yet there was no clear cause. There were all these symptoms, but you'd think that if there were, there'd be something easily identifiable. And that it sort of started this whole journey of exploration. I ended up researching just about every area I could, from sustainability to ancient history, got into esoteric subjects, alchemy and material science. But inevitably, this all leads to thermodynamics, which is very interesting. So that led me down two rabbit holes. One was into the ZPE research, and the other was into realizing the tie between current physics and mistakes that actually go back 150 years. And that's actually really fascinating. Well, at least it is to me. Hopefully you'll find it the same. And I have a feeling that many on this call already realize that. So I'll get to the point. I'm going to cover two basic areas. One is the technologies that we've developed. I'm not going to dwell too much on the history, because that's been covered by plenty of others. But I tell you what, next slide, we'll start there. So briefly, what is ZPE? Well, from my perspective, terms like quantum is different to different people. Quanta from a particle physics is not where I'm coming from at all. I'm referring to an infinite quantum field as a source of energy, QFE, and 0 point energy is essentially what that means to me. I think the term 0 point energy is a little unfortunate because when you dig deeper into this, you realize that there's really no such thing as zero, and there's no such thing as a point. Zero as a concept of emptiness is wrong, and since the idea of smallest is an irrational concept, there's clearly no such thing as a point. So, but the name sticks, it sounds good, so we might as well stick with it. So next slide. And I apologize, my voice is going a little bit, getting over COVID, and I've got a bit of COVID fog here as well, so I'll do my best. So what I'm going to look at in terms of ZP, I figured we start with the technologies because they're kind of fun, and then we'll talk more about the physics and maybe implications. I'd sort of like to get the talk over with and get more into Q&A so that we can clarify things as people need to. So I'm going to avoid death by PowerPoint. I'm not just going to read text, but it's clear that in this research, and I think to some extent propulsion research, that there's a lot of hoped for results, and it's very easy to get misled. And it's also clear that many of the researchers end up falling into this because they didn't get a classical education. And then people that are very well educated in physics or other sciences run the risk of being ostracized by the mainstream community. So it's a touchy field to be in. But the fact is that based on my experience, 98% of free energy claims have been false. So you're looking for a needle in the haystack. That's become a lot easier as time's gone by because I've known what to look for, because I'm seeing these different systems and sort of piecing together what the basic principles are beneath them. And the academic side of this is a huge obstacle. I think it's more than most people realize, and I'll get more into that as I discuss the physics. I'm not going to delve deeply into Tesla, even though he's one of my heroes. I think a lot of people have looked at Tesla. I would say that the mainstream view of Tesla is skewed by the physics we believe. And I believe that much of his work is not understood as a result. But if you look at his work more from the quantum field perspective, it tends to make more sense. So one specific example that stands out was his supposed earthquake that he caused in New York City. And that was apparently caused by a small device he could put in his shirt pocket. If you work that out, you'd have to have that thing hooked up to the building for months to generate that amount of energy. And there are other issues because the kinds of resonance that you'd expect if you were tapping another source, you'd expect to find, say, one frequency, but in reality, you're dealing with who knows how many resonant frequencies with an event like that. To start an event by hooking up to a building and then propagating that across several blocks is pretty remarkable. And I'll leave my discussions about Tesla at that, even though I believe his work with oscillators and other areas were absolutely profound. I'm not going to get into inertial too much. I talked about this more 10 years ago. Even developed some technologies as an example. I'm aware of a couple of systems that are currently working by all indications that I've found using an inertial amplification principle. And this does overlap work with inertial drives, because in both cases, you're trying to establish some form of asymmetry, either by creating excess output or motion. So it's interesting to me because I see this physics in a very similar way. I'm working with one or two electromagnetics. I'm aware of more. And the reason I'm not focused on them specifically right now, the ones that I ran into many years ago, is often for other reasons than the technology. So when we're dealing with these technologies, you've got two factors. You've got the technology, and then you've got the people involved. And that side can be far bigger an issue than the technology. I'm sure many of you have run into this. You've got to have a very tight collaborative group where everybody does what they need to do. You can't have big egos. You can't have unrealistic expectations. And that is almost as difficult to find as working technologies in my experience. What I'd like to focus more on is direct ZP tapping, where the concept is more like a quantum pump or a lens. And one of the reasons we're focused more in this arena now, myself and the people I'm working with, is that we're working primarily with a medium like water, and that enables us to produce a commodity, which then is less disruptive. And the whole issue of hydrogen and water goes back a long way. And I've got Urban Langmuir mentioned here. You'll find he's referenced by a couple of people, including Blacklight Power. I think they're called something else now. But his work's very important because he was working to develop several things, light bulbs, working on hydrogen torch. And there's an interesting overlap here. If you look at the sun's corona, it's far hotter than the surface. And this is still one of the mysteries in current models of physics. And the irony to me, and this is probably the first time that I've talked about it, at least, and I don't know if anybody else has mentioned it, but I believe he figured this out 100 years ago and didn't realize it, because what happens is once hydrogen hits a significant drop in pressure, you get anomalous releases of energy. And he measured up to 873 times the input. And this was later replicated by Norden in about 25 years ago, 2004. So it shows that there's a bit of a tragedy here, because we could have transitioned to ZPE, almost 100 years ago. And the question is, what would this civilization look like today if we had? And it would be a startling difference, as I'm sure many of you have thought about. The economy would be completely different. We would have gone to the stars. We'd have access to all the resources of the solar system if we had transitioned to a energy source that was infinite and not dependent on the concept of fuel. So that comparative idea, where you look at a civilization that might have occurred and what we would have accomplished, and you compare it to the one we've got, it's a very stark comparison, and it tells you that whatever went wrong, we need to figure out, and I believe we have, and it all comes down to thermodynamics. So the specific systems that we're working on now are all involving very high efficiency over unity, separation of water into hydrogen and oxygen or other states. And then when those gases are recombined, of course, you've got conventional release of energy. So the actual magic, the actual quantum pumping, is occurring in the separation phase. And the analogy is to look at it like a refrigerant cycle. So instead of thinking about water as a fuel, which as everybody knows in thermodynamics, is impossible. You'd start with a certain amount of water, you'd separate it, you'd recombine, you'd get the exact same amount of water, and then you'd go and do it all over again, and oh, that's perpetual motion. So if you look at water as a medium, and you look at it in a way where you are actually transferring energy out of the quantum field, then it takes on a whole different meaning. And then you realize that you can, in fact, use that medium to extract that energy. And in essence, what that means is that same cup of water can run that engine until the engine breaks. It's unlimited. It's an unlimited energy source, and we have achieved this. So in several cases, we're running an engine directly on water. If you look at these two pictures, I only had two days to prepare PowerPoint, but so I've got minimal material. But the lower picture is actually one of my partner's systems, and that's a 1 megawatt system. And there's some stuff missing there because I had to erase 2 people from the picture. And obviously you can't see too much of what's going on, but that's a system that's running on water and providing the energy. And that in its current form, as well as the other one, the one above that is showing a cell, pretty muddled picture, but that is in that form that's running at around 27 times over. So once you run it through an engine, your actual output's around 8 times. The one below, I believe is higher, but I'm going to be determining that in the next week or two. I'm going back down to take some measurements. So these are 2 of the systems, and they use entirely different processes. Typical of this kind of situation, I'm working under NDA and other issues like that, so I can't get too much into details. But what is fascinating to me is that I'm the only one working with these different systems. And so I'm seeing the same physics underlying each of them. And yet people I'm working with are really focused on their system. I'm going to give one other example here, and that's another partner, brilliant scientist. Her work's been studied by over 14 different universities. Very advanced water technologies, but in one experiment, I ran the calculations for this. We had about a cubic meter of water, and from a 2-watt input, it showed over 420 megawatts of output, 430. And this happened in split second, went from near freezing to near boiling. So that shows just how much energy is actually available. And, you know, what is the limit of this? Who knows? So again, obviously, there's a lot of synergy here using the same physics, because really anything to do with the quantum field and what we're discovering now with warp drives and all the other amazing work that you guys are doing, we're dealing with the same physics, and now it's simply a matter of understanding that we can pull energy out, or that we can create asymmetry in motion as well. I'm not going to get into all the obvious applications. I mean, the fact is that by using the water approach alone, and the fact that it's fully scalable down to nano, you could power anything, and that includes electric vehicles. It includes piston engines or turbines, because obviously what you really want to be doing is using this kind of a principle in a fuel cell, and then it's basically a solid state, closed loop. Next slide. I'm used to feedback. I'm used to talking to people, so this is a little different for me. I feel like I'm sandboxing, but so the physics really is fascinating to me, because it points to two things. One, that we have a rational explanation where an energy source is coming from that is not based on the concept of fuel. And that's very important because every current energy source known to man comes from that concept, even wind and solar, because it's obviously coming from the sun's parent fusion reaction. So what I found is very interesting, and this came from trying to rationalize what I was seeing compared to having a life in thermodynamics, which said it was impossible. And so that inevitably led me to assessing what was wrong with the physics, because obviously the technology is working. There it is. So what I found is that thermodynamics is accurate, but it's not universal. And the main problem is that thermodynamics has become a universal concept. In fact, you can Google, the universe is an isolated system, and it'll say, yes, indeed, it is. And that's a finite concept. So let's go to the next slide. Tim, next slide. Okay. So this is the essence of the problem. By making laws of thermodynamics universal assumptions, it's closed the door on other perspectives. So one of my favorite quotes of Einstein, classical thermodynamics is the only physical theory of universal content, which I'm convinced will never be overthrown within the framework of applicability of its basic concepts. If he'd worded that any differently from that, it would be wrong. Because it's the framework of applicability which is the problem. And the fact that he recognized that, I think, is brilliant. A favorite quote of mine is Richard Feynman. There's enough energy in the vacuum inside a single light bulb to boil all the world's oceans. And this brings you to the cosmological constant problem, which is, I think, currently a 60 to 120 order of magnitude discrepancy between observation and theory. I think it's called the biggest mistake in physics or something like that. You can look it up. And again, it shows this mismatch between quantum field observations and astronomical observations, which I believe we've now solved with what I've found and the work of many others. Next slide. So here's the essence of the problem. Thermodynamics started over 150 years ago, and it's based on the concept of systems. And back then, you've got to remember this was before knowing about nuclear or any kind of other discoveries like that. So the world was described more from a entropic perspective. What we see is what we get. It's all very finite, and somewhere out there the universe ends. But the one thing I will say is that 150 years ago, the one thing they should have realized there was the possibility that the universe was infinite, and that should have affected how systems were looked at. So what I found is this. The problem is that systems are looked at only as boundaries. So, for instance, a closed system is defined as a region that is isolated from its surroundings by a boundary that permits no transfer of matter or matter and energy, and that's closed and isolated systems. And these are finite concepts of reality. And the open system can be an infinite concept. So the way I look at this is it's like defining a system like an eggshell. An egg cannot be defined as a shell, and that's the essence of the problem. We're not looking at the character of the systems. We're not looking at the properties of the systems. We're only looking at their boundaries. And if there's one primary mistake, I would say that is it. So next slide. So this led me to discover two systems. These are mandatory. I'm not particularly proud of the discovery because I absolutely believe this should have been discovered 100 years ago. You won't find any reference to these definitions, but what it does is point out the glaring problem in defining systems by their borders alone. So, and forgive me for reading the text, but first definition is a closed system requires that energy density must remain constant regardless of scale. This is fundamental to thermodynamics. If you cannot identify the content of a system, then how do you know what to do with it? You know, everything's based on understanding these numbers. You know, you have X amount of fuel in a container, and, you know, everything in nature seems to obey these laws, but it requires this assumption that we observe in a macro environment that entropy is what rules, and we can define content. We can define amounts of energy very clearly. And yet in reality, we live in an inverse energy density reality. And this is a very, very important point. If the energy density increases as volume decreases, then the energy potential of a system cannot be determined. System is open and laws of thermodynamics do not apply. And we know this. Nuclear energy is 1 million to 10 million times more powerful than chemical energy. Quantum field is supposed to be theoretically far higher. That is an absolute essential component of this reality. And yet thermodynamics is based on ignoring that aspect. And the fascinating thing is you won't find any reference to inverse energy density on the internet. All you'll find is the inverse square law. And I'll talk about that in the next slide. Actually, maybe we can go to that and come back. Okay, so the inverse square law, very well known, obviously, that focuses on the idea of you have a point of energy source, and the further you get away from it, the more diffuse it gets. Pretty obvious. And that's, again, kind of this entropic perspective on reality. What's ignored is the exact opposite of that. It's all about viewpoint. Notice this. It's we're not looking at it the correct way. So if you look at the universe as an infinite construct where there's no such thing as smallest, you realize that we're also dealing with inverse energy density. And try to find that on the internet. You won't. So just to nail this home, the way we think about things from thermodynamics is and remember, thermodynamics is an engineer's Bible. So for me to talk to an engineer and explain this, I'm literally turning their world upside down, and it's been the proofs that have enabled me to do this. And then, you know, you can have an intelligent conversation about over unity. So the problem is a matter of perspective. Based on thermodynamic assumptions, the energy potential of a gallon of gasoline is approximately 33.7 kilowatts. But is that the only possible energy potential? What's the nuclear energy potential? What's the quantum field energy potential? Is fuel the only source of energy? What's the quantum field potential? An empty container or, you know, vacuum inside? These are different perspectives that reflect technological challenges, not physics violations. And thermodynamics is looking at these different perspectives as physics violations. You're ignoring the possibility that you could define something other than what you see. So if we go back to the new systems definitions, go back up one slide. The other concept, the second definition, and again, it's mandatory, a closed system cannot be created within an infinite system. And this is obvious. Neutrinos, for instance, go ripping through entire planets, but they have energy and mass potential. And especially if you start looking at it from an inverse energy quantum field perspective, and that goes on infinitely, you cannot create a defined finite system in an infinite system. It's just obvious. It's theoretically impossible to isolate any system from an infinite spectrum, either externally or internally. And again, the concept of smallest is an irrational concept. And so regardless of what math you use or what perspectives you use, or whether you decide to normalize your equations or whatever, you can't get past the irrationality of that concept. So if we go two more slides. Great. Boy, you're quick. Thanks, Tim. So what the conclusion is that laws of thermodynamics are based on systems that do not exist. And they've led to three very, very damaging beliefs. Energy can be neither created nor destroyed. We all know that one. You can't get energy from nothing. Perpetual motion is impossible. And what you hear over and over again from engineers in this field is you can't violate fundamental laws of physics. And the assumption is those laws of physics are universal and they're based on thermodynamics. So let's go through these three beliefs. Energy can be neither created nor destroyed. Well, if you're tapping the quantum field directly, you are able to create, draw out, or destroy, put back. And yes, you can put energy back into the quantum field. That's called cold reactions. So you tend to have heat reactions when you're pulling it out. And I like the term quantum pumping or quantum lensing. And there's no nuclear reactions going on here. You're not releasing gamma. You're not releasing any of these nasty nuclear breakdowns. This is actually the same mechanism, in my opinion, that maintains atoms themselves. And I'll actually talk about that now. So my conclusion from all this is that macro entropy is maintained in balance with quantum negentropy based on an inverse energy dense field. And atoms are right in the middle. And the way I often start the discussion with a physicist or engineer is I ask a single question: is an atom entropic? And again, you can look that up. And the obvious answer is, of course, it's not. If single atoms were entropic, they wouldn't exist. They would have gone away a very long time ago and this universe wouldn't exist. Obviously, energy can be extracted or replaced from the quantum field. You can't get energy from nothing. And this I find humorous because the thermodynamic perspective of nothing as a concept of emptiness is false, obviously. There's no such thing as nothing as a concept. So really what you're saying is you can't get energy from a source of infinite energy potential. And we can prove this obviously now. And then perpetual motion is impossible is the other belief that's damaging. A perpetual motion machine is useless. There's no excess energy as a concept. But in reality, everything we've ever observed is in perpetual motion at the atomic and quantum level. Again, we live in an inverse energy dense, negentropic driven reality. So these beliefs have caused catastrophic damage, and this is where it comes back to that comparison between an alternate history where we discovered ZPE 100 years ago and the kind of civilization we'd have now, which would be, I believe, abundance-based. And the result of thermodynamic beliefs constricting what we could actually achieve by belief. And our current economy is based on unsustainable, fuel-driven debt, lack, depletion, and expansion. Those are the four cornerstones of modern economics. And thermodynamics and the concept of fuel, in my opinion, are central to that economic system, which also means that transition is kind of a chess game. I don't see much choice. If we continue down this road, I think we're in serious trouble. And at the same time, transitioning also involves a lot of hiccups. We've got to do it very carefully. And I think many of the people on this call are very aware of how much of a chess game that is and what we're up against. Next slide. So the next two slides are basically showing the two different belief systems and how different they are. And I'm not going to read it all through. We can, if you guys want to come back to that, we can. But in essence, it's summing up what I'm saying, that the thermodynamics is by definition a finite perspective of reality, and QIED, or whatever you want to call it, next slide, is really what physics is about. And that leads to a final conclusion that I think might agree with some of the colleagues out there, that, and especially this one, macro entropy is maintained in balance with quantum entropy. The more I find, the more I believe that to be the case. So if we go to the next slide. So to me, adapting to this new kind of thinking, backed by the fact that we can prove it with technologies decisively, in my opinion, it's about evolving beyond current beliefs and realizing that, you're, it's a little trite, but the idea I come up with is closed systems create closed minds. So final thought, and this is theory, but I believe that we have a very strong case for calling the quantum, an infinite inverse energy dense quantum field, a fifth dimension, because it meets all the requirements for a tangible fifth dimension, which I think some would agree makes it easier to solve unified field equations. The fact is if you remove any other dimension in 4D, the fourth being time, obviously you change everything. Take one dimension out, you're in 2D reality. So if you look at the quantum fields of fifth dimension, and the fact that there are also characteristics of consciousness manifesting there, I think that there's a solid case for calling it a fifth dimension. Beyond the nervousness of giving a talk after so long, one of my main interests here is that I see a lot of synergy between my work and the work of others here, and I'd love to be involved more on the propulsion side. And I think I'm excited by the idea of combining ZPE with the field effect and warp type propulsion systems, by the fact that you've now got like the QED, you have the capability to accelerate at 1g constant indefinitely and decelerate. So that's the presentation. Thanks for listening.
Mike, that is awesome. That is awesome. Okay, so what I'm going to do is take the slide deck down. Let me see if I can do that. There we go. Perfect. And you know what? Let me bring everybody in here. I'm going to bring Shiva, Jared, and Drew in. It's a quiet day. This is a holiday weekend. It's President's Day, I guess. So we should have a mattress sale. That's obviously what our hey guys, let's give Mike Waters an enormous applause for a wonderful presentation. Mike, thank you. And so I should apologize and thank you even again, because I only gave Mike like 2 days for this. Mike McCullouch was going to do a discussion. He emailed me 2 days ago and he's like, I'm really sick, I can't talk. I'm like, oh, okay. And then I had just reconnected with Mike. Mike, we haven't talked in like 12 years.
Right.
And so Mike reached out and he's like, I have all this news and and I'm juggling like 20 things. And I'm like, do a presentation. So,
and rather large shoes to fill with Mike McCullouch. He's doing
well,
some amazing work.
yeah. And I appreciate your touching on the propulsion side of it. It's
Well,
so
that's this group. So
well, and so ZPE, these concepts, that's something that's kind of part of our community, but it's not that much focused on. And so a lot of folks here just don't. It's not an area that they know much more about. So it's wonderful. Now, so do you think that I could drop your email into chat, or do you have a website or something like that?
I have an old website that I haven't uh, done much upkeep on, but I can give all that to you. How's best? Should I send it on WhatsApp or what?
Yeah, whatever
Okay.
whatever works. And again, I won't drop anything then that can be scraped online because that's something I try and be really sensitive to. So, and we have some other folks with us today. Chris is here for he's not quite there yet, and then Michael is here as well. So guys, did you have any questions for Mike Waters? We got about 10 minutes left. Shiva, go for it, sir.
Yeah, not as much of a question as just a comment that I think might be handy for you. Is so it seems like what you're saying is that you're using water as a medium to gather zero point energy, which basically, as an analogy, correct me if I'm wrong, but kind of sounds like how in biological molecules you can gather Gibbs free energy specifically because of the geometry of the biological molecules, and they're basically there's heat that is there that can be converted into usable energy, and so therefore it's not there's kind of like language around reversal of entropy that they don't there's when you start to get into that how biology uses energy, people don't like to call it a reversal of entropy, but basically it is. They're just saying, oh well, it's just an efficiency. Well, okay, fine, but that's basically you're still gathering energy that was not usable before and making it usable now. And so that's kind of the same sort of principle, is that they're basically if you're using water in some way to that it in some way taps into the zero point energy field and gathers some of the usable energy there as it goes from being just hydrogen and oxygen to being a water molecule, and then when you break it apart, you're gathering that energy again. So therefore, you're not getting energy from the molecule itself, just like you're not getting energy from any of the biological molecules when you gather Gibbs free energy in the cell. So I think that's a valuable talking point that you can get across to people if they cross that boundary between biology and physics and understand.
And you can also ask, how does chicken create excess calcium?
Really? Yeah, that's interesting. So
it tends to exceed the calcium in the environment.
Really? I haven't heard that one before.
Isn't that just bioaccumulation? It just accumulates it, keeps it?
Well, to me, alchemy is a lot easier than people think. And again, we tend to think of nuclear about it as a brute force approach. And really, if you look at the relationship between an negentropic quantum field and entropic macro, it's a resonant fractal relationship. And if it wasn't, we'd be overwhelmed by, massive amount of energy. You've got to maintain that stability. Everything depends on it. And atoms are sort of at the center of that balance. That's how I see it.
It seems like there is a verifiable, along with, of course, so you're saying you've got experiments that are already harnessing energy.
Oh yeah, large amounts. Yeah.
So I guess there's some other ways of looking at it where there should be experiments where whenever they're doing hydrolysis and fuel cells, there should be some way in which the calculations don't align. If you do both hydrolysis and fuel cells, in a cycle, then there should be some way in which there is additional energy somewhere in that cycle when you see how much heat comes off of it, etc. So there seems like there's multiple ways you could kind of attack this problem.
Yeah, again, either you're going to be breaking down something in a nuclear process or a chemical process, and the fact is, even when you're burning fuel, atoms don't disappear. You take a hydrocarbon, you dump it all into the atmosphere, and you go down the road. You've still got the same amount of atoms. And it's interesting how many engineers don't understand this. But again, the fact that we're starting out with the same amount of water, ending up with the same amount of water, and you can do that indefinitely. There's no radiation, so there's no nuclear, there's no loss of matter. This is tapping ZPE is not a fuel-based concept. It's just tapping what creates everything.
Yeah, basically you're saying that the bonding energy is what you're gathering. In other words, like the bonding energy is there, and then when it breaks, you're gathering it, but that it's gathering some of the bonding energy from the 0-point energy field during that process.
We are sneakily debonding the natural molecular bonds between oxygen and hydrogen. No, we're singing to them instead of smashing them with hammers.
Yeah, it's interesting. It's an interesting emerging area. So Michael actually, Michael Perrone was talking the other day about an experiment. This is different than what you're talking about, but in his, it was I believe it was something like a 2-micron gap, 20-micron gap with the diode where it picks up thermal energy from the environment, right? And so it was bringing in Brownian motion into an electrical circuit through that way. Michael, was that,
Cool.
did I express that somewhat correctly, or?
Not particularly, but keep trying. Yeah, I mean, if you have a system where you have strong quantum coupling, then the microcanonical ensemble can be non-ergodic. So what that means is, well, imagine you have an ideal gas simulated by pool balls on a table. If you have holes in the table, eventually all the balls will fall down. So it's an if some quanta of energy happens to enter some state, then it gets captured. It's not like it's not a smart process like a Maxwell's demon. It's actually a a straw man argument at the end of the day, because it was elegant because people were like, oh cool, information is energy, but not exactly.
Yeah.
So
I mean, you take this to the next step and you realize that all the energy differential that we see in the universe is not so much from the Big Bang as from the turbulence, the differential that was created by the Big Bang. If
all
there was in fact a Big Bang.
Differential. All energy is differential. So if you imagine taking a molecule and putting it in an area with a different vacuum ground state, then that molecule will have a different equilibrium than it otherwise did.
Right.
So yeah, you could do things like that. You could do refrigeration with that. You could do maybe energy extraction with that. We'll see.
Well, and I think that was Mike. I think that was what you were expressing, was that the concept you're working on was similar to refrigeration, right?
Yeah, it's more like a refrigerant cycle.
In
fact, you can take an engine and have no interaction with the outside atmosphere at all. You're simply taking the exhaust, taking all the water back out of it, running it back through the intake. Closed loop refrigerant cycle.
So what is the vacuum state that alters the water's behavior? And sorry, different Michael. It gets confusing, Tim. All right, yeah. So what exactly unzips the water molecules, I guess?
There's actually several different approaches. They all ultimately, much like the QED drive, remember they're using very precise geometries to achieve what they're doing. And everything, I think, comes down to that. So if you've got a resonant fractal understanding of water, you can crack that water without using electrolysis. You can use sound. You can use more like a plasma or spark process. I'm saying this from experience. And so there are more than one provable methods of doing this. And we're not talking about a minor effect. When you start talking about between 5 and 70 times over unity, that's a substantial amount of energy release from a pure separation perspective, because all of that is occurring as you separate the water into a gas state.
I'd like to see if I can write an equation on this board. Hopefully none of these markers are, hopefully one of these markers is still functioning. But
yeah, and Michael, just to be aware, we got about 3 minutes left. So
yep.
Let's see.
Yeah.
So if you go look at Friedrich Morgenthaler's paper, velocity modulation of electromagnetic waves, you have E2 equals, and this is a slightly modified version, E1, E2 over. So if you can change the.
Okay, and that's actually that, Michael. That's a little faint here. Let me try and.
I can't see it, but
yeah.
Yeah, I'll maybe I'll move the desk closer. My bad.
Wow, look at that. See, this is turning into an action movie.
Well, anyway, plus gamma 1 over gamma 2. Right. So V, of course, is 1 over root mu epsilon in a given material, and gamma is root mu over epsilon. So if you have a material where you change its physical properties with respect to time, you get a change associated with the velocity. This and a change. So if you increase the velocity, the frequency goes up, the energy goes up. Simple enough. If you change the impedance, as long as the impedances are not equal, you actually get a reflection, which in theory contains more energy than the original wave. And
yeah, you're creating a differential again by.
Well, sort of.
It's
So
almost like an inertial effect.
Maybe. So, but what's interesting about the system is that if you imagine you have some small wavelet, and you have a back propagating wave that's going the other direction, based on the angle of overlap between these, you'll get a reflected wave, which is going in this direction, and a reflected wave going in that direction. And these waves partially cancel. So you don't get the full gamma in this. So classical electromagnetism fails in this case. And
remember that all waves are 3-dimensional and 4-dimensional constructs.
So what I'm saying is you have a phase angle that's important to getting the maximal amount of energy output. So if these things are fully overlapped and then you change the impedance, you destroy all your energy. The reflections cancel out the transmitted waves. They're 180 degrees out of phase, and they have the same amplitudes otherwise, or they have opposite amplitudes going the same direction, whatever. But yeah, so you could in the classical case, these waves all cancel and the energy disappears. So, but by the same token, if you have a specific resonant structure that every time you change the material properties, the peaks of the waves are 90 or 180, I guess 90 degrees out of phase is best. But anyway, if you have the right spacing, the next time you switch, then you get this maximal energy output. So that's why you have like sacred geometries and stuff, because specific geometries will correspond to this maximal lack of cancellation. Versus,
and Michael,
and then you can also create things that will cancel as much energy as possible. Anyway,
thank you, man. Thank you.
Friedrich Morgenthaler, velocity modulation of electromagnetic. People don't realize how important that paper is.
And we can touch on some of this later. We do have a Q&A session, and Mr. Waters, you're under no obligation to stick around or come back in. But if you do want to come back in later, we'll be here all day. The APEC conference, these things just sprawl out and run for hours.
Oh, it's fascinating. This is great.
Yeah. Well, guys, let's do this. Let's put our hands together one more time for Mr. Mike Waters. Thank you.
Thanks.
Thank you, sir. And thank you for the short notice. And let me apologize for the chaos. That's normal around here. So, but
I
we're
really
making
appreciate
things
it,
work.
Tim. Thanks.
Okay. And so I'm going to take everybody off the stage and let me see. And I'm going to bring Chris in. Chris, welcome, sir. And let me see. You're muted. Let me unmute you.
Okay, thank you.
Okay. Yeah, and then let me see. So Chris Provatidis is going to be talking about, basically it's a summary of inertial propulsion. The write-up that you've given me said the use of Google Scholar produces about 278 hits on the term inertial propulsion. If you include patents, this goes up to 536 results that come back. And, I think Google is missing stuff. I mean, there are a ton of papers that have been written on that. And so what you're going to be discussing is basically some of the characteristics of inertial propulsion devices. And I'm going to put your paper up on the stage now. Oh, yeah, okay. Wait a minute. This one is yours, I believe. And you can do the back and forth if you want. Oops.
Yes, I agree.
Perfect. Okay. Well, again, thank you so much for presenting. What I will do is remove myself, and I will be here in the background if you need me.
Okay, thank you. Well, I'm very glad to be with you. Here is 11 o'clock in the night. I was confused and thought that it was 1 hour later. Okay. Well, the outline of my talk is that in the beginning I'll present the problem. I will start from ancient to modern times. I will refer to the projects that were carried out in about 2000, how to model contra-rotating mass drive, about weight loss of gyroscope, and so on. You see here the rest of the topics. Well, as you know better than me, the fathers of rocketry in a chronological sequence are the Tsiolkovsky, the Goddard, Oberth, and Werner von Braun. Okay, the problem, sorry, I have to find the right, okay, the page down here. Okay, it's down. Sorry. Okay. Well, the problem is that we have a huge rocket to move a small object, and the costs are very high. So, since many years ago, all are trying to find an alternative way for the propulsion. How to replace the rockets. Okay. And of course, this was not the reason in ancient times, but you can notice here this athlete and this halter here. These were used in ancient Greeks in the Olympic Games, as we see from the vessels, to elongate the length of the jump. You can notice here the halteres. Okay, I think this was the beginning of the inertial propulsion that, based on the conservation of momentum, they could put the halteres at the proper position and transfer the momentum of them to the body of the athlete so that he elongates the length of the jump. Well, the second, let me say, historical issue is no, here it is serious, and here is for joke. it is due to Archimedes, who said, "Give me a position to stand, and I will move the earth." This is the Greek language of that. And that means that in order to exert a force, we need a reference. So in this case, it's impossible for the Lord Milhausen to put himself outside the mud, because it is an internal force. And when we talk about anti-gravity, there are a lot of references that this is something out of normal, against the laws, and so on. Maybe they are joking, but despite all these things, we have some attempts that continue up to today. So after the ancient times, I think, to the best of my knowledge, that the first inertial drive is not the Dean's drive, as you know, but it is due to Professor Toddesini in Italy, who was awarded a patent, an Italian patent, as you can see here. This is the patent: centrifugal propulsive force engine powered by dissociated water with automatic gradual speed variation. You see here two masses, and these are due to them are the inertial forces. And of course, you know, the Dean drive, that was more complicated than the one of Toddesini, many components, but the principle is that we have a vehicle or a cart, and we have two contra-rotated masses, and due to their position, we have a transfer of momentum from them to the body that moves, but nobody knows how. But it is very interesting that only a few years after the patent of Dean, there was a Russian paper in Russia, in the journal Prirode, something like the American Nature, that was against, and they said that it is impossible that this happened. And also they start the paper, I use the Google Translator, that since 1907 they were talking about chimeras, and that also respectable persons were involved in this out of mainstream topics, and this is a matter of psychology and not mechanics. Okay. The third in turn patent is due to Professor Alfio Di Bella in Italy. Also, you can notice here a motor that gives the motion. It transmits the power up to the mass here. You see the M mass, and the path of the mass is the Viviani curve. Viviani was a pupil of Galilei. And the same Professor Di Bella, as he writes in his paper, he started in January 1962 to deal with the propulsion due to rotating masses. You see here some experiments he has reported using an inclined plane here and a small cart here. And he continued with the results of his engine in the sea. After him, there are two papers, one in 1965 in Electronics and Power, March 1965, and the next paper is due to Farrell 1966. He also was awarded a patent, and this is perhaps the first scientific paper in which we see the word inertial propulsion. Inertial propulsion here, inertial propulsion there. And of course, you know Eric Leithwaite, who was awarded a patent after his death with his co-worker Dawson, 1999. Okay. Near 2000, there were three big projects. The first was due to NASA, the Breakthrough Physics program, directed by Marco Miles. And we have the report in 1996, then also a book of 700 pages in 2009. This is one project. Another, you recognize here the interview from Ron Evans, who was the Greenlow that was conducted in British Aerospace. Here is a paper by Allen, who was one of the directors in the company. He was a professor. And also, you know, the GRASP, the Gravity Research for Advanced Space Propulsion in Boeing. It was related maybe with the Eugene Podgletov, but the company said that they did not spend money on that. And this is from the BBC News. Well, because the NASA was receiving every day at least 3 proposals on some anti-gravity devices, they were obliged to write this technical note responding to mechanical anti-gravity, where they were telling that this was impossible, and they were giving some few mathematics to prove it. But nevertheless, we had some patents after the guidelines of NASA. These are the patents from Fayala, who is a very respected person from aircraft industry, I think. We have other from Gucci. I think he sold the patent recently, and you can see here the word inertial propulsion. Here he says that this is for teaching students, okay, but in any case, they use the word inertial propulsion. Well, some questions on the DIN drive. Can the counter-rotating mass cause unidirectional motion of a vehicle? Is there net thrust? What are the parameters to control the motion of the vehicle? Of course, they are the radius and the angular velocity. Can an object remain immobile in the air? What is the possible maximum height the vehicle can jump? Okay, so in order to develop a correct mechanical model, you have 4 possibilities at least. One is to apply Newton's second and third law. The second approach is to deal with the center of mass. The third, to use the conservation of linear momentum. And the fourth, maybe the most academic, is to use the Lagrange equations. So regarding the first category, based on the Newton's law, that what is necessary is to use the inertial forces that are not only at the rotating masses, but also on the object because it accelerates. So we have to add here the mass, the product of the mass of the vehicle times the acceleration of the center of mass of the vehicle. Of course, there is a center of mass of all of that. So based on these considerations, it's easy. It was easy for me to do, but I spent many days before I acceded, before I was sure that it's correct. This is a partial differential equation that deals with the motion of the vehicle. Vehicle is something, the object on which the drive is attached. Only in this sense, we have a critical parameter that is the product of the mass, of the rotating mass, times the radius r, divided by the total rotating mass plus the mass of the vehicle. This is a critical parameter that is introduced in the equation. Also, we have the angular velocity, which is not a constant, but we have also the time derivative here. G is the gravitation acceleration, phi is the polar angle here. So if you solve analytically this equation, you take what one knows from the Lyceum, from the high school, but we have some additional terms here. Okay, the critical parameters to define the height the system will jump or will not jump is the product of this term, the initial angular velocity, and the position at which the ground will be removed. If it is a well and suddenly the cover of the well opens, it is it's going to fall down, but due to this rotation, we have a term here that is the one that gives, let me say, the thrust. It's not the thrust, it's only the initial velocity of the total system. And due to that, we have a jump. What is the maximum jump? Well, I spent many days on that, and I decided to consider the rather Bohr model. So I made the assumption that I have not one atom, but one molecule of hydrogen. And in the hypothetical case that the two electrons were moving in a contra rotation and exactly synchronized and the same length, the same angles here, and taking the mass of the proton and of the nucleus and the electron and what this model demands, I found that depending on the harmonic, in the first harmonic, the maximum altitude this hypothetical molecule would obtain is 72 kilometers height. So even it was in the beginning it was holding by something, there was a support. When the support was released, due to the initial velocity of the center of mass, it will jump 72 kilometers if there was a synchronization here. In the second, third, fourth, and fifth harmonic, okay, the minimum is 3 kilometers, the maximum is 72. I give you this number not because this is reality, it's not reality, but just to understand that is a matter of velocities and masses, how height, what the altitude will be. Well, I played with the variation of the angular velocity, and I have seen that in the model, I have seen that the position is almost a steady function. It's what the vertical suit determines under the Newtonian consideration. Also, the velocity may be vary. It depends how we choose the rotation, but whatever happens with the instantaneous velocity, the altitude is the same. Okay. And the other question is there the case that the object hovers? Yes, if we put the acceleration equal to 0 and the velocity equal to 0, it's possible to determine the phi, the angle, the polar angle versus time in terms of time, and this gives an angular velocity in closed form. But in the denominator, we have 1 minus something over square, like Einstein's law, but okay, it's not. And what happens that until the rods, the radii, take the vertical position from vertical down until vertical up, in this interval of 180 degrees, you can control the angular velocity, but when it comes in the vertical position, you lose the possibility to have an analytical expression. So it's only for a very, very, very small time integral, except if it is very slow, and in this interval you can control. Okay, what is the disadvantage of the drive? It is that the impulse in half, from the half and up and half and down, the impulse is opposite, equal and opposite. So the total impulse in one whole period is null. So you don't have the case to have an internal impulse to create the thrust. So as I told you earlier, you can either influence the radius of the centripetal force or the angular velocity. This is the principle. So we can see here a patent by Robinson where he uses a longer radius in the upper part than the lower part. And he thinks that in this way he achieves a thrust, but this is very simplistic, as I will explain to you my errors also. And here's another pattern that makes a differentiation of the radii. So they understand how to intervene, but it's for nothing, unfortunately. Okay, another debate is about the significance of the rotation regarding the assumed weight loss in gyroscopes. There are a lot of papers here, but I go through them very fast. The first was Bruce De Palma, who was electrical engineer, a lecturer in MIT, in the chair of photography, something like that, where he used photographic experiments, and he found that when a gyroscope was rotating, the maximum altitude was higher than was when it was not rotated. And he used 27,000 RPM. Okay. And there are some papers on that. We don't have time to go through them. But after some years, in December 89, there was a paper by Hayasaka and Takoshi. They used some gyroscope, rotating gyroscope, and were measured here the weight, and they found that depending on the angular velocity in RPM, they were measuring different weights in the balance, and this is the graph they obtained. And also they found that if the rotation is left, there no variation of weight. If the variation in the right direction, they have a weight loss proportional to the frequency, to the RPM of the gyros. There are many stories of that in the internet. We don't have time. And they came back after 8 years using another experiment, a free fall experiment, where they found again the same results, if it is right or left, and they found that there is a decrease of the acceleration. That means a decrease of the weight. Of course, the next year we had a paper and many papers against them in Nature that were these found null result, so no dependence of the weight. After many years, in 2007, we have a paper by Waite in Mechanica, who has measured 8% weight loss in the experiment of lathe weight. Okay. So there was needed some explanation. So the Correa brothers, if I pronounce them correct, they made some analysis here and found that Hayasaka used this level of RPM. The others used other values. The De Palma used other values. So they correlated the electric resonance. They said that there is electric resonance influence in the rotary velocity, and found that the 13,000 RPM in Hayasaka is very close to the frequency of electron graviton, very close. It was 12,800, so they are very close. And I have noticed that the amount in the Palma was almost double something more, but okay, the order is double. So may be some dependence on the frequency the Correas refer. But if you go to the paper in the electronic version, it is missing here, okay, because it was rejected afterwards. It was withdrawn, okay. But I went to a library and found it in a print version, okay. Also, there's another professor from Russia who published measurements in rotated gyroscopes and found F is the frequency here in hertz, a decrease of the weight as the angular velocity increases. Based on that, the American Dennis Allen, who is a mathematician, he published some books here, but from our personal communication, I have understood that based on the experiments of Dmitriev, he has found a formula here that the mass depends, is not a constant measure, magnitude, but it depends on the acceleration, A, and also the derivative of the acceleration, the surge or jerk is called. And the constants are found in his books, but he claims that. Of course, there are other scientists like Mike McCullouch, who is not here today. I was okay. My English is not that good. I expected to see him, but it doesn't matter that he have other laws. So, in order to make thrust, to make impulse, inertial impulse, it's necessary to break the symmetry. How to break it? So some years ago, I thought with some colleagues how to achieve it, and we thought that instead of a circle, we could fold the circle and make something like 8-8 shape, like the infinite symbol. And we used a machine like that forms, these are the masses that are moving in the shape of 8. You see here, there are two rotations. One rotation is from the motor that is given to the masses, so I call it rotation R1, the first rotation that forms the 8 shape. But after 380 degrees, the mass takes exactly the same position. So the variation, the change of the impulse is 0, so nothing happens. And due to that, we imposed a second rotation of all the frame here. So even if the object after a full rotation takes the same position, due to the second rotation will not at the same, except if it is double here or 4 times and so on. And you can see here the axis here, the masses, as I told you. This is the motion of the masses. Here is an ornithopter that is the precursor of the mechanism. Here is the mechanical drawing, the mathematics that have been published elsewhere. Also, this is the prototype that you can find in my papers. The forces are proportional to the radius as well as of the square of the angular velocity of the R1 of the first rotation. And if we consider the elastic deformation, we have a variation of the radius, because now it's not rotating on a circle where the radius is constant. Now, due to the 8 shape, we have a difference from point to point. And after many mathematics, I derived a formula that the impulse has many harmonics here, okay? And a constant term, of course, is not correct, because mathematics are correct, but physics are not. In any case, here is very, very small. I'm not sure that it was correct. And many other things that just to give you that I have worked hard in this area. And this is one experiment. It was a faulty experiment where we measured the weight reduction of almost 12%, but the strain gauges were not well adhered to the object. So at the end, it's not correct. And depending on the ratio to rotations, we have several figures here of the masses. The blue is the first mass, the red is the second mass. So depending on the ratio, we have regular or chaotic motion. And the reason of the eighth shape is that we have an axis of symmetry, so it is supposed that we can regulate the thrust in the direction we want, because due to the steering system we can turn this half of sphere to any direction we want. And this is the actual prototype we used. You see here the masses. In the beginning it was 2, then we increased the number of masses. And I published a lot of papers that are written in the report you can find in the repository, as well in preprints. I hope that it will be published also in a peer-reviewed journal. And I have investigated the dendrive in air, on the water, on the ground, how we have repeated jumps. We don't have easily. We need some support to perform the second jump. Also, I have investigated why we have the apparent weight loss. I have explained the lathe-way engines in 2 peer-reviewed journals here, and due to a paper that appeared in 2022, I think, from Taiwan. It was funded by the Ministry of Energy, and they wanted to replace the internal combustion engines. I said to myself, it's impossible. So I investigated the magnetic energy of Earth, and I found that to be 8 by this amount of joule. It's going to be published in American Physics Teacher this year. It's accepted since summer. And I published also a second work for the magnetic energy in Earth's interior, only because I wanted to see what is the total amount of energy and if it is adequate to replace in the very, very future the cars by electromagnetic cars, as the Taiwan people say. You know, of course, the Eric Way, the experiment here that is attributed to not mutation, to precession, and I gave all mathematics on that. You see here the word internal propulsion in an encyclopedia here, a propulsion system and so on. Also, there is a successor of lathe-weight. It's William Stoney, who has developed a machine and another machine, but he didn't like to show it. He applied for a patent. Here you see here a system. It is the idea of lathe-weight. He knew him very well, and I think he has all the equipment of lathe-weight in his lab now. Some activities by Mike Gamble, who is a member of yours. Mike has published two papers on the gravity. I met him in 2010, and we talked about for 5 minutes. So next year we publish together a paper here under the auspices of his company. And we published also a paper in the International Journal of Applied Electromagnetics and Mechanics. My thought was that if we have a rotating bar, I tell you how I lost Nobel Prize here. Well, when we have a beam and we exert a heaviside force, we have elastic wave that is reflected. And what happens until the wave reaches the ground, the force here is zero, then it becomes double, and finally zero. So we have a duplication of the force, but in the half time. So I thought if I could give a pulse with zero force from here to there, that is 1/4, and then in this part, that is half of the rotation, would have the double of force, of course, by 1 sinus, okay, and then zero here. So I could rectify this force, and Mike did the same in electrical terms, but unfortunately we lost the Nobel Prize because it's impossible to do it, because there are the Coriolis forces that we don't understand them in principle. I had to spend days to understand that it was not possible. Mike has measured that when we have two scissoring gyros, there is a force, a lifting force, that is not zero, although the time variation is that, the mean average is a positive number. So he insists that there is a thrust, and he has made some experiments. I cannot judge him, but I think that it is because there is one support here. So he measures here, but there is support there. He continues his job with a flying saucer. Here you see here, I think there is one more presenter on that. Now, some Russian activities I have collected from internet. Here is the Pravda, a newspaper. They speak here about that they started in June, July 2008. They refer to inertial propulsion, as you will see later. The inertioids, this is the Russian word for the inertial propulsion device, and they called it Kravitspaya. I don't understand the system, but I understand that there was a contradiction between the academics and the people who were in favor of the system of these devices. In any case, they spent money of that, and they say that it was sent in orbit for demonstration of the inertial propulsion. Okay. Also, I have seen some devices in Russia. It's open publication here, DOI here. You see here this device, and this device here that is pulling something heavy, but a lot of people working. It is inertial propulsion. I don't know what there is inside. Nobody knows. Also, you can see here this device. Mike says that it flows. It's a combination of magnetic field, and I don't know exactly what happens, but it's true. It's only the cables here, electricity, and it's in the air. Also, there are some practical application of inertial propulsion by the Professor Lukanov, who comes from Bulgaria, but he was a professor in Botswana, where he used the contra-rotating masses here to for building a pump for water, and also he developed some cards. But this is of practical importance to pump in water. And another topic is that it's not inertial propulsion, but it's very related. You will understand why I say that. I refer to it. You know, the paper by Forward, the guidelines to anti-gravity. What happens here that when we have a massive ring that rotates, except of the centripetal forces, if we put a mass here, we have also an axial force. This is based on the theory in Lenz papers, and there are two papers much later. One is for Martin Thermonuclear in Acta Astronautica. It's 2010, that he using the frame dragging effect that is very weak, of course. And Marco Miles, 7 years later, in the same journal, he talks about inertial frames and breakthrough propulsion physics. It seems that only general relativity is capable of giving thrust. But okay, there are also some activities in universities. This is in the University of Cornell in cooperation with NASA. They developed a polygonal inertioid, let me say that in the Russian language because it is very short, inertial propulsion device that could could operate on Mars, on the ground, of course. You can find it also in Zurich, in Switzerland. The University at ETH developed the Kubli. That is something similar, I think. I have seen something that it moves on a rope in this way. But there is something under the subject. What has impressed me too much is the work, is the paper by Wisdom from MIT. It's 2000. No, it's a mistake. It's 2003, I think. I think it's 2003. So it's 21 years old. What he says is that based on relativity, I suspect on general relativity, if we have cyclic changes in body shape, but in this position we can consider a dim drive, for example. He says that we have forces, but I think the forces should be something like that. And the force, and he says the curvature of space-time is very slight, so the ability to swim in space-time is unlikely to lead to a new propulsion devices. So this is our case. I think it's very closely related to our topic. And then he says that for a meter-sized object performing meter-sized deformation at the surface of the Earth, the displacement is of order 10 over minus 23 meters. Okay, it is very small. I suspect that Einstein knew it, but he never referred to it because it was too small. But who will answer my question? If in my device, who works in the conditions of wisdom, under high velocities, is there the case that I have a resonance between these two rotations? And if I impose this resonance, will the displacement will be of the order 10 over minus 23 meters, or it may be much larger? So I'm desperately looking for a co-worker on this issue, but he must know general relativity very deeply. I cannot do it. I asked the assistant of Martin Timer in Germany, and he told me that, okay, you can find a student to do it, but it's not that easy, I suppose. So that was the main part of my talk. I have some slides after, but this is the machine. This work has been done very near to Acropolis. And I thank you very much for your listening.
Oops, sorry, I was not mic'd. Chris, let me see. I'm going to remove the slideshow. Thank you so much. I'm going to bring everybody back in here, bring the whole gang. Everybody, please put your hands together. Give a giant applause to Mr. Christopher Provatidis. Thank you, sir. I genuinely appreciate you sharing that. We have about 7 minutes for Q&A session. Again, inertial propulsion devices. There was so much. I appreciate you covering so many of those. There's massive scope involved there. Does anybody have questions? Do you guys have any questions?
Yes, I do. Yes, I do.
Andrew, go for it, sir.
The several questions I have. Number one is that when you were talking about your configuration of your rotating devices, they seem to be dependent upon initial conditions, and it seemed to be a particular solution to the Lagrangian equations, not a generalized solution. And do you have any comments on that? That's the first question I had. The second thing is that when you talk about the displacement, the lens stirring effect and everything's destroyed, is the lens stirring effect going to be necessary and sufficient, or working with that necessary and sufficient for set up to say small propulsion or something like that, or is that impossible?
Yeah. Well, I was expecting this question. If I didn't put all the mathematics because it will be very very boring. You can find in the paper that is in preprint.
Certainly.
Yeah. What is the problem? The problem is that when you have a mass, a rotating mass, when it is in the lower part of the circle or the upper part, the velocity is horizontal. So the projection of the velocity to the normal axis is zero. So the change between these two positions of the linear momentum is zero, because it is 0 minus 0. So it's not possible for masses rotating on circle in the Newtonian perspective, of course, to give thrust, because 0 minus 0 is 0. That's all. So nevertheless, when I hold a cart with rotating masses, I feel some vibrations because the centripetal forces are giving force in upwards and downwards. But we need a support, and when the force is maximum, if we leave it, of course, it has the masses have velocities, upward velocities. So until they go to the normal position where the components are horizontal, so the change from here to there is maximum. This difference of the momentum is taken by the cart because of the conservation of linear momentum in the vertical direction. But then they come back and so on. So I used 4 methodologies that gave exactly the same results. The first is to decompose the system in 3 masses, maybe 5 masses, because it is the cart, the rods, and the masses. 2 masses, 2 rods, and 1 cart. I wrote all the equations like a student of the college, or the first year college, okay, in physics, and I received the final equation. Okay, then I did the same using the center of mass. I applied the Newton law for the second on mass. The sum of the external forces equal the total mass multiplied by the acceleration of the center of mass. Then the result was the same. The third approach was to take the conservation of linear momentum. The result was the same. And finally, I took the Lagrangian. That means not the Lagrangian of the physics, as you know better than me, but what we use in mechanics. I am a mechanical engineer. We take the total kinetic energy minus the potential energy, only mechanical, and then we take the partial derivatives. That's all, and the final was the same. So I'm entirely sure that my equations are correct, because all these 4 methodologies give the same partial differential equation that can be analytical solved in this simple case of the DIN drive. It's a simple case. So the theory land says something else, because we don't have Newtonian mechanics. We have geodesics and things that I cannot understand. I know tensor analysis, but not so deeply, not Ricci and things like that. I need a co-worker in this area. Although I understand, but I cannot go deeply. There, due to the geodesics or something like that, we have the axial force. And only that is the plausible, I don't know if the word is correct, the most promising way to give thrust without having expelling material. Maybe if we have ions or things like that, of course, there's something leaving the system and gives the thrust. But if we don't have something leaving, only the theory of Einstein, or what is that, can explain it. I don't know if I answered you.
Thank you very much. It just caught my attention because I was thinking about the geodesics too.
Thank you.
I'm not special.
Well, no one is. No one really is. They say they are, but they really aren't. But thank you very much.
Yeah. Well, and so guys, we are at 2:00. Actually, it's Andrew's. We're going to have Andrew do a presentation now. So let me do this. I know this has been a short Q&A, but let's put our hands together one more time for Mr. Chris Provatidis. Thank you, sir. It was absolutely wonderful. Thank you for presenting. And actually, what I'm going to do is take everybody out of the studio, and I'm going to go. We have Mr. Beckwith. So, Andrew, thank you for. Let me see. Where is our? So you were talking about dark matter candidates from a non-SUSY process, and basically you were emphasizing a way that dark matter could be formed and potentially used for some kind of a photon axion
Possibly.
rocket.
That's an idea that was promoted by Scobie and other things, but not fully developed. And that was Scobie was thinking along those lines.
Yeah. So I put the paper up that you sent me. I hope this is the right one.
That's the right one.
Okay. Yeah. Why don't I take myself out and just let me know if you want me to scroll down?
All right. Well, let me just read it off. It said this is just meant to be an idea and concept. It's not a working device, but it was just an idea and concept. Hypothetical dark matter, Axion rockets, and a neutrino without SUSY problem. All right. We present dark matter candidates for non-SUSY processes and we emphasize how dark matter of roughly 100 to 400 GeV could be formed. As has been said about the photon rocket and Axion rockets, the presence of a magnetic field. Which will indicate that the emerging photon thrust would be comparatively greater for something like a rocket ramjet for interstellar travel. We assume that much the same sort of methodological procedures would be for an Axion ramjet could be employed for dark matter with perhaps greater thrust power and conversion efficiencies. So the key words are dark matter, photon rockets, and axions. Let me just go to introduction. We attempt to discuss the concept in the presence of dark matter and candidates for axion from non-SUSY processes in which we think that their discovery via the Linear Hadron Collider, once vetted and confirmed by LHC, could perhaps be relevant to a dark matter axion ramjet. Let me go to the second slide. Second one. Page 2. Page 2. Thank you. Okay. We conclude with the discussion that Koida, as well as Jury and Otis brought up alternatives as well as dark matter, which are also alternatives to the possible formation of sterile neutrinos without the use of SUSY. What the author brings up, since the ramjet model is brought up as assuming hinges upon dark matter as far as the propulsion protocol. Now, what can be said about axions? The author estimates that at near light speeds, the available axion power would be about 3 watts times that particular record. Beta times gamma squared, where beta is the velocity relative to light, and gamma is the square of the relativistic mass increased factor. At a velocity of 99.9% C, the available power from actions would be about 1,500 watt centimeters squared, enough power for a modestly efficient space drive. And the faster we go, the more such power becomes available. Note, though, this is a long way from saying that we are having a viable interstellar vehicle candidate. We are saying that the principle that the photon rocket may be improved upon in the dark matter axion destruction by intense E and MB fields is an avenue toward making a more powerful photon rocket. We are leaving as a full-blown R&D project the feasibility of obtaining actions in dark matter as a part of phase transitions in the first place, which will the last part of our article. Actions are one component of dark matter we'll bring up. So anyway, the axion rocket concept is the modus operandi. A large magnetic field in a chamber can change actions to giving photon components. Let me repeat that again. You have a large magnetic field which will be changing a dark matter candidate to photons. Use constraints upon the mass we carry. We favor the concept similar to the Axion ramjet for interstellar travel. We could find The ramjet has greater thrust than the photon rocket and better than the Axion rocket itself. Using propulsion candidates, some of the dark matter may provide a way to gain further improvements to the Axion rocket, which in itself, as a ramjet, is an improvement over both the simple photonic rocket and the Axion ramjet rocket. Reviewing the highlights of the IDM 2008 talk, abandoned dark matter candidates leading the present candidates for dark matter. That's a question. We in this session give reasons as to why the particular candidates for dark matter we will invoke were used. And we discuss why some of the baryonic and non-baryonic candidates for dark matter have recently been abandoned. Next slide. Next slide, Tim. Thank you. We will define some of these candidates. The first of them is macho. Briefly put, an MACHO are dark matter candidates with mass at 1/10 of a solar mass. Well, that's not going to work. And what is known as the gravitational lens phenomena eliminates them as a viable dark matter candidate. So machos were eliminated. Next, we look at what is known as the standard sterile neutrino of the dark matter candidate. The idea being that sterile neutrino with a mass in a KEV range may answer some dark matter problems. Okay, so really what we're talking about is what is known as transitional neutrino masses as warm dark matter existed would interfere with the structural formation of the early universe. So the idea was that, well, could dark matter be composed of what's known as warm dark matter? Well, in the case of doing that, what you do is that you would no longer have the observed structure formation that's seen, say, in the first something like million years of interstellar evolution after the Big Bang. So what about champs? What is extraordinarily rich, that's also too was eliminated. Champs specifically measure champs, specifically massive charged dark matter candidates, are largely ruled out due to next page, Tim. There is excessive mass and also due to energy levels between 1 to 1,000 TeV. And so there's a paper by Tassos and Bologna and I can't pronounce that name, in 2008. The main objection is that champs had many similarities to heavy hydrogen. Well, that's not going to work. Well, still though, if champs are negatively charged, they may have bound to iron and other elements to create supermassive varieties that could effectively could be detected by their weight. These elements may also absorb and emit telltale X-rays that could be observed by telescope. Well, no, that didn't work either. So let's go to the fourth one. Meissner, Nicolai extending the standard model. With classically conformed Lagrangian at the usual Higgs doublet and one extra weak scalar field, this leads to a statement about the existence of the so-called Majoran candidate for an Axion candidate without invoking SUSY. So you have a scalar field equaling to an initial configuration times an exponential I A of X over the square root of 2 nu. The expression of A of X is a pseudo Goldstone particle associated with spontaneous break and renew global symmetry. And the A of X shares properties with the axions, partially due to conformal symmetry, eliminating the existence of conformal Lagrangian contributions. So we get masses like neutrinos heavier than the SUSY neutrino mass, but having the same branching ratio. Okay, in our treatment of the problem, we assume that Meissner and Nicolai are almost right, that the axion is 10 to the minus 4 times the rest mass of an electron in GeV values. But what they have calculated is close enough to be still with value and merit to review. Okay, so next slide. next slide. Okay, Meissner and Nicolai worked with a classically deployed Lagrangian model, and I just I write that what that is. That has a standard model minus a term which to the second power, and then to the and then another term. We begin first with the interaction Lagrangian with the usual Higgs doublet, an extra weak singlet complex scalar field phi of x. We minimize the effective potential varying values of the effective coupling constants, phi 1, phi 2, phi 3. And it's 1.447, 06, 48, and 0871. And those are put into the equation 2 in terms of phi 1, phi 2, and phi 3. We also consider zero expectation values to remove the O6 symmetry, would lead to these values, and that's right over here stated: phi 1, phi 2, phi 3, G, and then that other term, and we have numerical value. Then we work with H equaling to the square root of phi star phi, and deal with the case where phi carries lepton charge. Well, let me just, if this is going to go above the tolerance of the conference, let me go to number 5 directly. Parameter space treatment or to isolate a dark matter candidate. Meissner and Nicolai eventually attained the following average out parameter space values, namely, next page. Next page, thank you. So this is what they obtained. The value of M equal to 477 GeV is the very upper limit of dark matter candidates, was brought up by many IDM 2008 speakers, leading to what the author numerically estimated a candidate dark matter candidate to be of the order of M, which is greater than 400 GeV. This upper value is the specified dark matter mass, and Hooper and Fermi National Labs specified the indirect detection schemes for dark matter, leading to a mass range for WIMPs below 200 GeV, with dark matter WIMPs being greater than 200 GeV, leading to a quark and gluon decomposition decay of the WIMPs. Okay, now let's go now to the but anyway, though, roughly the concept between 200 to 400 GeV for something like that might be a candidate for a high level dark matter particle mass is what is brought up right over here. First, principles of an axion ramjet. We should state specifically we are now thinking of converting an axion to dark matter particles to either interacting them with the magnetic field into photons. We are improving upon the specifics for a photon rocket drive. Currently proposed photon rocket designs include the nuclear photonic rocket and the antimatter photonic rocket, first proposed by Sanger in the 1950s. In a nuclear photonic rocket, a nuclear fission reactor is used directly to heat tungsten coiled or graphite blocks to white heat at the focus of a parabolic reflector. While using the lasers produced, the light beam would produce much better collimation. This is offset by the reduction of the efficiency incurred by powering a laser rather than using black body radiation directly. All right. Now we can talk about a photon rocket in terms of destruction of dark matter / axions via intense E and M fields. All right. Next slide. Next slide, Tim. Next slide. Thank you. Castanetti said it'd be about 100 times that. So we can only talk about a ramjet engineering construction, i.e. scooping up axions, dark matter from the interstellar void and using that as a fuel source. So how we get around it? It happens that the mass beds as obtained above and the author's IDM 2008 presentation of several hundred GeV is the only way possible to get the high frequency. As can be inferred from Skilby in 1983. Every axion, when converted to a photon with the same total energy and go in the same direction, produces a momentum kick, and it's delta P equaling MC times gamma 1 minus beta. M is the axion rest mass. If we take a swap between axions and dark matter, use the mass of 700 GeV as the starting point due to the calculations we referred above, and avoid the absurdity mentioned in the Wired article. Do not think of carrying fuel to the stars, but use a ramjet modus operandi. We can possibly think of obtaining a working upgraded photon rocket, which would improve our chances for greatly improved space propulsion. For a dark matter rocket, it's a dark matter. Some of the axion properties, this would likely mean working with velocity nearer to 0.1 C. The main point of all would be confirming a viable candidate for the dark matter that would be used in the momentum kick, which is equation 6. All right, now, which is, let's just get to the real point. The real point is the main point, confirming a dark matter candidate for a dark matter particle. After we confirm some of the dark matter physics, would begin a realistic propulsion candidate, so we can get the ship in order of magnitude, at least a craft going to 0.1, something like 1/100th the speed of light. And that's what this is all about right over here. Furthermore, before we do this, it would be helpful if we confirm the prediction given by Meissner and McCullouch in 2008, namely the coupling of a Meissner axion candidate, the photons of in the order of, and here's what they have right overhead. A frequency is 10 to the 12 GeV. As energy release is handled appropriately and for a dark matter candidate, will improve the so-called axion ramjet energy figure. An extension would begin to yield a more practical candidate for improving the efficiency of photon rockets and or ramjet based upon axion conversion via strong magnetic fields into a powerful light source beam. Conclusion. Our short article is focused upon several themes. Okay, first of all, is a mass of about roughly 400 GeV per particle. That would be tie-in with equation 6. Okay, that's really the main point right over here. And secondly, which is that we're only going to talk about going 100th the speed of light, but that could be done if you have an interstellar medium with many dark matter candidates, something that could be going on quite continuously. In other words, we'd have to go beyond the Kuiper belt. All right, now next page. All right, lots of engineering to bound here, but one of the biggest one, an axion that has a mass of about one. Here's is it. Axion has to be a lot smaller than electron mass. There has to be about 500 billion of them in each cubic centimeter space in vicinity of the Earth. More cc near the galactic center, only 200,000 per cc in intergalactic space. Figuring the dark matter candidates 10 to the 8th larger in GeV mass than electron. Okay, which are in 10. So anyway, that's what the problem is that you have to just find out in interstellar space, would there be enough dark matter candidates that could be put in a ramjet. And the ramjet would, in essence, if you use magnetic fields and everything for it, improve upon the photon rocket. And the photon rocket would be a way of having a continuous drive to say between Earth and Alpha Centauri. That's an example of it. Further considerations. It's important to keep in mind that further investigation of dark matter candidates are imminently feasible. We're still working on it. There's a whole range of them. And the idea is to go to equation 6, where you have delta P being the change in momentum, and you would have an appropriate value of M times some other factors. So in other words, they have this idea so that you could get a candidate momentum put in would be enough so as that you could get a vehicle going to maybe something like 1% the speed of light. But you have something that's going 1% the speed of light, it goes between Earth and Alpha Centauri or something like that. You'd want to have something that's continuously operating. This had the chance of doing it. And secondly, you're not going to have an interstellar ship or an interstellar craft with fuel stored in it, independent of the space-time medium, which is going to get between here to another star. Forget it. It's not possible. That is the basis of my talk. The idea is go back a slide. One slide back, please. One slide back. 10. Equation 6. Let me go over this again. Delta P MC times that proportion, that basic proportionality factors, and the delta P, which is the change of momentum, is dependent upon, for practical utilization, M being the axion rest mass. And this is essentially the basis of my talk. It's in one sense extraordinarily simple. So the idea is find an optimal mass for M. Put that in so you have a momentum kick. And if you would do that, then what you would have to have very heavy duty engineering. And the engineering would be you take a axion, which would be in a chamber. You put a very intense magnetic field upon them. These would change into photons. And so you'd have an improved upon photon rocket. And this is the basic idea of my talk right there. I don't have very much more to say. I'm now opening up the floor for questions.
Okay,
Andrew,
thank you.
For questions. Anyone can ask me questions. If I can answer them, I'll try to.
I'm going to bring everybody in here. Everybody who's got their camera.
I'm sorry, I made people go to sleep.
No, you know what? That was wonderful. That is an awesome big idea, right? I mean, so just for like the people in the audience,
the
when
idea
you sent me
really
that paper,
is
you're like,
you have to find an optimal axion mass candidate.
Well, let's do this. Everybody, put your hands together and give Mr. Andrew Beckwith a big hand for a tremendous idea. When he sent me the paper, it was like dark matter axion rockets, and I was like, I'm in. I was like, that's it right there. It's like, I don't know how it works. I don't know what it does. I was just like, that's the coolest sounding title ever. So, yeah, if you guys have any questions, and this is pretty intense stuff. So the only person who might have, I don't know, Dr. Chester, would you have any questions? Because
I was curious about in section 2 how you estimated the power. Were you assuming that all of the dark matter?
I was just using Scobie's formula. Scobie's formula was that I was just talking more about a momentum kick, about an actual power and other things. It would depend upon the relative efficiency of transmitting something like an axion candidate introduced to a magnetic field, and how that would be changed into a light power source. So in other words, it'd be an enhanced photon rocket drive.
Okay, yeah, I was just asking about the earlier thing.
No, I know that. I'm just trying to give you a straight answer.
Well, I don't. Okay,
I'm sorry if that's too vague for you, but I'm trying to be very specific. David, if that's too vague for you, I really apologize. But what I'm saying is that go to the papers that look to so-called photon rocket drives. All right, and the idea, is that what they were trying to come up with is something sort were ridiculously low trust values. So the idea is that if you could, though, what you might call axions, and put into an electromagnetic chamber, is that you would actually get a greatly enhanced photon rocket drive. So the idea is that you would first of all have to confirm the mass of the axion. That's number one. That's the reason why I went through the so-called different candidates, and there are a lot of them. And then secondly,
there's a lot, yeah.
Right. There's 5 of them, which I went through.
Oh, there's way more than that, I bet.
Well, there are 5 of them. All right.
I mean,
So then
there's a
the
lot of
idea,
papers on. There's a lot of
yeah, I
ideas on the
know. Well,
mass
there
of the
are a lot.
axion.
There are a lot of candidates, but then the thing is, go to the papers that are many of them which are out there, which have to do with like a photon drives or photon rockets, and these things have ridiculously low thrust. In other words, it's just simply, it's just almost like forget it. All right. So, but the idea though is that you maybe get something like about 100 to 1,000 times more powerful than a so-called generalized photon rocket. That's what the photon drive. That was the idea.
For
Now,
sure.
Aside from that, though, the physics of the entire thing was I talked about just putting all the physics. I went to the dark matter candidates into that term M. You mean delta P M, and then you'd have this other stuff which is put on there, which is coefficients were put in. This idea was actually even brought up by Scobie.
Okay, so are you assuming that all of the dark matter in the universe is the axion of that mass range you're referring to?
That's actually one of the more current theories, because that the WIMPs are not getting very good treatment, which is that the WIMPs are becoming increasingly disfavored. And one of the few surviving ones that actually exist are things like axions. Axions perhaps with other candidates, but WIMPs itself, people have been trying for something like over 20 years to come up with WIMP detection, and it just turned to a hole in the ground.
Okay.
It's been dismal. It's what I'm trying to tell you, is that the search for
it's been difficult.
Yeah,
everyone's looking where the axions aren't rather than where they are.
Over $3 billion and come up with no results.
Yeah. No one's trying to find the axions. They're trying to rule out where it isn't.
They're going through a whole bunch of, axions are a certain class of axions, may be about the only candidate that hasn't bombed out yet, but the other ones have. And the other thing also too is that Susie is in trouble. Is that people have been, like Winos, Fotina. I could go through the list of the so-called Susie particles. I know what they are.
Yeah.
I know what they are, and other things are. Guess what? At the LHC, no results.
Yeah, they're not going to find them. They don't exist.
So in other words, what I'm saying is that you're probably just going to have to toss out the Susie, which is going to make a lot of theoretical physics people upset. Well, too bad.
There are ways to actually get the standard model with supersymmetry without the super partners, but that's a very subtle point.
That's exactly right. You hit the nail on the head. That's exactly right.
I'm just thinking that I want $3 billion not to produce results either. I'm going to use the LHC to hunt for unicorns and gremlins. And
well, that'd be great. Anything is right. We need some fresh thinking, because we've blown an enormous amount of money. The axions are about one of the few surviving candidates. Susie has just been a colossal waste of time, and they're just going to have to do something else other than Susie, and that just is top. And then the idea is that the even reason why I brought my idea up was just simply because of the fact is that the photon rocket, as it's been initially configured, is a joke. Just in the initial configuration of it. But also, too, they had experiments for axions called the light shining through a wall and other things which are very interesting. And,
that would be interesting.
That's one of the few things but why are we even discussing dark matter in the first place? Well, we still have the galaxy rotation curves. That's not been gotten rid of. The galaxy rotation curves and Zwicky, which said in the 1930s, makes a pretty effective, good case that you probably should have some form of dark matter. But all the so-called dark matter candidates, except for axions, are just simply no detection, no results. So I just said, let's talk about the one that hasn't been killed. And so that's number one. And number two, then talking about the so-called photon rocket. It said, "Come on, guys, you want to talk about having a flashlight in space?"
Yeah.
Because
No,
that's
no,
about
those are,
that's about the value of them. It's about a flashlight in space.
yeah, they're pretty weak. They're pretty weak.
It,
And,
it, it's just that it's asinine.
yeah.
It's implied, so to speak, with rhapsodizing about the Dean drive. And the Dean drive just simply, well, unless somebody comes up with something I haven't heard of, it's just something appears like it's going nowhere. Appears. I'm not saying it has gone nowhere. It appears to. So
Well,
what's left? Not a lot of candidates.
Yeah. So Andrew, we're about half an hour ahead of time. I wonder if, and I think, I'm not sure. Do you guys have any more questions? What I'm wondering is if we might want to fill in with some lab time or something along those lines.
Well, I can say a few things about dark matter, which itself actually have been verified. It take about 10 minutes.
Sure, go for it.
All right. Well, first of all, the number one is that the WIMPs, and also Susie and the candidates, and it has just been a complete total. Someone's trying to call me. I have to shut this thing off. Sorry, it's my phone.
Well, here,
Yeah,
let me put
I
everybody
know
back
who it
up.
is. I'm
Actually,
waiting for it to shut up. Okay, it finally went away. Thank God. All right. I'll just ignore it and hope it doesn't bother you. Okay. WIMPs have suffered because of the fact that what they tried to do is that they tried to go into the LHC. And when they went to the LHC and searching for WIMPs, is that they went to Atlas and they went to other things that went to all these very elaborate detectors and other things of the sort. And then the thing is that it wasn't the case of the search for the Higgs particle. For the Higgs particle, they were actually able to get confirmed signals that actually were zeroing in upon a standard mass that would be appropriate for analysis. And so they came up with something fairly quickly. The exciting thing would be if the Higgs mass would lead to new physics. Well, that's an open question about how you generate mass in the universe. So that was done, and that they had an active program, which they had a series of findings, very specifically, a series of findings that indicated where to go. And as a matter of fact, is that when the Higgs was found in Geneva, which they went back to Fermi National Lab, and they found out that there were weaker but specific possible findings of the Higgs particle that occurred something like 5 years earlier before Fermi National Lab was discontinued. In terms of what we've seen about Susie, about WIMPs, and other things of the sort, is that we had findings which basically contradict each other. In other words, the detectors don't work as advertised. As I've been to dark matter conferences where people would be talking about, oh, we have the detector A, B, C, D, and we have all these rare. One of the things that they were talking about was, let's fill a container, so to speak, was a really rare gas, and hope that something, we put it way underground, something like 10 miles underground, we're going to see some sort of a track that we can determine is similar to a dark matter candidate. Well, no results. All right, no results. The only thing that hasn't been axed out of existence has been the axion, or variants of the axion. So that's what's left. So most of the field essentially died out.
I mean, there's other descriptions of dark matter that haven't. I mean, the axions haven't been found either. It's not like the LHC found the axions, but I mean, there's a lot of good motivations for why the axion might exist. I can agree with that, but at the end of the day, we still don't know. I mean, there's so many papers discussing what mass it might have. It's hard to tell.
That's also true too. You always wind up what's called the needle in a haystack problem. But I think you will agree with me, though, that WIMPs have essentially been a no-show. And of course, it's the things like the so-called, they had the very heavy dark matter candidates, or the equivalent something like you people were configuring these might be dark stars or something like that. And I went to conference where people seriously discuss that. And then, which is they applied gravitational lensing, to these sort of data, look at what you about a data set, results. On the other hand, you really do need to have something like dark matter because the galaxy rotation curves tell you that you need something, because the galaxy rotation curves only make sense as you have a much larger mass than what actually is figured to say by so-called baryonic matter. So there's something out there. But we'd had a record of several decades of failure as to trying to find out what it was. And then it gets really interesting is where they're talking about combination of cold and warm dark matter to account to what you might call the halos about what you might call the dwarf galaxies orbiting the Milky Way, the Andromeda Galaxy, and all that, and all very interesting and good stuff. And I was actually thrilled listening to it. Well, the situation is very contradictory. That the results conflicted with one another wildly. So we have work to do. So there's a solid gravitational anomaly in terms of the way galaxies rotate and everything. So we need dark matter.
What about modified Newtonian
we've
dynamics?
not had any luck in terms of really narrowing down what it is.
There's other people that think modified Newtonian dynamics or something like MOND.
I heard that one
as well.
Oh yeah, like MOND.
Who knows?
MOND's actually very interesting, but here's where the rubber meets the road in terms of MOND. Is one of the things that comes up, which is they had this idea about this so-called acceleration of a space probe that's going faster than what it should be, according to general traditional type of theories and other things of the sort. It's one of they're talking about all sorts of so-called gravitationally strange things that are happening in terms of interstellar probes and other things that we shot off. Well, guess what? Which the MOND doesn't fit. It doesn't mean it's completely bogus, but we have a lot of work to do. I'm not saying MOND's wrong. I just am saying it's incomplete, and we have a lot of work to do. I'm going to be going at the end of March. I'm going to be going at the end of March to a cosmology conference in which I guarantee you that there's going to be a floor fight between people who are working on MOND, who are largely French astrophysicists, and I know them. They're very interesting people. I know them. There are about 7 to 8 of them who in Paris, in the University of Paris, in France. And so they're going to go, and so there'll be a floor fight for at least a day between them and the other people on this. So that's the interesting thing that we have here. All these ideas are very interesting, okay? But I really hope that we get into at least exploring the solar system, because I'm going to say something right here, David, and you can tell me if I'm wrong. On my phone again, I'll just shut it off. What is interesting, I think that our solution to a lot of mathematical equations are incomplete, and that we have a lot of work to do to find that we have optimal solutions to the equations of the laws of physics that we are working with. In other words, if we go into space, if we go into something like the solar system, we'll have to re-examine a lot of our so-called physical laws that we have, and that we'll come up with a situation which the physical, damn it. I know who that's a person in Maryland. They keep bothering me. Anyway, that many of our basic equations of physics are going to have to be redone in terms of solutions, is that the solutions are not optimal. Now, this is not just wild speculation. There was a simulation done about quantum chromodynamics, QCD. And the idea had to do, we were looking at solutions for common quantum chromodynamic problems. And the idea is you'd have a monotonic decrease and to say the power of the contributions and solutions that have occurred to a solution would put into the QCD equations. Well, what you would find out is something about term over 1,000 or 5,000. If you have something that's not monotonically decreasing but has a spike in it, where did that come from? What I'm saying is that if we get some proper engineering requirements to go into at least the solar system and have to re-examine what we think we know and rigorously do it, because pardon my crude language, our ass will be on the line if we don't do it right. We'll probably find out that what we think we solved in physics and in engineering are only incompletely solved. We need to rigorously solve this sort of thing. So one of the best things I could see about going into the solar system would be a requirement. Let's take it out of these theoretical parlor games. Let's try to cite these equations of engineering and physics, because our lives are going to depend on if we're in the solar system. We're going to have to do it right. And I think a lot of what we have done is only incomplete. And I'm willing to have the floor here tell me I don't know what I'm talking about, but I just simply, that's my gut feeling. We have a lot of work to do.
Well, there's always more to learn.
What?
There's always more to learn.
That's an understatement. That's an understatement. I think once we can go into the solar system, what we will find in the solar system will be that we will really begin to learn what we actually know and what we don't know in terms of engineering and physics, and it will be a shock to some people, but it would also be a good thing. I'm looking forward to that. That is, don't die of old age first. I'm almost 70 years old, so that I probably only have about a decade left.
You're doing well, Andrew. Now let me ask you. So you have been teaching in China, and you're back in the U.S. now, right? But are you going back to China?
Yeah, but I'm going to go back there probably about in the latest would be in the summer. But I'm going to go back. Oh, in China, what they're interested in? They're interested in Fangyu Li's one thing that's been going on. Fangyu Li had the program for high frequency gravitational waves.
Yeah, and you said that COVID had caused a lot of trouble with that, right?
What?
You said that COVID was disrupting the Chinese research establishment.
That was one of the problems. The other problem is that their economy is not very stable right now, which is that they had essentially what happened is the 70% of the so-called expenditures that could be spent upon science were negatively impacted by, of all things, the fact that their housing market has collapsed.
Okay.
So in other words, the housing market collapse in China has been so bad that what's happened is the expenditures, to say for science and other things like that, have suffered. It's called, they had, it just collapsed, Tim. And so the question is that how much is their central government going to maintain towards scientific exploration and scientific inquiry when what you might call, you have something like about 300 million people who may not be able to have housing because that, essentially their housing market is much worse than the United States right now.
Do you think that Fangyu Li's team might be interested? Are they able to work with like the APEC conference or scientists in the United States?
I don't know. That's their decision.
Yeah, I wasn't sure.
That's their decision. Right
well,
now,
I know Gary Stevenson used to work Bob Baker and Gary both worked with them.
Baker's dead.
Yeah, I know. Baker
Baker died, and that what happened was that Baker died, and what happened was that Gary Stevenson right now is not really active in research. He's primarily doing He's primarily developing things for flying cars.
Yeah.
Well, I know about that one. He's in a flying car company, and he might become very rich because of it. But which is he doesn't have a lot of time left over for other things. And the situation is that yes, they would be interested, but is it right now, which is the main problem? Is first of all there was COVID, and it actually killed people in China. Some whom I know died of it. And I don't want to go into the details, but it actually occurred. There were deaths in China over COVID, and this disrupted a lot of scientific teams in Chinese universities because the COVID epidemic in China was about 5 times worse than the United States. It was awful. I will tell you that. Secondly, after that, the second hit has been going on in China has been, as I said, is that the Chinese money that would be available for science research and R&D and other things is being negatively impacted by the fact you have maybe up to 300 million people out of 1.4 billion. 300 million people might lose their housing. They have an awful situation now with respect to it's awful.
Yeah.
So, and the other thing, which was I've been in a position being a visiting professor in China. I only got my spot because people liked me personally. I got along with them. On the other hand, the situation is that when you have something like about the 300 million people may not have adequate housing, That's what the figures are, and I'm not making this up. It's up to 300 million people in that country may lose having affordable housing. What are they going to do?
Yeah.
Well, they're being squeezed.
Sorry, I just got back. Why are we talking about affordable housing?
I was asking about the Chinese gravity research establishment. One of the things, so Andrew, who's been teaching in Chinese universities for quite a long time, and he's worked with Dr. Fang Yu Li's team, who had worked with Bob Baker and Gary Stevenson to a lesser degree on high frequency gravitational waves. And so one of the challenges has been over the last few years, especially because of COVID, as well as some of the international tensions, they really got separated. And it's been a tragedy because there was a wealth of really amazing research that was being done in China, and it's just been difficult to communicate with them.
It's been very difficult. It's been very difficult, and they're not the only ones. The Ukraine war has absolutely devastated Russian physics, and Russia was doing actually some pretty decent physics work. Got dynamited because of the Ukraine war. And well, we have other things of the sort. And frankly, I don't like to say this, but CERN Geneva is running out of ideas. CERN Geneva is running out of ideas.
Well, they discovered what they were built for.
Well essentially,
atom smashing, right? Still.
Well, they're doing it because they can do it. The joke
it was built to detect the Higgs. They found it.
The joke in Europe is that we have CERN, so we can go back to CERN whether or not that we actually believe the results is still there. That's pretty sarcastic, but to scratch under the surface, and I go to Morion. I'll be in Morion at the end of March, and what's happening is that they're continuing their projects, but they don't really believe that they're going to come up with breakthrough results, and that's what the problem is. Is essentially they keep on doing it because it's agreed upon.
Well,
the European, they're in an uproar.
Andrew, to your point about as exploring the solar system and new physics, so there is, I'm forgetting the name of it, the Roman telescope that's going to be deployed in a few years. That's going to be the successor to the Webb telescope. They're going to use, I believe it's the Nancy Grace Roman Space Telescope, and it's an optical telescope, if I remember right. They're going to use that to try and detect potentially habitable worlds. And then there's actually another one being planned, and I believe it's called the Habitable Worlds Observatory. That's going to go.
I know that. I know about both of them.
Yeah, and so I'm excited about those because even
I am
if
excited about it too because it
yeah,
might get people out of a rut.
that's my thought, right? Is that sometimes you have to, diversify to other areas, right? And so with mainstream physics, when it pushes forward and hits a wall, or like you're describing, maybe some of these other
For over
things.
30 years.
Yeah, yeah, sometimes inspiration comes from strange places, and, I mean, to pick on Shiva was talking about a hydrodynamic model of physics a couple of weeks ago, and I
Yeah.
think things like that are really, really interesting as well, right? Just alternative models and alternative approaches that yield results,
I don't
so.
have a problem with that.
I dropped a couple of links there in our chat that, on a fluid dynamic treatments of space that get rid of both MOND and dark matter. So
Oh, yeah.
we're looking at galactic rotation rates. There's a couple of different researchers who are doing research on that.
Yeah, it's well, and what you'd said about quantum states, right? And how they, how they essentially mirror ripples in a pond. And I know I'm mangling that. My physics is just progressively more and more rusty over time, but it's new perspectives and it's looking at the same things from new angles. And that, for me, that's really exciting because
Well,
that's where.
I'm just hearing again and again that hydrodynamic, chaotic, nonlinear quantum mechanical models, something having to do with superfluids. Just hear again and again that's something to do with it.
Well, I'm not disputing that. I'm not disputing that, but let me make a comment about the idea of the so-called the deterministic chaos. Just is that when people were looking at models of the deterministic chaos, what I did my PhD dissertation in condensed matter physics, and I used a so-called simulator, which is a random number generator, which had a C and everything but really was a pseudo random number generator. And so you'd have the idea of deterministic chaos. Well, to a certain degree, is that we really don't mathematically have a good theory about genuinely chaotic systems. We have something that's incomplete. And if you could actually fill that detail out and do it appropriately, then match it on to quantum mechanics and other things, so you might be able to say something.
Well, the
But
challenge,
again, I think that there's huge mathematical bottlenecks.
You don't need to have, the entire concept of randomness may just be a heuristic of the human mind. It may not actually exist.
That's true. I mean, just maybe very complicated order. But the issue there is like with Stephen Wolfram's models, is it computationally irreducible? Because there could be structure there, but if you can't get at it with a computer or pen and paper or whatever process, then effectively to us, it's beyond our ability to directly work with, besides statistics.
Well, that's where we are right now. But as I said, essentially, is that it doesn't mean that the models are wrong. A lot of our models of so-called physics may be better than we give them credit for it. But our solutions, the way we do it, especially computationally, may be very off the mark and other things. So it's just that we have a lot of work to do. And that's why I said going into the solar system, where we take away from so-called cute vanity exercises or something like this will save your life if you just determine it. It's going to mean, in fact, we're going to start to really find out what works and what doesn't work in physics and engineering things that are associated with space science. And we'll have to know.
Andrew, another thing that I'm really excited about is as artificial intelligence moves forward, and we're already starting to see this even with ChatGPT, with its many flaws and its inability to really do math. What we're seeing is it's able to search and find concepts and find relationships that are just in such a vast expanse of knowledge that the human mind can't do it, right? And so
that's also true too.
yeah, but then when you think about it, especially when it comes to mathematical formulas and the history and all the things that go into it. I mean, so you have a PhD in physics, David has a PhD in physics. I mean, when you think about the amount of time and energy that you've spent studying for that, and still there's a limit to scope and depth, right? That's based on the human mind. And so if AI is able to augment that, it may be able to do things like create reducible formulations and, potentially find solutions.
I'd heard people discuss that, but then there's a problem with AI. I'm going to tell you what it is. I'd heard, and I'd had conversations with AI researchers on this, which is AI cannot duplicate human creativity. It comes close to, but it doesn't do it.
Yeah, it can't make that leap. I think that's what you're talking about. There's the leap
Yes.
that it can't. Yeah, and that's
It
Einstein.
doesn't make
right there.
there's a basic biological component toward the actual human creativity, which is not covered by AI.
But
AI comes
then,
close to it, but doesn't actually do it.
but for physicists though, for like yourself and David, again, if nothing else, that would give you one heck of a tool to use to guide that creativity, and it would let you get more mileage out of.
I am not disputing that. One of the things that could is if we don't kill ourselves off in the next 20 to 30 years, if we don't kill ourselves in the next 20 to 30 years because of some stupid war or whatever we're doing, one of the things that I think would be very fruitful would be human AI, what you might call intermeshing, so to speak, which is the human brain used as something like being directly linked toward what you might call firmware.
Oh, I actually, if I could, and this is a little bit off topic, but I did an interview with an implant specialist. He runs a company that does implants, and one of the things that he suggested was things like Neuralink, even though they're not designed for it, just by connecting the human mind to a network, he
Yes, that's
believes.
exactly what I'm referring to.
Yeah, so what he believes is that because of natural neural plasticity, right, that's built into us as human beings, he believes that we'll start to unload processing onto the network, just transparently.
I'd heard that one brought up too, though. But what I'm saying is that judicious use of that type of cross-fertilization may get us to more complete and actually more necessary and complete solution to our physics equation, other things that we're working with. Because I can't believe that we had the final word about it, especially they had simulations on QCD, and they had something come out. You start seeing these spikes, and these spikes where, in other words, monotonically decreasing, then you have this gigantic spike that would occur. So, and well, its practical applications were very, very low in everything, because normally it wouldn't affect anything, but it could. And we have a whole bunch of things which are like that. So what I'm saying is that when we formulate solutions to our equations, we formulate everything, the AI intermesh and everything may allow us to identify problems like this that we right now are largely oblivious to.
Yeah, and that would be wonderful. Absolutely.
It would be wonderful, but you have to hope is that you don't. There are also problems in that too. One of the problems is that it's the other problem, I think, which is embedded in physics, is the idea supposedly of genius or something like that. You look for these lead lights and geniuses who call these great breakthroughs. Well, in other words, it's where the AI intermesh with human, and guiding force and everything. So we would see that there are logical stumbling blocks that aren't necessarily very obvious, that we could identify them earlier, so we could pick up, in some cases, the speed of innovation. And that would be perhaps a good thing. Another thing, which is, how many of you people have heard of Kurt Gödel in the incompleteness terms or you can't solve everything? How many people? Well, I really get off on Gödel. And my own rooting for why I would like AI to be a force is that we could do end runs around. I think that Gödel and incompleteness and other things and the problems it causes are due to what you might call, we don't see all the alternatives and other things and we get essentially ring fencing and boxed in.
Yeah.
And so that would be a value of AI supplemented with human intelligence and training.
Well, Andrew, we are at the top of the hour. I want to have the guys put their hands together and give you one more round of applause for
Well, I
a
hope I haven't
brilliant
been
and
completely
innovative
crazy.
paper.
Well, if you think I'm crazy, David, you're not the only one who said it. But I'm trying to be very practical in what I say, because I have seen people misuse computer solutions, especially in the post-Newtonian approximation in GR. I've seen abuses of that like for over 20 years, and it's sad. And I just hoping is that people just up the game.
Well, and Andrew, thank you again. I want to jump into Justin Pearson so that we don't cut too much into his time. But Andrew, thank you so much. It's wonderful to have you back. Again, absolutely amazing presentation. Thank you for spending so much time to help us.
Well, thank you. I did. I enjoyed the prior talk a lot. I enjoyed listening to you people. It's just that the only thing is that I'm elderly and I'm going to have to get some food. But I really got off and seeing you people at the conference. I thank you very much, all of you. Thank you.
Absolutely. Absolutely. Thank you as well, Andrew. Okay, Justin, we're 1 minute into time, but so you were going to tell us about the Aruba spaceport, and let me see. So for anyone who doesn't remember your first presentation, which I think everyone knows, you founded Baldwin Aerospace in 2017, which is an R&D business focused on hypersonic technologies. So your emphasis is on scramjet propulsion and hypersonic flight and lifting bodies. And you work with a diverse mid-sized team of aerospace engineers, but you are here today to talk about your recent trip to Aruba, which I am incredibly jealous about, as well as plans for a spaceport in Aruba that I understand you've been working on with some government officials down there. So, and do you have a PowerPoint that I could load, or do you want to just discuss it?
Yeah, I do. Is it okay if I just share my screen? Would that work?
Yeah. So I don't have anything up there. If you hit the present button.
Yep.
And yeah.
All right. Yeah, I'll jump into the presentation in a minute. Thanks for allowing me to speak, Tim.
And let me take myself out and let me know if you need help at all.
Oh, no worries. I know that the people listening to the conference prior to this meeting talking about some pretty important stuff like 0-point energy, inertial propulsion, dark matter. And I wanted to think about this talk, maybe this hour, as not separate from that conversation, but I always like to think of it as a fresh start because it's dealing less with the technology and more with the people. And towards the end, I like to think of it as setting up an aerospace industry. You kind of have a fresh start when it comes to Latin America, and I'm going to be spending most of my time talking about Latin America. I'll get into the presentation in a second. But there's also lots of ties to the US and Europe, and that's the exciting thing. So I'm going to go ahead and start sharing my screen. We'll jump right into it. Just let me know if you can see this, Tim. All right, Tim, can you see my screen without the notes? Tim, are you able to see it without the notes? Let me just make sure it's going good.
Okay, sorry about that, Justin. Let me see. It is not sharing yet. I think you have to finish clicking yes to share that.
All righty.
There we go. Okay, add to stage. Yeah.
How about now?
Yep. And now it is up.
Perfect. And it's the screen without the notes, correct?
Yeah, it looks like it is just a presentation.
Perfect.
Yeah, there we go. Macedon United.
Awesome. Well, I'm gonna be talking primarily about the Aruba Aerospace Port. I'll talk briefly about Baldwin Aerospace, and then I want to introduce you to two new companies, Noxender Labs and Macedon United. All the photos that you're going to see are actually from my most recent trip to Aruba. And I'll give a short introduction of where we're at today working in Baldwin Aerospace. Now, I will say that Baldwin Aerospace, a lot of the people actually provide a lot of support and consulting work to all the projects in Latin America. And the two companies, New Alexander Labs and Macedon United, could be thought of one as providing aerospace infrastructure and the other aerospace funding in Latin America. And kind of a side note, I'm actually planning to move to Aruba in the near future. And I think you'll see throughout this presentation, there's no real substitute, absolutely at all, no substitute for just being on the ground, working with the people, even moving to the place. So quick recap on what we're working on at Baldwin Aerospace. So as you remember, Doug Codron, my COO, we're presenting our most recent project, which is the development of the RDMS X-Jet facility. We are designing and then building a arc jet, and that's going to be built in 2025. But we are presenting our paper and simulations and process in the AIAA Aviation Conference in Las Vegas this July. And Doug, he had a background at NASA Ames and worked on the Mark I. And so this arc jet is very similar to that tunnel, but its goal is slightly different. The goal for this arc jet, as you can see the specifications here on the screen, it's to fill a niche market here in the US. And primarily that is supporting larger thermal protections, hypersonics, and material science programs. And then secondly, as far as like a goal for this arc jet, we want this to provide training for interested undergraduate, master's, PhD students and from universities all across the US. And so, from where we talked in our last presentation at APEC to where we're at now, we're still in hypersonics, and we're just building out our infrastructure, building our network, building, more importantly, the relationships here in the US to talk about things like MHD, hypersonics, and the like. So I'm really excited about this progress and this project. You can also email me any details or thoughts that you have. My email's on the screen. I can also send this to anybody. It's the abstract paper that we're writing for this arc jet, and our team is simulating now. So I'm really excited about that. So without further ado, I wanted to talk about the Aruban Aerospace Hub. And when I say Aruba, a lot of people don't actually know where Aruba is. And it's actually just a couple miles off the coast of Venezuela. And it's, as you see, the population is pretty small. It's only 108,000. It's still actually a part of the Kingdom of Netherlands. And it's a multilingual population. So most of the people speak 3 languages, the native language, Dutch, and English. And there's actually a lot of natives on the island from surrounding Latin American countries like Venezuela or Colombia. The economy is primarily a tourist economy, and that's going to be important later on in the talk as to why an aerospace hub is important to the economy. The other key industries on the island are agriculture, like plants, or it used to be and primarily was the oil industry, not so much anymore. When you go there, it's very American. So 80% of the tourist population is actually U.S. citizens traveling for vacation. They're actually more busy. Their prime tourist time is actually during winter. And we were there actually this past October, and we had an excellent time. We were there for Halloween. It was pretty cool to see everyone celebrating. And it's a very literate population. So, and it's very highly educated. A lot of the people, if they want to study, they go to the US and they go back to Aruba, or they go to Europe, specifically the Netherlands or Germany or the like. And you can actually walk all the way around this island. They have a law saying that there's no company or private entity that can restrict you from walking along the coast. So it's about 20 miles long and about 6 miles wide. And it'll take you about a day or so to actually walk the circumference of the island. So I like to give that information because not a lot of people know about this little tiny island, and you always hear about in famous songs like Aruba or something, or the destination hotspot. Something important too in Aruban Aerospace Hub is the fact that this island does not fall within the hurricane path. So it rarely, if ever, do you have a hurricane actually coming onto the island. It's actually a pretty desolate island. Its history actually is pretty significant, going all the way back to World War II. And the island of Aruba was a vital oil supplier for the Allies during World War II. And it was actually home to two of the world's largest oil refineries. This is Venezuelan oil that they would refine on Aruba. And two companies that were actually located there were Iron Petroleum Company and Lago Oil and Transport Company. They had their base of operations. They operated out of here. And specifically, the point in time that most people reference is on February 16th, 1942. Because of the oil and supplying, the Germans and Italians sent about 5 U-boats down off the coast. And on this particular day, a German boat, it was called the U-156, and was commanded by Werner Harnstein. You can see him on the screen there on the top left. He slipped off the coast of Aruba, and he started seeing some of these oil tankers. And what ensued was an oil tanker, the SS Perdinelis, was struck by a singular torpedo, and actually 8 out of the 26 crew were killed. And after that, Werner Harnstein attacked the second oil tanker, the Oranistan, and 15 out of the 22 crew were killed. And then finally, the oil tanker, the SS Arkansas, it was partially sunk. No one was killed. You can actually see the SS Perdinelis partially sunk there in the right. And then the U-boat, U-156, is featured on the top. And I mentioned about the economy of the island. Those two photos on the bottom, my crew and I, we drove around the perimeter of the old oil refinery, and this has sat dormant for the past for at least a decade. And they've tried to start the refinery back up. There's been a couple bidders on the land. The problem is it takes an equivalent of a couple $100 million to get this land revitalized. It's the second largest plot of land, meaning the oil refinery land, second to the nature reserve on the island. So wow, it's pretty significant. And so it was kind of cool to see that. It kind of looked post-apocalyptic there, because not a lot of work has been done. But I'm telling you that the island is very ready for new industry. And more importantly than that, I've never had anybody, when I say Aruba, say, well, I wouldn't like to live there. And you can see some of the photos that I took from our most recent trip. I have a particular approach when I go to a foreign country and want to do business there. I like to talk to the locals. I like to have a local with me when I'm meeting with people. I'm having business meetings. Most memorable, one of the most memorable things that I had on this trip was we were so busy in meetings during the day that we really could only go to the beach mostly during the night. And so we were swimming in the ocean just off the coast under a full moon. It was really pretty. We sailed on a catamaran. I went to my first Rolex shop. The food was absolutely amazing. We went to this old farmhouse that was turned into a restaurant where we ate a local Aruban food. And we did walk along a lot of the coast. Aruba is very, very safe. There's not a single time when I thought to myself, even when I was out at midnight walking around the town, the city, that, oh, wow, I'm in danger. It was an enjoyable experience. And like I said at the beginning, it's very U.S. So if you're a U.S. citizen, not only will they accept U.S. dollars, but they're very welcoming. And I couldn't say more about that. I could say a lot more about that actually. It was an amazing experience. The other important aspect to our trip to Aruba was our meeting with the government officials, and I met with His Excellency the Minister of Economic Affairs Jeffrey Waver, Senator Ricky Hook, and Greg Peterson, the Aruban Economic Free Zone. And like I said, because of the Aruban economy, they're very eager for industry to come into the island and set up shop. And we were very well received. Particularly, our conversation centered around incorporating New Alexander Labs, which is the company we're about to talk about for the Aruban spaceport in the Aruban Free Zone. And this is the government-sanctioned economic free zone, so you can get around tax laws, you get some subsidies. The way they've set up this economic free zone makes it very appealing to businesses coming in and setting up shop there. So we met with Greg Pearson in his newly renovated office and his team. Very, very warm welcome. Very, it was just a great time that we had. So the reason we visited there, and I kind of stole, I gave this, I hinted about this a second ago, is to set up New Alexander Labs in Aruba as this Aruban Aerospace Hub. And this is, to this conversation, the equivalent of having or investing in the Latin American aerospace infrastructure. And New Alexander Labs' goal is building an aerospace facility that can provide testing support to countless Latin American aerospace programs. Principally, this facility will be home to Latin America's only commercial and academically focused wind tunnel. Now, when I say that, people are going to say, "Well, come on, that can't be true." No, there are no hypersonic wind tunnels in Latin America, and we're going to discuss maybe why that is. But specifically, this will be the only commercial and academically focused hypersonic wind tunnel. And really, the questions I have on screen here are, why did we choose Aruba? And in one of the slides I had previously, you say that Aruba is located centrally between North and South America. And that's important to us because if we put New Alexander Labs, let's say we put the New Alexander Labs in the hypersonic wind tunnel in Brazil or farther down in like Chile, it would mean that we would not be able to send North American hypersonic programs to test in our Latin American facility. However, with the central location of Aruba, you can send North American and South American hypersonic programs to test here. So at this central facility. And even now, you think about the American hypersonic industry, the testing aspect where people want to test their programs. It's not like you can go to Kubrick. There's a lot of programs that want to test in these North American wind tunnels, but they can't, and they're unable to. Maybe it's something to do with like defense restrictions or something dealing with military, and they are unable to get into some of these classified or restricted or secure testing facilities. That's one aspect. Not so much in this Aruban wind tunnel. The second reason why we chose Aruba was, again, the people, the desire that when we got to the island, everyone we talked to about establishing New Alexander Labs here in Aruba, it was everyone from the locals, from the government officials to entrepreneurs, local businesses, owners. They were all encouraged. They all were excited about the possibility of having this infrastructure there. The other aspect was the politics. So you think about Ecuador, you think about Argentina, and I'm not going to get into the political problems of these countries, but Aruba is very sound and safe politically. It's very stable. It does business very like a European country would. It is actually, like we said, a part of the Kingdom of Netherlands. And when you walk into the Aruban Parliamentary Building, you can see a photo of the King of Netherlands on the wall. So that kind of also answers why not Brazil and other Latin American countries. So if we have a facility of this on Aruba, how does this facility work? How does it have partnerships? And what we want is for Argentinian, Brazilian, Chilean, Costa Rican, Colombian hypersonics programs to fly in and test at this facility. And I don't think that we need to get into at this time. We could talk about doing something similar to what the UK does with their nationalized testing facilities, where you kind of have to join a kind of a membership, I guess you would say, in order to test at their wind tunnels. I don't think we're going to go that far with this facility. I want to make it as easy as possible to test in this facility as possible. Why do I care as an American about building the Aruban Aerospace Hub or even the Latin American aerospace infrastructure? I think that America, for the last 50 years, has not put as much emphasis on Latin America as it should. And the result of that is very evident with other countries, other superpowers moving into Latin America. And if America wants to remain the top as far as like the leader in aerospace technologies, then they have a vested interest in investing in their Latin American neighbors that are developing aerospace technologies the same. It's not like you can put a hold on Latin America and say, no, you're not going to invest in Latin American in aerospace technologies. You're not going to do R&D. No, they're doing it now. And you either help them join the program, or someone else is going to do it. And as an organization, as an American, you know, like I said at the beginning, there's no excuse, there's no substitute rather for just going and doing the job and talking to the people and building this network with these aerospace teams. Alrighty, so the tunnel that we're looking to build is actually similar to Oxford's T6. And you've seen featured that on the screen. It's a Stalker series tunnel, and which means it's a reflected shock tunnel. And this talk is not to talk about the tunnel specifications of what a reflected shock tunnel is. That's for a later date. But this gives you an example, an idea of what it will look like. And it will be able to do scaled model testing, scramjet engine testing, shock layer interaction, high enthalpy aerodynamic problems, hydrogen ionization studies. And then even this tunnel, it's not doesn't require a lot of power. So even some of the power requirements are listed here on the left. Things like water hookup and cooling are important. It's important that you build your tunnel in a temperature controlled environment with air conditioning. And all I'll say on this is, you know, we're working with the people that built the T4, the T5, the T6, Sandia National Labs, HST. So we're working with the best team of engineers in the world, the best network of engineers, the world's leading experts on reflected shock tunnels. So I'm excited to, in the very near future, begin construction on this tunnel, because I know it's going to have a tremendous impact on the aerospace industry throughout Latin America. I would say that we are taking the proper safety precautions, and we're being proactive with this tunnel, meaning we're looking at where we're going to put this, where we're going to place this facility. Is it going to be near the airport? Is it going to be fuming toxic gases? Is it going to be loud? Are there neighborhoods close by? And a lot of this has to do with working with the Aruban Economic Free Zone, working with Greg Peterson and his team. And we've had a tremendous time working with them, and they've been extremely helpful. The wind tunnel market globally, and I'll talk briefly about this. So the global wind tunnel market in 2021 was $2.7 billion, and it's expected to grow to $3.8 billion by 2028. And the U.S. Pentagon's financial 2023 budget request for hypersonic research is $4.7 billion, up from $3.8 billion in 2022. And as an organization, New Alexander Labs is pursuing an entirely underutilized market. I like to think of it as, we're creating in the industry. Latin America can only boast, like we said, of one hypersonic wind tunnel, and that's the T3 down in Brazil. But we are building the only commercial and academic focused hypersonic wind tunnel. And I have 5 points that I have that really emphasizes where Latin America is in its aerospace industry, what does its future look like? The Latin American Aerospace Agency was established in 2021 with a budget of $100 million US. Mexico's aerospace sector grew 15% from 2010 to 2019. And because of its location south of the equator, Brazil's CLA launch center may become one of the best in the world. In 2022, Brazil launched its first domestically built rocket, and the total number of satellites launched in 2022 was 20 times the number sent into space in 2012. So if you were to take a 40,000-foot view of Latin America, and the interest that they're taking in the aerospace sector, every single country has its own goals, prerogative, and path to, essentially, you could say, path to dominance for its aerospace industry. And a lot of this is, some of them don't even have the capabilities yet, but they want to. And I will emphasize this point one more time. Most surveys, even the ones that we went over in this slide here, will talk about the global market, but they won't talk about the creation of a new market, like what we'll talk about towards in the second half of this talk, is creating a new market of hypersonic research, a new hypersonic industry. And I'll be honest, it's very hard to find information on the global wind tunnel market and the global wind tunnel industry. And that's because a lot of hypersonic research is focused on the defense and the military. Everything I'm talking to you now and here is commercial focused and academically focused. In the public domain, it's very clean, I would say. So there's no worry about dealing with weapons or military programs. So we're good with that. So the question is the Latin American aerospace market ready for a hypersonic wind tunnel? And keep in mind, like we said, some countries don't even have aerospace engineering, or they don't even offer that as an undergraduate degree. In Brazil, like we said, with its T3, that's the only hypersonic wind tunnel on the continent. I have ran into teams in Latin America that wanted to build their own wind tunnel, but they didn't have the correct funding. They were unable to. And another marker on the health and well-being of the Latin American aerospace economy is actually something you can find out in Argentina. Consider the Argentinian space agency, CONAI. Its budget, and this is with the recent election of the new president, and I'm not about to get into politics on yay or nay, but the Argentinian space agency actually has a budget only long enough to last until about a quarter of this year. And so you can see the government-backed aerospace programs in Latin America are faltering. they're kind of at a standstill, which opens a door for the private sector. And that's where Mastodon United comes in, where New Alexander Labs is creating the aerospace hub. Mastodon United is creating the aerospace funding. And Mastodon United is a United States-based venture capital firm, and it's focused on investing in Latin American aerospace projects. And a lot of these projects will actually come and test in New Alexander Labs hypersonic wind tunnel. And so this is important because, you know, in aerospace, you can have the vision, you can have the dream, you can have the team. If you don't have the funding, you're going to have a standstill. And so with this strategy, both New Alexander Labs and Mastodon United, we've been able to circumvent that and say, we found the team, we found the dream, and we can also match that with funding. And we're actually growing our first fund in Latin America right now. And you can see a few of the members there on the screen. But an aerospace hub in Aruba starts with having ties to Latin American aerospace programs. I can't emphasize that enough. And kind of some bullet point topics that I would say to like investors or something is say, you know, if you invest in Mastodon United, you're going to have access to the top Latin American aerospace research programs, including some national programs. That's very true. You're going to have portfolio diversification within the aerospace sector, also true. And you're going to be supporting new and a budding aerospace industry within Latin America. And there's Justin Gans and I on the beach of Aruba. We had an awesome time walking along the coast there. So this second half, I took 30 minutes to describe New Alexander Labs, the aerospace infrastructure. I'm going to take the rest, the next 30 minutes or less to describe the funding infrastructure. All right. So Mastodon United, now we're getting into the nitty gritty. Mastodon United has some goals. And you can see on the screen there, we are working with teams in the green. So what that means is we are working with people, aerospace teams, aerospace startups in Mexico, Guatemala, El Salvador, Costa Rica, Colombia, Ecuador, Brazil, Chile, and Argentina. Now, I can't say that we're in every single Latin American country or in the Caribbean, and that's okay because this is a pretty good start. And we have an investment sector focus where we're focused on hypersonic and supersonic teams and startups, also startups working in the satellite and drone sectors. And I hope that each of the startups that we work with, that they become specialized in a particular aerospace technology, which then allows them to collaborate with other Latin American startups within the fund. And to answer the question that we previously asked, is Latin America ready for a hypersonic wind tunnel? Well, maybe, but we're making sure that's a definite yes, because we're creating the market. In so doing, we are creating these startups, which are creating jobs, which are building the economies of Latin America. And as an American, I talked about how we have over the past 50 years, kind of looked over Latin America for other regions of the world. Well, if you want to solve the border crisis in the US, which I would love to do, and I'd love to be able to help any way I possibly can, how I'm doing that and how Mastodon United, how New Alexander Labs is doing that is we're growing the economies of these Latin American countries in green because we believe we can provide jobs so that the students graduating from these incredible universities don't feel the need like they do now that they have to leave their country. Most of these aerospace engineers go to the US, to go to Europe, and they find jobs. They can't find jobs in their country. Something else that I like to say is we found this out in the very beginning of Mastodon United. We're not growing these startups to compete with the US. We're growing them to go collaborate collaborate with the U.S., collaborate with Europe. And part of what we do and part of our goal is we want to provide confidence to international investors. So we don't want what's previously been done, aerospace investors to come in Latin America and say, you want to start up a Latin American company? And they say these to Latin American aerospace engineers. Well, you go and start and found your company in Georgia and you go work there. No. We are creating Latin American companies. And we hope to provide international confidence, which will bring resources to the continent. And within this first fund and within subsequent funds, we want to have a cradle to grave approach. So the startups that are collaborating will be able to, in time, produce every component of a satellite. And there's quite a few startups we're working with that can actually take up and build out most of the life cycle or the build cycle of a satellite program. We're even working with a Brazilian startup for a launch as a launch provider. So this cradle to grave approach is very important to building the Latin American aerospace economy. Now, there's a lot of strategy to this as well, and it requires a lot of unique strategy. So specifically, these are things we found out just working with the people, working with these countries. The first thing is, how do you find aerospace startups? Like, let's put you in front of a computer right now or a phone and say, go find me the best aerospace startups in Latin America. What would you do? How would you go about finding them? How would you go about choosing or not choosing the ones you should? Or what I mean by that is avoiding the startups that you shouldn't be involved with. That's really important to know too. What we are also doing is we're growing an aerospace sector from scratch. I said previously, there's some countries out there in Latin America that don't even have an undergraduate program. But you know what? That's okay, because our goal is to grow an industry. And so as long as there's a desire within a community that we can find of aerospace and engineers within the country, we will help them in any way we possibly can to build a startup community, to build companies, to build their private sector, whatever it takes. Here's a unique strategy that was very beneficial to us as well. Piggyback off other industries to help found another. Specifically, there's countries out there in Latin America. You can't just walk in and say, I'm going to start a hypersonics industry in this country. It's not going to happen. So you have to find a industry that country will have need of, an aerospace industry the country will have need of, that has ties to the hypersonics industry. Because again, I'm a hypersonics guy, so most of the things I do with have ties to it. Specifically, what we found was the satellite industry is that. It's that link. Because there are in the lifespan of a satellite, whether it's reentry or even the rockets that put it into space, there is need for a hypersonic wind tunnel. Another strategy is we wanted to partner with local law firms that can help our startups within their region in founding documents, in corporation documents, helping them get into economic free zones within their country. Maybe it's Brazil or another country. We wanted to partner with governments and institutions. This is very, very important. We also want to keep the private sector autonomous. So that every company that we want to work with, we don't want them to become too intertwined with any government. We want them to be private. We want them to have freedom. We want them to be able to do their own thing. And another aspect here is we want to serve as an accelerator. And if you're familiar with VCs and how the industry work, how the investor world works, accelerators and incubators are organizations that prepare a startup for venture capital to then invest. And actually a lot of venture capitals have accelerator programs. And so we have our own, and we work with the startups and getting them ready to be invested and ready for investment money. The other thing is a strategy of, there is such a thing as high risk investing. And a lot of times, that's what we're in. But that's okay, because usually that's the highest payoff too. Because a lot of times you're the only ones in a specific section or region on the continent. Now, some things that I love to do is the things that I like to consider or help each of the teams I'm working with consider are, I want each of them to have responsibility. And I don't want them to be completely dependent on the venture capital or the accelerator programs. I want them to, we're not going to be able to, if the team isn't motivated, it's not going to succeed. And so we want to be able to invest in autonomous, responsible teams, but then again, provide as much aid as possible. And I wrote this next point, getting to the nitty gritty of entrepreneurship. It is that in its truest sense. It's sometimes very challenging to work with teams, not because they're not motivated or anything like that, but you're working in an entirely new industry. But that's what we love to do. And so even in the US, it's challenging to have a startup. So the same thing is true really across the globe, whether it's Latin America or not. And I said this point earlier, but I want to never take resources out of Latin America. I want to invest in the continent. And in so doing, that is helping America. And this slide provides an example of collaboration that we've got. So let's say Mastodon United wants to invest in a satellite startup, which it is. And that's step one. In step two, Mastodon connects that startup with other startups within its funds, which it's doing. And then we coordinate those startups with institutions or local universities that deal with aerospace programs. And then step three, finally, is we have the option, dependent on the country and the region we're working in, to then pair that startup and that university with a local space agency. So there are also Latin American countries that don't have a national space agency. But there are Latin American countries that have a desire to grow one. And so a lot of times these programs that we're working on and I'm thinking of a real example right now that we're working on, can actually form a basis of helping establish a country's space agency in their national space programs. So it's very exciting to get a part of. So the next section, this next slide is actually, you can see Justin Gans, Colin, Bradley, and we're all sitting there getting ready to meet with Jeffrey Waver, the Minister of Economic Affairs. I want to make it easy for undergraduate students in Latin America to get involved with our programs, to get involved with our startups. And so it's as easy as step 1 and 2. So I first have to ask the question, and on a weekly basis, I'm interviewing undergraduate students and PhD and grad students, and I'm asking them, are you interested in aerospace engineering? Are you desiring a job in aerospace upon graduation? Do you want to work on the top Latin American aerospace projects? And then I have them contact Mastodon United, and then I plug them into one of our companies. And that's the opportunity that we've got in front of us. And this is, again, just a real example. This is a real example of how we're changing the landscape, the aerospace economy in Latin America. And this is going to have a tremendous impact on on people's lives. And that's exactly why we're doing it. I'm very excited about, so I said that we visited this past October, Aruba, but Macedon United, I'm taking a team to visit Costa Rica next month. And some goals for this team is we're taking letters of support from some surrounding Latin American nations, so from the government of Aruba, and we are helping warm the relations between Central American companies and their aerospace focus, specifically the Aruban government and these aerospace startups, specifically who were going to visit the Costa Rican Aerospace Cluster, which is a group of 30 plus Costa Rican aerospace companies. And we'll be visiting Costa Rican universities and startups. And so this will be a very profitable trip. And in our time, we'll also have to, we'll also do some cool sightseeing. We'll visit La Fortuna, and my Spanish is terrible. So, but this is a national park that has some volcanoes. And the image you see on the screen actually right now is Manuel Antonio Beach, I believe that is. And I hope to actually visit there when I go. And also another place we'd like to visit is La Paz Waterfall Gardens in Monteverde. So we'll be staying in San Jose, the capital, and we'll be traveling around the country. So I'm really excited. And we'll be taking also Baldwin Aerospace engineers, because like I said, a lot of the engineers at Baldwin Aerospace provide support, and they aid in consulting a lot of these Latin American aerospace teams. So there's kind of a brotherhood there. There's a lot of collaboration and cooperation. Not a separate trip, but the same trip from San Jose, Costa Rica. We are then flying to San Salvador, El Salvador, and that is again next month. And we'll be meeting with government officials from El Salvador, again, meeting with universities and startup teams. And the place we're going to be staying is just outside of the capital, San Salvador. And we're kind of up on a mountain overlooking this jungle lake. And the place we're staying has like these hammocks, and it's kind of like jungly, and it's really cool. So I'm excited. And one final kind of update in April, I'm taking the team to Chile, and we're visiting FIDE in 2024. This is the International Air and Space Fair. We're going to be actually having cooperating in a booth set up there. So we'll be able to meet with officials, Air Force officials, aerospace enthusiasts. So that'll be very cool. My last slide, and I'll spend the rest of my time there because I've only got maybe less than 10 minutes. I wanted to talk about just these things to consider. This is a kind of a question to everyone involved. Is Latin America not really the perfect opportunity to right the wrongs that have plagued the U.S. and European aerospace markets? There's no better time to be involved in Latin America right now as far as like aerospace programs. And I for the longest time have talked about the qualms and the problems that you've experienced in the United States. There are obviously, Latin America has its own problems and challenges, but the fact that you're starting in a whole new industry, a lot of times in these countries, gives us the ability to right those wrongs and set it up correctly, set it up properly. Maybe sometimes set it up even better than things are set up here in the U.S. But there's still ties to the U.S. and there's still ties for collaboration. And then kind of a somber reality is if the U.S. doesn't get involved, I'm doing everything I possibly can to be involved. Others will. And they'll just do everything that we're doing now. but it won't be for the profit of the U.S. In reality, what we're doing is for the profit of these Latin American countries, their economies, particularly its people. And by doing so, the U.S. will benefit. And there is a lot of room for involvement. There's a lot of room for involvement within New Auxena Labs, Macedon United, and Baldwin Aerospace. And this is a program that burns like wildfire, spreads very fast, and it sets up the forest, you could say figuratively or allegorically, for new growth. I like to think of each of these countries that we're privileged to work in as their own thing, which they are, and they have their own challenges. In Mexico, you could say that there is a heavy industrial base, and there's incredible ties to the U.S. So let's say I'm working with a Mexican university, which I am, and they're really close to the border, and they want to work with and collaborate with a U.S. university. Well, there's that opportunity. That's awesome. Let's say Guatemala, which does not have an aerospace, they don't even offer it as a undergraduate program. The potential in a country like that is beyond almost anything else, because you truly are creating something new. In El Salvador, you have a newly elected, more recently elected President Bukele. You have an excited country that wants to set themselves up as experts in the aerospace industry. They have an incredible roadmap to highlight what they want to do as a country in the aerospace industry. So anything I could do to possibly aid that is, I hope to do so. In Costa Rica, you have organizations like the Costa Rican Aerospace Cluster. And this proves to most people that this is a well-established aerospace industry. And you think about Colombia, and this is a country that's focused on mobilization. There's a lot of excitement about national satellite programs and gearing up startups. In Ecuador, you have a very established industry that's slightly different than what you have in Costa Rica, because you have a few key players that are very, very specialized and have set themselves up very nicely and built an incredible reputation. In Brazil, it's essentially the powerhouse of potential, because this is, again, where you can see why, because this is where we're having the space launch startup located, because this could be an entire ecosystem all on its own. In Chile, there are so many specialized aerospace engineers in Chile. It's incredible. But there's also a need, because there's about 10 to 20 aerospace engineers for every job opportunity. In Argentina, you have the political strife. But really that just means potential. Because, like I said, the Argentinian Space Agency might not be able to fund certain aerospace programs, whereas the private sector can. And some of the other challenges you might consider are language barrier. There's a lot of languages spoken, primarily Portuguese, Spanish, English, Dutch, Papiamento, all these different things. There's also groups of people that don't like each other, and that's to be with everyone involved. That's everyone. That could be said about anybody in every continent. There's also difference in how business is done between Latin America and North America. And so I hope to set companies up right in Latin America so that they can receive funding and confidence from North American and European investors. There's also the close proximity to Venezuela that Aruba has. Now, Aruba does have F-16s via the Netherlands, and it has about 100 Marines in a military base on the southern part of the island. But, these are things in recent news. What's happening down in Venezuela? What does that mean for a Reuben Aerospace Hub? All these things we're considering. But despite these challenges, again, we have been met with incredible support from the local Reubens, the local Reuben governments, local Reuben entrepreneurs. And by combining the teams and the efforts of Baldwin Aerospace, which is providing consulting and help and aid to New Alexander Labs, which is providing the Latin American aerospace infrastructure. We want to create something refreshing and new, something that, will help these Latin American countries. But we didn't forget that infrastructure and teams also need funding, which is why we're also equally passionate about providing that funding through Mastodon United. And again, you can contact me through my email. I'm just about done, but contact me if you have thoughts or questions about this, justin@baldwinaerospace.com. And I'd love to talk with you about this, how you can get involved, opportunities, trips coming up. You can see me there walking along with one of my friends along the Aruban coast. It's absolutely beautiful. Now, I had hurt my foot previous to taking this photo, so I was just hobbling along with an infected foot. But that couldn't possibly have taken the joy that I experienced away when I went to Aruba. It's absolutely beautiful. I cannot wait until I go back again, and I'm excited to take. I'm actually excited to live there, so we'll be there soon. Tim, I think I'm about done. I knew that we'd set aside an hour. I have 3 minutes remaining. So
yeah, Justin, thank you. That was an amazing presentation. I know that this is something that's close to your heart, and I know there are a lot of benefits, right, to putting something closer to the equator. I mean, for folks who are engaged in rockets, and that's for the foreseeable future, that'll be the majority of the industry. There are a lot of reasons they want to do that. So thank you for covering that. So you know what? I want to bring in everybody. We're just about out of time, but I want to bring everybody in to give you a big hand. And we're waiting on Mr. John Brandenburg. Justin Pearson, thank you. Thank you for a remarkable rundown. Again, plan to put a spaceport in Aruba. We only have a couple of minutes, but do you guys want to do you want to give any questions for Justin?
Yeah.
Oh.
Okay.
Go ahead, Mark.
Fast. Probably this is what Drew's going to ask. Where do you get the liquid helium, oxygen, and all the fuel and all that stuff for a spaceport? Aruba is an island. Like, how are they going to build up industry enough in order to actually make launches there?
The spaceport has more to do with the research and development center than it does a launch center, because of the size of the island. And so the goal is that a lot of the research and development will happen here, whereas, like you said, in Brazil, like we saw, or Colombia, you could actually have a better launch facility there. And so it has a little more to do with the research and development than it has to like launching a rocket from this small island. Formula One wanted to put a track on Aruba, but they were denied because the track interrupted a local owl population. So it's a very it's a very environmentally friendly island for good reason. But so the type of testing and R&D that will happen here has more to do with clean energy, clean testing, which is.
Okay.
Yeah. How are you? I assume you're expecting or hoping for U.S. investment, bringing big aerospace operations, big projects down there to be investigated, and wind tunnels and stuff. Am I correct there?
Yeah, and even there's universities that go ahead.
How are you going to get around, or what are you going to do about ITAR? Because nobody down there would be allowed to work on anything that we bring down there.
There's a lot of North American open source and completely public programs that want to test, but they're unable to here in the U.S. because
there are no space programs that match that description in the U.S.
Exactly, but what I mean is There's
That's
a
where the
lot
money
of
is.
what I mean is there's a lot of U.S. hypersonics programs that are unable to test in the U.S. hypersonic wind tunnels. And so if ITAR doesn't apply to open source and public programs, which all these programs will be. And there's also a lot of South American companies, like some of the leading Latin American space programs or aeronautical companies that do their testing in the U.S. and they're looking for a facility closer to home.
Yeah. Well, guys, so we're just past the top of the hour. Mark is actually on a schedule. John Brandenburg is running late. So let's do this again one more time. Let's put our hands together for Justin. Justin, thank you, sir. That was amazing. And again, as you have more hypersonic updates, things like that, I would love to have you back on. It's wonderful to be able to showcase this. Let me apologize for squeezing things so tight. I want to go to lab updates now. We'll start working on those. And I'm going to begin with Mark because Mark actually has some scheduling constraints. So. Okay. So Mark, take it away, sir. And should I introduce you? The indomitable Mark. You have a lot. I will. What I will tell people is you have a lot of amazing, like, oh my God, this is amazing stuff going on. So take it away, sir.
Okay, so last update you guys heard, we were seeing weight loss in the X band with that graph showing 8 consecutive weight losses at the same point in the magnetic sweep. We're going to be taking that data to the ENC conference, the Experimental Nuclear Magnetic Resonance Conference, and our own Tim Ventura and Michael Prohn plan on joining me. Jared might be there as well. David Chester might be there as well. So we're very excited about that. I actually submitted a paper, and it's in the process of getting reviewed. I need to fix some stuff up. I've never done that before. So the X-band RF amplifier is broken. We tore it apart. Turns out it was the high voltage side of things that broke. And the other unit that I had that was a similar make and model had the exact same component that was broken. So we decided this was a sign to start moving towards the S-band. And what you can see behind me over here is S-band, or 3 gigahertz and below microwave amplifiers. And right when we decided to do that, Mr. George Hathaway reached out with an email asking if we wanted all his S-band equipment that he used for the Alzafon experiment when he replicated it. So that's just a sign from the universe that it's time to go to S-band. But we do have still a 20-watt RF amplifier in the X-band over here with a coax output, and we're going to be using that in the interim in order to run a couple tests until all of our S-band stuff is set up. Okay, for those who don't remember, this paper over here, let's see if we can, okay. So basically it talks to increase the effects of dynamic nuclear orientation or nuclear spin orientation by introducing triplet state electrons into the chamber, the RF chamber. Triplet state electrons are 2 electron pairs that are sort of like floating together and going. Basically, they're like interlocked. They're similar to Cooper pairs or something like that. I'm not exactly sure, but the way they're produced, or one of the ways of producing them, better yet, is to shine a very bright light at some certain types of crystals with different dopings in them. In fact, when I started talking to the laser, Patrick, one of Jeremiah's buddies that deals with lasers, he said that's actually one of the problems they have with high power lasers is that the dye sometimes at a certain power level, they start to produce these triplet state electrons, which then fog up the lens or fog up the dye or whatever. So it's actually a pretty common occurrence in high power lasers. But for our experiment, we were going to use different materials that are made in a Bridgman crystal growing machine. For those who don't know, it's pretty simple. A Bridgman crystal growing machine, you fill up a vial like this with some material. You have 2 chambers, hot, and then it's slightly colder, and then it goes through a hole very slowly. This movement would go about several hours or days, depending on what the material is. So for our first run-up, we were supposed to be making it with P-terphenol, but Sigma Aldrich, our chemical company, didn't have that available yet. Should be coming in a month or two. So our own Michael Perrone suggested we try using mothballs or naphthalene. So this was attempt number 1. One of the temperature sensors were not in position and it ended up burning. Attempt number 2 had a similar result. Attempt number 3, it sort of fell down and became a solid crystal. Anyways, I'll get to the good part. So here is attempt number 10. And I don't know if you can see this, but that is clear, actually. Now, I don't know if you guys are familiar. That means that there's a monocrystal forming. It's about half of the tube is a monocrystal. So this is attempt number 3. These are chemically identical. The only difference is that we the reason why it's clear is because we tweaked the settings of the system, the speed at which it falls, the temperature. We had to add fans in. Every single time we were changing up the recipe a little bit, taking notes of what worked better, what went worse. And this is the best result we've had so far. This was cooked up last night. We're gonna continue perfecting it until we get it almost perfectly clear. Then we're gonna shine a light on that inside of the microwave waveguide and introduce those triplet state electrons that are going to be coming off of the crystal, and they're supposed to help penetrate the samples better. So that's pretty much it for now with the Alsfang experiment. We also have, I don't know if you guys remember him, the youngest presenter at APEC, Kishlay Singh, is going to be here for the summer for an internship job, and we're going to work on a magnetic profiling device using 3D printing parts. So that's something that's pretty exciting. And there is talk. A conference organizer reached out to us. Me and Tim talked to him about a potential in-person conference, and that's to be determined. If anyone has any interest in that, please reach out to the APEC email, respond to it, and we'll see if there's enough funding, if there's enough logistics to make that happen. I'm personally not going to be involved in making that happen. It was too much of a hassle last time. But that's pretty much it that's going on.
Awesome, Mark. Wonderful timing. Wonderful timing. Well, so before if it's okay, actually, I want to go to John Brandenburg, if that's okay. And then we can come back and do the rest of our lab updates. John is having transient internet outages. He has been actually for a few weeks. So, John, welcome, sir.
Did you say transient internet allergies?
Maybe I did.
Transient internet allergies, right?
Yes, his computer is allergic to the internet. So,
well, it all seems to be fine now. Of course, I turned the machine off and then turned it back on. I visited some sites, and of course, they always say, "Here, kid, you want a cookie?" And
no, say no to the cookie. Say no to the
cookie.
So I
say no to cookies. No, no, I don't want any cookie, not even with chocolate chips. So anyway, yes,
you can't turn away chocolate chips.
No, you know what? On the internet, they're not really chocolate chips. That's the code word.
No, they're not.
Yeah, you gotta. Well, yeah, if it's okay, Mark, let me take you out. Thank you for the update, man. That was amazing.
In the meantime, my nose has started to run. Here, hold on. Let me give me some.
That is fine, John. I'm going to bring up your presentation, and again, I should apologize to everyone. Anybody who follows the APEC conference knows that we are a little bit chaotic. So. I liken this to Moses crossing the desert, right? And then I learned later, it took him 40 years, and I was like, wow, it turns out it's only a 2-week trip.
Well, yeah.
Okay, well, John, let me take myself out. Thank you so much for joining us to present this.
Oh,
so you're going to be talking about Mars.
Always an honor and a pleasure to be on your on the APEC conference. I apologize. I've been kind of absent the last couple of weeks. I've been getting ready for a move to relocate to Oregon, where my family is, and
up near Jared.
Before Texas secedes from the Union, and I can't see my grandkids without crossing an international frontier. I'm only joking.
I
So
think Texas
it's
is
only
sitting
it's only the beer
years ago.
talking down here in Texas, you know.
Okay, well, let me take myself out and go for it. Just let me know when you need next slide.
Okay, thank you. Okay, my friends and colleagues, today I'm going to talk about literally the big picture of the situation we are in. Those who have noted what I posted on X, I believe the day before yesterday, which was actually an article published in MUFON Journal 34 years ago, 1990. And this was kind of confined to the UFO community. And some of the people in the UFO community I knew happened to be kind of on the inside of the UFO cover-up, or at least in its outer layers. And they viewed the article with great alarm and said that they were going to make sure it was widely disseminated within the realms that they worked. But anyway, I'll get to that later. So I want you to know that the discussion I'm going to have here is more background for the discussions that are presently raging on X. So it's the big picture. Our situation in the cosmos, in both space and time. And next slide, please. Okay, the agenda for today is, and I'm not going to, I'll just say there's going to be an introduction. And this is a cosmic military political summary of our situation. Unfortunately, we must bring in both politics and its extension, the military, into our summary of this situation. First, we'll talk about scientific analysis of our situation, and then our situation kind of going back in time, antiquity. What does antiquity tell us about our situation? Finally, we'll go to our contemporary times, more like we're moving forward in time into our present space-time. Contemporary times, Mars. Contemporary times, Earth. Our cosmic situation now. Pardon me. There's a cold going around, it just hangs on. Our cosmic situation in space at this time. Should ET disclosure occur? That is actually a question that has been raised now because people who are cognizant of what is being covered up have said, oh, the public is not ready. Even members of Congress have said that there must be preparation. Some people have said it must take 5 to 8 years to prepare the public for this big thing, this big disclosure. I call this an ET disclosure because you'll find out that the situation we are in is not just a ET cover, it's not just a UFO cover-up or UAP, little wordsmithing by the Defense Department. It's not just a UFO cover-up. It is a Mars cover-up. It is also a cover-up of things that are being recovered from meteorites now that have just been from the formation of the solar system. Okay, should the DET cover up end? Okay, can we deal with the aftermath of ET disclosure? And then I will discuss my own belief, heartfelt beliefs about human destiny in the cosmos. Next phase, please. Next slide. Okay, just a summary of our situation. First of all, we are not alone in the cosmos. We share the rest of the cosmos with other intelligent beings such as ourselves. And this is a This should not be a shock to anyone with any kind of scientific knowledge. So that's just a given scientifically. More advanced aliens surround and visit us. We are not the first intelligent beings in the universe, and we are not the first intelligent beings in the universe to develop space travel, including interstellar travel. So more advanced aliens surround and visit us, both friendly and some, unfortunately, are hostile, apparently. We appear to be situated in the center of a strategic neutral region of space. This is a quite fascinating discovery, which I will go into detail about. Fourth, Earth is a rare and resource-rich planet. Look at the Earth compared to the other planets in the solar system. It just stands out immediately as a water-rich, large planet with a magnetic field. And it's just a rare and it's a rare gem in the cosmos. Some alien species appear to be attempting a stealthy takeover. I'm sorry if this, I mean, the universe has good and bad just the same way as Earth does. This is the principle of mediocrity, the idea that the human race is not remarkable in the cosmos, nor is the Earth. So the ET cover-up has helped humanity in the past, but must end, I'm sorry, with a mobilization, because we are, in my opinion, threatened with a stealthy takeover. The end of the ET cover-up may trigger hostile reaction from some ET groups. They are invested in the cover-up, unfortunately. Humanity is popular, powerful. There are people out there who apparently like us. We're obviously an object of great fascination. Many, many different species are visiting here. And why so many tourists? Anyway, humanity is popular. Some of them look very much like us and behave much like us, and apparently they are cousins genetically. The human race is also quite powerful. We may not think of ourselves in that compared to the rest of the cosmos, but we are quite technologically advanced. We have space travel. We have, unfortunately, nuclear weapons, which is the power of the stars. And we also have a reputation for being fairly tough. And I believe these things contribute that we are well able to resist a hostile reaction of ETs to the end of the cover-up, and especially with the help of friendly ETs. We are having this discussion because I believe there are a lot of people out there who actually like us and are watching over us. I will explain how that occurs later in the talk in detail. Human destiny is to join a community of peoples, of enlightened cosmic peoples. I truly believe that. That is our destiny. We're going to get through this difficult period of adjustment, and we're going to end up becoming part of a community of enlightened cosmic peoples. Next phase, please. Okay, a scientific analysis of our cosmic situation. The existence of many Earth-like extrasolar planets has been confirmed. I mean, I'm just talking fairly straightforward mainstream science now. When I was young, there were just some suggestions of maybe extrasolar planets. Now we have thousands of them. I think it's a fair statement that every star you look at in the cosmos, in the night sky, except for a few oddballs, has planets around it, like a hen and chicks. in a barnyard. The chemicals of Earth life are abundant in the interstellar space. We're not made out of some strange molybdenum alloy. No, we're made out of the common dust of the cosmos. And the meteorites we recover are full of amino acids and sugars, all of the things that make up the form of life that we have. There may be other forms of life, such as silicon-based or other life chemistry systems, but the chemistry system that we work on, carbon, nitrogen, oxygen, basically, appears to be very much embedded in the structure of the cosmos. And we see that in surveys we can do of using radio telescopes. We can detect the emissions from these chemicals. We see them in infrared. And also, we find these chemicals in meteorites that are very primordial. They date from the foundations of the solar system. So now nearby Mars shows evidence of a past Earth-like conditions, and also biology. That's why it's red. I will discuss that briefly. And archaeology. It looks like this is the second planet in the solar system to develop a humanoid civilization. Evidence on Mars suggests, unfortunately, a thermonuclear holocaust that was apparently created by, and I'm saying this is apparent because as we're trying to connect the dots of the scientific evidence, this Holocaust was extra Martian. Someone else, yet another intelligent race, apparently came to Mars and destroyed its living environment, turning it from being an Earth-like planet into the moon-like planet it is now, where there's only a tiny remnant of the former biosphere. So those are results of scientific analysis, which I'll discuss the evidence for. And then there's mediocrity. Not a term we like to bandy about in the sciences, but in this context, it means we're typical. We are not remarkable in the cosmos. Earth, humanity, and its habits, unfortunately, some of its habits are bad, are not remarkable in the cosmos or in nature, on Earth even, the habits of humans. Then finally, there's Fermi's paradox, and Mars suggests the worst enemy of intelligent life in the cosmos is other intelligent life, as on Earth. I mean, we know that the cosmos can be a dangerous place. Asteroids can plow into living planets like our own, wiping out whole biosystems like the dinosaurs were wiped out. We had several other mass extinctions that we're not sure why had happened. There's gamma ray bursters. There's nearby supernova, which can wipe out life in whole solar systems such as our own. The universe can be a dangerous place for life, especially for advanced life. Some microbes can handle just about anything nature throws at them, but not us. Then apparently added to the dangers of just astrophysics and the life and death of stars is the dangers posed to intelligent life by other intelligent life, just as on Earth. Next slide, please. Antiquity. Well, we've been handed down some very interesting tales. I'm just an Episcopalian. It's called Christianity in its mildest form, or Catholic light. But I do know my Bible. I owe that fact to fact I was raised in a very religious household, and so the message of antiquity, even from the Judeo-Christian Bible in Genesis 6:3, it says, "The sons of God saw that daughters of earth were very fair and took of them wives whomever they chose." I'm sure they had marriage licenses. And the offspring of these unions were great men about whom many legends are written. That is in the Bible. So, just like every nature is obsessed not only with violence, but also sex on Earth, procreation, apparently the cosmos in general is also. And some of the tales we're most familiar with from Greek mythology is the Greek gods coming down and having children with earth women who became great heroes like Perseus and Theseus and Hercules. So here is Apollo walking around on Earth in human form, inviting a young damsel to dinner, and says, and this is my pal Cupid, who'd like to come to dinner with us. And of course, here is a woman staring at what the ancients would understand, their garbled understanding of what would be a spaceship. It looks like a floating city. And the top of the caption is Love Nest. So based on this, I can confidently say we're all part extraterrestrial of one kind. There apparently were very humanoid aliens who visited here, found Earth females attractive, and they were basically either consciously or unconsciously trying to make the human race part of a super terrestrial gene pool of quite humanoid aliens. Now, it's also possible that the entire human race is the result of some kind of genetic programming by some very advanced race that may not have been humanoid at all, but made us just very practical looking to live on this planet. But if they did it here on Earth, they would have done it on other planets. And as a result, you would end up with a gene pool of beings who were on different planets, yet could have children with each other. So either way, either road you want to travel, some super intelligent beings created us on Earth, but they also created similar beings elsewhere. We end up being part of a super terrestrial genotype, which I think is a quite reasonable interpretation of the many legends from antiquity. So, next slide, please. Now, other things occurred in heaven. Not only was there misbehavior, human behavior and misbehavior involving beings from other planets, but we were occasionally treated to what looks like were battles involving other extraterrestrials. There's a recording of a 2-hour battle over Nuremberg in 1561, with complete with objects falling from the sky, burning and hitting the ground and exploding. And debunkers have said this is all an optical illusion caused by ice crystals in the sky. Sure. And of course, all of the legends of both in Western and Eastern religious traditions talk about great conflicts in the heavens between gods and demons in the Hindu perspective, out of which grew Buddhism, and also the in the Western kind of Greco-Roman traditions, which also involved the Norse. We had battles in heaven between different gods and races of giants, et cetera, et cetera. So, you know, it looks like the universe has been a busy place, and our ancient ancestors basically have reported that to us in, you know, a kind of garbled, non-comprehending form. And so, as above, so below. Next slide, please. Now, on Mars, which apparently was Earth-like in the past with a ocean, I was the first person, by the way, to propose an ocean based on modern science data. I did so in 1986 at a conference called the MECA Conference, Mars, Evolution of its Climate and Atmosphere. I gave it to an audience of, must have been 1,000 Mars scientists. And this has, if you look up Mars ocean theory on Wikipedia, I'm reference number 1. They give me credit for this. The mainstream Mars establishment, though, basically gives, even though they love talking about the ocean now, which is considered an established fact, the Paleocean of Mars, they don't give me any credit, and it's because I also investigated Cydonia and another place on Mars called Galaxis Chaos. Here, prompt on the top row, you can see the pyramid and the face of Mars. If you look down below them, here's a frame showing both of them next to each other. NASA never shows this frame because it shows basically a carved face and then nearby a pyramid. It doesn't take a rocket scientist to figure out what that means when you find that on the surface of Mars. And the other object on the right is a face found in a place called Galaxis Chaos, a completely different site. But both of these sites, Cydonia Mensa, where the face and the pyramid are found, and Galaxis Chaos, they are on the shores of what was the Paleocean of Mars, which is now considered a well-accepted idea. Next phase, please. Next slide. Okay. Mars was apparently Earth-like in the past with an ocean and a biosphere. The reason Mars is red is if you look at pictures of Earth, you'll see the deserts of Earth are bright red. It's because of highly oxidized iron called hematite, iron in its highest oxidation state. So Mars was very Earth-like in the past, apparently had an oxygen atmosphere and a ocean, meaning liquid water, Earth-like conditions. But the Mars atmosphere has a component of noble gases, which people like to study because they don't combine chemically with anything. So they are there kind of forever in the Mars atmosphere, in the atmosphere of any planet. And on every place else in the solar system, the abundance of one Mars xenon isotope, of which there are about 5 stable ones, is xenon 129. And the other one that's very abundant is xenon 132. And they form 2 peaks of almost equal size. They're within a few percentages of each other in every major planetary reservoir in the solar system. If you grind up the meteorites, the xenon in the meteorites predominantly follows this pattern. They put a probe into the atmosphere of Jupiter. It gives the same distribution, even Steven for 129 and 132. The solar wind has 129 and 132, almost dead even. The moon rocks have 132 and 129 almost equal. And yet on Mars, in the Martian atmosphere, xenon 129 is 2.5 times what it is the amount of xenon 132. And this is a result, by the way, this is considered a mystery. The most recent article about Mars atmosphere measurements was done just a few years ago using Mars atmosphere samples from the rover. And what they found was that the xenon 129, they confirmed basically the Viking measurements from half a century ago. That was half a century ago we landed on Mars with the Vikings. They found the 129 hyperabundance, and this is called a mystery. It is referred to as a mystery. There is no geological, geochemical scenario that is accepted by the community to how this xenon 129 arrived there. However, an excess of xenon 129 is produced by what's called R process, R for rapid. The nuclear R process occurs in supernova explosions and also hydrogen bombs. Those are the only two places you see R process. Basically, hydrogen bombs use the same physics that occurs in a supernova. So it looks like there was an enormous thermonuclear holocaust on Mars. Mars did not have a supernova on it. If it did, there would be no solar system here. But there were, on a planetary scale, massive thermonuclear explosions on Mars. And it's sad to report that. However, the good news about that is that now we know it. And the circumstances the circumstances of the explosions, next slide, please, can be investigated. They apparently both occurred over the ancient Paleocean. One was near Cydonia Mensa, and the other one was near the other archaeological site called Galaxis Chaos. And they left radioactive hotspots in both potassium and thorium. Potassium becomes radioactive when you expose it to a bunch of neutrons, like in a nuclear explosion. And thorium is a component of nuclear weapons. That has been declassified by the Defense Department. The big nuclear weapon test that they did up in Amchatka for an anti-missile warhead included thorium. That has been declassified. So they use it as a neutron multiplier. Now, this is what Mars looked like in the past before this terrible Holocaust occurred. Next slide, please. So we had a planet that looked like Earth and now looks like Mars does. Only 1,000th, roughly 1% of the Earth's atmosphere remains on Mars, where they used to have an atmosphere that was roughly the same temperature and density as the Earth's. Now, this indicates, because of the size of the explosions, the energy released was roughly 10 to 100 times greater than the Chicxulub explosions, an explosion that wiped out the dinosaurs. So this was a absolutely planetarily devastating thing, especially because Mars is only half the size of Earth. Now, this looks like it was caused by thermonuclear weapons of massive size, as big as the Empire State Building, dropped from space because they were airbursts. There are no craters at the sites of the enhanced radioactivity. So that's very disturbing, but it tells us something important about the universe, that the universe is a lot like Earth. in that respect. It is occasionally a place of great violence between intelligent beings. Now, there's another troubling aspect of the universe. That's called Fermi's paradox. Radio astronomers are looking across the sky all the time, and they expected that if there was intelligent life elsewhere in the stars, and our radio telescopes are very sensitive now, they could detect a Earth-like civilization out 100 light years from here. We would expect that we would point antennas everywhere in the sky and pick up soap commercials, political solicitations for funds, the normal racket that intelligent beings make. Here's a bunch of howler monkeys howling in unison. And this is what we expected the cosmos would be like. Now, they were looking in radio frequencies. I'm sure there is that is not the preferred method for light waves are too slow for technologies that span several star systems. They probably use something like subspace radio, which was in Star Trek, to communicate instantaneously. Well, you can probably do this by quantum entanglement. But our expectation was a noisy radio, a cosmos with a lot of intelligent species like ourselves, making a lot of racket. But our experience is that we seem to live in a ghost town. And one way to explain that is, well, there's two ways. One is to explain that people who are advanced, truly intelligent species out there go radio quiet to hide from the rest of the universe. But that's not the pattern of life on Earth. On Earth, the more intelligent the species is, usually the more racket it makes. The other sad explanation is that a lot of things like happened to Mars have happened out there, perhaps in a bygone age when there was some galactic war or something. Anyway, our experience is living in a ghost town when we would expect to live in a noisy jungle. Next slide, please. So the suggestion of both Mars and Fermi's paradox is the cosmos may be as full of genocide as it is of life. I'm sorry. We must hope for the best, but be prepared for the worst. And this is part of the reason the government is reluctant to end the ET cover-up, in my opinion. They worry that the public will not react well to this discovery that it's a jungle out there. As in Hitchhiker's Guide, it says it's a rough galaxy. And in order to know the truth, you have to be people of courage. I'm sorry. You have to be courageous to face the truth, because not all the truths of life are pleasant. We must hope for the best, but be prepared for the worst. It's a tough galaxy. Next slide, please. Okay. We also have now a UFO situation, especially since 1942, about the peak of World War II, when the Foo Fighters arrived. It is commonly reported many different species visit here. We don't just have one species visiting, we have a whole spectrum of types, some of whom are very humanoid, like the people who are said to be from the Pleiades region. That's 400 light years from here. Then we have the reticulans or grays. They come from 40 light years, 10 times closer. So, but there are many different species. some humanoid, some very humanoid, some very unhumanoid. One group, the Pleiadians, is reported to be quite friendly and very humanoid, suggesting shared genetic background. They look on us as kinfolk. And another group, the Greys, or Reticulans, reportedly from Zeta Reticuli, are reportedly quite hostile, only approximately humanoid, suggesting very different genetic background. So you would expect that intelligence can be found. The octopus has, believe they have the intelligence roughly of a house cat. I know house cats that are smarter than the people who run the households where they live in. And so we have intelligence arising in a variety of physiologies out in the cosmos, as you would expect, but also humanoids such as ourselves apparently are also out there, and that's because the humanoid form is actually a very practical form. So now the Greys are reported to be behind abductions and animal mutilation phenomena reported military clashes. So I ask people who say, well, the universe is benign. I say, what about the abductions and mutilations? And they say, oh, that's the government doing that as disinformation. Well, I'm sorry. I do not think that is a reasonable explanation for what has been seen. Now, the Greys are reportedly creating a hybrid gray human gray race immune to common Earth bacteria. They are transplanting. Why would you create hybrids between such creatures of different physiologies as the humans and Greys? It apparently is due to the fact they are trying to transplant the human immune system to earthly bacteria. They're trying to make a subspecies of their own species that can be used to colonize the Earth, and that colonization would be at humans' expense. Next phase. Next slide, please. So yes, the Earth is a highly desirable planet, and just like a lot of other indigenous peoples on this planet have discovered that when the French fleet arrives out in the harbor, this is bad news. It's a real nice country you have here, or a real nice planet you have here in this case. And they desire it. Next slide, please. Now, our cosmic situation also has to do with our location in space. Our location is in the center of a local bubble or void in the middle of a galactic spur arm. Our galaxy has arms like other galaxies, and we are in the middle of a bridge arm, a bridge spur that connects two arms, two lanes of full of stars. Now, we're in the center of a local bubble. We have reports of visitations by many different species. This strongly suggests we are strategically located in the center of an interstellar neutral zone. We're in the center of the Romulan neutral zone, let's say, from Star Trek. And that's why we get so much visitation from different species around us. And that's also why people find us so fascinating. Next slide, please. If you look at the galaxy from above, the plane of the galaxy, you'll see there is a local void. This was apparently cleared out of gas, star stuff, by an explosion of a supernova a long time ago. The Earth has drifted the solar system, the sun and the solar system connected to it, have drifted into the middle of it. We're almost dead center in this thing. We are almost dead center, and it's about 100 light years across, and is surrounded by walls of stars, where the stars are much more densely packed than they are around us. But all of these stars are familiar to Alpha Centauri, Sirius, and even Zeta Reticuli are within this zone. So we are dead center in this region of few stars. We are reportedly visited by many different races, indicating that the surrounding space is well populated with other intelligent species. And so, yes, we do appear to be in the center of a neutral zone. So we are a speck of dust in the cosmos, one of many specks of dust, but we are actually an important speck of dust in the great game of cosmic monopoly. We were issued Park Place and Boardwalk at the beginning of the game. Next slide, please. This pattern continues in that we are doubly significantly located because the Perseus arm, which is out further from the galactic center, is connected to an inner arm called the Sagittarius arm. When we look into Sagittarius, by the way, in the summer, or Scorpius, we're seeing the galactic center. When we look outwards, when we look at Orion in the winter, we're actually looking galactic out. Now, this spur is called the Orion spur, and it connects the Perseus arm to the Sagittarius arm. And we are almost dead center on this curving spur. So we are doubly strategically located. Next slide, please. Okay. Now, not only that, if you come into the solar system and look at the other planets, nothing compares to Earth. We are a water-rich planet with obviously a big biosphere. We have a big magnetosphere that protects us from a lot of radiation. We are a pearl of great price. I believe we are a rare gem in the local stellar neighborhood. So now, if you own valuable territory, but you are Stone Age people, you actually basically must have had the protection of surrounding interstellar powers. Otherwise, we would not exist. Somebody else would have taken this place a long time ago. But apparently, we have been allowed through some kind of interstellar prime directive and the enlightenment of the surrounding peoples. They have protected us. I think that's the only logical conclusion, since people obviously have no trouble getting here. But the very fact of our strategic location is also part of our protection. Next slide, please. Earth is analogous to Luxembourg in Europe. Luxembourg is in the Ardennes, site of many battles of World War I and World War II. You can see Bastogne, which was the center of the Battle of the Bulge. It's right on its border region. Now, three powerful entities are next to it: Germany, France, Belgium. And Belgium is connected by treaty, since it's right across the English Channel from England. England has always helped the Belgians. They refer to them as the Low Countries. They've always been culturally bonded to them. And in World War I, this is what led Britain to join France in the war against Germany, is because Germany invaded Belgium. But Luxembourg has survived down through the ages, through the Napoleonic Wars and every place else, because it's surrounded by three, or basically England is part of this, four great powers, and they all desire to have this little country, militarily very weak, called Luxembourg, as a buffer zone between them. It solves far more problems than it's worth to try and take it. So Luxembourg has survived, surrounded by three major military powers. It survived because it is surrounded by three major military powers, actually four, including Britain. And no single power could try to conquer it without triggering a war with the other powers. So I believe Earth is in the position of being kind of Luxembourg in this local galactic neighborhood. Next, please. Next slide. Here is U.S. military maneuvering in the winter at the Battle of the Bulge. This is near Bastogne. And American troops were operating near there. Because Luxembourg is a strategic place in Europe, but at the same time, it's remained a sovereign country. They're called the Benelux countries. The Benelux is Belgium, the Netherlands, and Luxembourg. They form a consortium. So Luxembourg has been strategic down through the ages, especially during World War II. And next, I think it is a useful analogy for the Earth's position. Next slide, please. Now, we have an ET cover-up. It's not just UFOs, it's Mars. It's also the fact that they're finding what look like microfossils in meteorites that come from the very dawn of the solar system. They've never been part of any planetary environment. This means panspermia. Life is to be found elsewhere in the cosmos. So we have an ET cover-up. They're trying to cover up the night sky, and they can't do it any longer. They're covering up a dead civilization on Mars, plus a Thermonuclear Holocaust on Mars. They're covering up the UFO activity that we're seeing here, and they're also covering up the fact that the meteorites are revealing panspermia. Now, in the past, the cover-up preserved human self-regard. We could think of ourselves as the top of the pyramid, and that was important. When the UFO thing first started, we had no space program. We had no large nuclear weapon stockpiles. The aliens, by the way, are very interested in our nuclear weapons. And as a physicist, I can tell you why that probably is. They fear them. I don't care what your spaceship is made out of. If it gets hit with a Sidewinder with a tactical nuclear weapon on it, your spaceship will be destroyed. Nuclear weapons use the power of the cosmos that's all around us every night. What makes the stars shine. So if some people have said, oh, our nuclear weapons all our weapons are just toys to them, and then I ask, okay, so why are they so interested in them if they're not important? So next slide, please. Yeah, Tim, next slide, please. Now, the cover-up must now end. Continued cover-up hinders human intellectual development. We can't advance unless we know the truth. The basis of science advancing is data. And if data is being withheld from the scientific community that shows that we're not alone in the universe, that is holding up our science. The continued cover-up helps aliens to perfect hybrids to replace us, the Greys, because if everybody knew that they were out there and coming at night in billion-dollar spaceships to try and abduct people for sperm and eggs, we could create all sorts of situations that would make this very much impossible, and difficult to achieve. Continued cover-up perpetuates the human government's inaction. It completely short circuits any public pressure to do something about the situation we're facing with the Greys, because the government says, oh, there is no situation with the Greys, there are no Greys, there are no aliens, there are no UFO crashes or retrievals. The thing at Roswell was a weather balloon, et cetera, et cetera. So, continued cover-up allows aliens to effect a stealthy takeover. The best way to win a war is without fighting. That's Sun Tzu, The Art of War. He fought in medieval China, and he said, if you're going to take a city with high walls, don't bring up catapults and battering rams and things like that. He says, just pay somebody to open the gates for you in the middle of the night, or put in a Trojan horse like the Greeks did at Troy. The best way to win a war is without fighting. And it's also the cheapest form of war. So what people are trying to do, my own belief, and I've published this, is they're trying to achieve a very cheap acquisition of this planet. And next slide, please. Okay, possible consequence of ending the UFO cover-up. Some alien groups, like the Greys, may react in a very hostilely to the disclosure. They may sink a few ships in our Navy, et cetera, shoot down a bunch of our planes, fly over our cities and terrorize people. But the disclosure will derail their plans for a peaceful takeover. They will be forced off the Sun Tzu optimal path for taking over this place. Humanity must make its defenses both militarily and psychologically as strong as possible. Why do you think there have been so many movies about alien invasions, from War of the Worlds to Earth versus the Flying Saucers to Independence Day? Hollywood has fed out a continual stream of wars with aliens from outer space, and my own understanding is this was encouraged by the US government. A classic movie made by the Japanese that depicts women being abducted into alien spacecraft, a hybridization between humans and aliens, human traders who have gone over to the alien side, underground bases and bases on the moon. That was made in 1957 by the same group that made the Godzilla movies. So that's called The Mysterians. You can get it free on the internet. I suggest everyone watch it. And also, this one rock group adopted the name Mysterians. Was somebody or other in the Mysterians. They had a few top 40 hits. So humanity must make its defenses both military and psychologically as strong as possible. This is the best way to deter a war. Sun Tzu and von Clausewitz. Sun Tzu wrote about war in medieval China. It's heavy on very psychological ploys and razzle-dazzle. Von Clausewitz wrote about war in Europe against Napoleon. He had been part of the Russian repulsing the Napoleonic invasion of Russia. He also was the chief of staff, one of the generals involved in the Prussian army at the Battle of Waterloo. You couldn't do razzle-dazzle on Napoleon. You couldn't use psychological ploys on him. He was too good. All he cared about is how much artillery he had in which places, and how much infantry he had, and how much cavalry. That's all he cared about. And you could not fight Napoleon without suffering heavy casualties. You just had to accept that fact. He would never give up, and his troops were too dedicated to give up. So, now, the best way to deter Peace through strength, unfortunately, has been true all throughout history. Von Boss, Van Clausewitz, and Sun Tzu agree on that. The best way to deter a war with an enemy is to make yourself as strong militarily and psychologically as possible. Next slide, please. Okay, humanity is in a good position for disclosure now. Human technological advances, our reputation for being very violent, what were once vices are now virtues, and location will help deter war. Due to sci-fi movies and books, humanity understands that it's not alone. They understand it, maybe not at the conscious level, but at the subconscious level, at least. They're aware of the possibility. Humanity is now spacefaring and has large numbers of advanced weapons and reverse engineered UFO technologies that they've acquired during the last 80 years of the UFO cover-up. Now, if a bunch of aliens from outer space invade, and this scenario was discussed by Philip Corso, he said that the US government and the Soviet government during the Cold War had an agreement under the table that they would be allies if they were invaded by the Greys, which were an enemy that both nations, both alliances knew about, the Warsaw Pact and NATO. And one of the reasons they stockpiled so many nuclear weapons was basically to wire the house with dynamite. If the bank tries to foreclose on it, you can invite them in for coffee and say, yeah, you're going to try and seize the house. I have the detonator switch right here. I'll blow the whole thing up. Now, that's obviously not an optimal defense policy, but it is effective. As it says in Dune, he who can destroy a thing can control a thing. Alien war might go nuclear, destroying the Earth and humanity rather than resulting in its capture. They don't want that to happen. They would lose a bunch of people and machines for nothing. The Earth would be a radioactive frozen wasteland, useless to them. Because of our strategic location, war at Earth will become interstellar also. Any overt move to try and take the Earth violently and openly will involve our neighbors who want this place to remain neutral. Luxembourg will be defended by the French, the Belgians, and the British if the Germans try to invade. That's what happened. Next slide, please. An analogy. American War of Independence. War began as a war between Britain and American colonies. The war ended as a world war with France, Spain, and the Netherlands fighting Britain alongside American colonists. Britain had a lot of enemies, and it was the reigning superpower, and the lesser powers wanted to get even for previous wars. So the British effort was also hindered by logistics of supporting a large force across a stormy Atlantic, attacks by Allied navies, and dogged and effective American resistance. Nobody helps people who won't help themselves, by the way. That's a rule on Earth, and it's also in the cosmos. Next, please. Logistics. The people in the American colonies knew they had a fighting chance to get, if a war with Britain occurred, because the Gulf Stream pushes all the ships. It's the prevailing current. It pushes all the ships across the Atlantic towards Britain. To sail from Virginia to Britain took about 2 weeks, but to try to sail the other way took 2 months. It took 2 months for the British to ship supplies and people across the Atlantic. Half the troops on the crowded ships would die, all 3/4 of the horses, and most of the supplies would spoil. And not only that, is the prevailing winds were against the British when they tried to cross the Atlantic to bring troops to the American colonies. And the American colonists knew this. They also knew, next slide, they also knew that the British Army was not invincible. They'd seen the British Army routed at several points in several battles in the French and Indian War, which the American colonies fought alongside the British. This is Braddock's defeat. Here's the French and Indians taking advantage of cover. It's a very non-European war way of fighting, and it was a disaster for the British. Next. If hostile aliens could have taken this planet by open war, they would have already done so. We are being protected, apparently, by friendly aliens out there who are also major powers. That's the reason we've been allowed to develop our culture without a lot of alien interference. Next slide. Now, what is the human future going to be? I believe in all my heart that we will get through this difficult period, and we're quick learners. Once the cover-up ends, that frees up so much intellectual resources to analyze the captured technologies we have and invent new ones. I myself work on unified field theory, like Hal Puthoff. Our theories, we've both come up with very similar theories for how to change gravity with electromagnetism. Basically, gravity is the curvature of space-time. You can change it with electromagnetism because the space-time itself fabric is electromagnetic. And I believe the future of the human race will look like Star Trek. Now, Star Trek, I'm just using that as an example of a positive view of the future. It was, of course, a product of its time. And but I believe we're going to go up to Mars, find out exactly what happened up there, and learn from that to make sure it won't happen here. And then we're going to develop warp drive, and we will eventually join a fellowship of enlightened species in the cosmos. Next, please. In summary, the message from science and antiquity is the Earth and humanity are reflections of the cosmos, not aberrations on it. As above, so below. Evidence from Mars suggests planetary genocide occurs in the cosmos. Reports from ufology suggest both friendly and hostile aliens are here. Location and makeup of Earth suggests we occupy valuable and strategic real estate. Humanity is now in a good position mentally and technologically for disclosure. So I believe disclosure should happen. Human destiny is to join a community of enlightened interstellar peoples, as was depicted in Star Trek. And I believe that concludes my talk. I don't know if I have any time for questions, but anyway, thank you very much. I know some of this has been kind of jarring and disturbing to many of you, but we have, Tim, with your permission, some time for questions. Now I'll try and answer them as best I can.
Yeah, I think we have a few minutes. So let me take the slide thing down. And so we went over because you came in late. So we're actually not at, we're a little bit off.
Oh, I understand, Tim, and it's my fault.
There we go. There we go. Let me bring everybody in. So first things first here, we need to give Mr. Brandenburg, Dr. Brandenburg, an enormous applause. Dr. John Brandenburg.
The sound of two hands clapping, unlike Zen, where it's the sound of one hand clapping.
No, thank you. Thank you for presenting that. Thank you for, it gets more
I'm sorry,
it's as you do research. So
I will, I've worked in defense, energy, which was is always been part of defense, and defense all my career as a plasma physicist. So I recognize, and I came from my father was a combat veteran of World War II. All of the uncles on my mother's side were in the combat infantry. One of them didn't come home from World War II. I'm named after him. These things shape one. I grew up during the Cold War. As one person put it, if your head is a hammer, everything looks like a nail. So I will concede that because of my background, both as a family and historically, and my professional career, I tend to look at things a certain way. And I realize that that limits me. Other people may connect these dots that we're seeing in a different way. But I've given you the best way I can connect the dots of our present situation in the big picture is what I've presented.
Well, John, thank
There.
you. So let me take questions from the guys. Anybody, you guys have questions? I'll go over to the comments here thing too.
Yeah, I'd love to ask a few questions. It was a really fun presentation there, man. But
yeah, Shiva, go for it. Go for it.
Yeah, Shiva.
I didn't catch where you get all this information from. I mean, is it?
Well, I'm 70 years old, and I've worked in defense / energy and space propulsion for 40 years. I mean, more than 40 years, probably 45 years. So I worked in Washington, D.C. for 15 years for the Pentagon and certain import-export agencies, you know, the intelligence agencies. I was a scientific consultant. They would bring me strange stuff, you know, having to do with the Russians and things. Because of my interest in Mars, people would confide in me a lot of stuff. So let's just put it this way. I heard a lot of interesting stories around the coffee machine and the cooler, and I turned that into a science fiction novel called Morningstar Pass, The Collapse of the UFO Cover-Up by Victor Norgard, pen name. So I will just simply say that I picked this all up because of the community I worked in. I was not part of the UFO cover-up per se, but I heard interesting stories from people who were apparently in part of the UFO cover-up. So there's Shiva. Shiva, the destroyer, creator and destroyer.
Absolutely. Destroyer of ignorance. A thing standing.
I heard he destroyed a lot of other things.
Yeah. Well, let me
including a lot of Earth girls' virginity. Yes.
I'm gonna run into the. I need to run out of the studio for just a moment, so I'm gonna remove myself. I think is Mark here. Mark's not here, but I'll leave it open for you guys to do questions. I'll be back in just a moment, guys.
Okay, John, I had a question for you, John.
Yes.
So I was wondering about the earliest time you can recall getting any inkling of the nuclear stuff happening on Mars, because there was a book written by one of the guys from the CIA's Stargate program, the remote viewing program.
Yes.
And Joe McMoneagle. I shared a link to his stuff, and he talks about it in 1984, and he wrote the book about it in 1993. And I thought 1994 was the earliest when you started. So I was just wondering if you could touch on if there was any stuff there.
I'll give you a quick rundown on the evolution of my thinking. My mother was fascinated with the whole UFO question when I was growing up. And of course, a lot of UFOs were seen. I even saw a UFO over Medford, Oregon, where I grew up. Everybody else in town saw it too, because it was reported in the newspaper the next day. It was just basically a disc-shaped thing that was in the sky and moved around and disappeared and then reappeared and then left. And it was the same period where there was the swamp gas thing in Michigan, the swamp gas sighting, you know. So I was very much, but then the first animal mutilation occurred. I was so horrified by that at the age of like 17 that I basically decided, people from outer space would never do such a thing so terrible. And then the Condon report came out. It was 1969. Yeah, I think this was, and the Condon report basically said, move along here, folks. There's nothing here to see. And because of the animal mutilation, the Snippy the horse in Colorado and the Condon report, I decided not to be interested in UFOs anymore. I went into denial. And then since I became I wanted to become part of the defense establishment, like my uncle who'd worked on the Manhattan Project. He was a nuclear physicist, and named William Siri. Helped found the Sierra Club, marvelous guy. He was my uncle. He was my inspiration. I ended up at graduate school going to at Lawrence Livermore National Lab, and we were basically told there are no such things as UFOs. Don't even talk about them. And we said, yes, sir. Please sign my doctoral thesis so I can finish and go get a real job and buy my wife a nice house like I promised her. It was one of those transactions. If you're working as a graduate student in a big government lab, and they tell you there's no UFOs, and you just play ball. I'm sorry.
So when did you get the date, the year when you?
Oh,
first
the
got
date.
your
No, I'm
Mars
sorry.
thing?
Yes, that's so. When I was I became swept up in a Mars investigation because we went through a nuclear crisis called Able Archer, 1983. You can look it up on Wikipedia. We were as close to a nuclear war as the Cuban Missile Crisis. This occurred when I was at a new nuclear weapons lab called Sandia Labs in Albuquerque. The public was never aware of how close we were to a nuclear war, unlike the Cuban Missile Crisis. And the morale at the lab, it came out, the Able Archer crisis happened just after the nuclear winter thing came out. Morale at the lab collapsed. People were obsessed with the idea that their families would perish in a nuclear war along with them, that there was no safe place. You couldn't flee to the hills. You'd die of cold and starvation after the nuclear war because of the nuclear winter. So morale collapsed. I was kind of in despair because I thought after Able Archer, because we knew what was going on, because we all had security clearances, that gosh, we were going to have a nuclear war by accident with the Russians. And so I was at Christmas break, and then I saw the work of DePietro and Molinar of the face of Cydonia, their analysis of the two images they found. And suddenly I had hope that we could end the Cold War. So I became part of an investigation of other scientists and engineers to investigate the objects found on Mars at Cydonia Mensa, and we also found the ones at Galaxis Chaos. We found the ocean, et cetera, et cetera. And the headquarters for that investigation, called the Independent Mars Investigation Team, was at Stanford Research Institute. And as it turns out, the headquarters for it, and I actually visited the headquarters at one point. It was a room with all these Mars maps on it and two scientists working there. It was right down the hall from the remote viewing thing where McGonagall worked. So we found out about the nuclear war on Mars because of comments of people who looked for nuclear weapons effects at Sandia Labs. One of them told me Mars looks like it has been nuked because of the isotopes. I shared that with the rest of the team. So about 1984, we knew. This is all recorded in a book called The Face on Mars by Randy Pozos. And so then that also was picked up apparently because it was just down the hall. The remote viewers found out about this and investigated themselves. They conducted a parallel Mars investigation. And so I found out about the same time as the remote viewers, and it could be just synchronicity. It also could be that they found out because we had found out and the news just spread down the hall. So 1984 was the year.
So, John, I have a question. If I can jump in like that.
Sure.
So, a little while ago, we had Sal Pice on the thing, and I guess he can't talk much on these topics anymore. But he mentioned they hate us. I thought he maybe meant China or something. Does he mean the aliens, or what's he talking about?
Well, one group, at least, there may be several groups that hate us, but one group prominently, the Greys, I have heard from people in the military part of the cover-up that they are one person described them as an extraterrestrial threat whose existence is classified. So other people out there are very friendly to us, apparently. I think the reason we're even having this meeting and be able to talk about this freely is because we've been protected. There's sort of a NATO alliance you could think of protecting this place. But let's say if the Greys do a stealthy takeover, then what are the other aliens going to do? Are they going to start a nuclear war, an interstellar war over a non-violent takeover? No. We must help ourselves in this, and one of the ways we help ourselves is to end the cover-up. And by the way, I will also say I am for a blanket pardon to be given to everybody in the cover-up as long as they tell us what they know.
As long, like kind of like in South Africa, right?
Exactly. South Africa is a good model for that. Everybody.
Truth and reconciliation.
Yeah.
So Aiden had a question too here, if that's all right.
Can you?
Yeah, that's quite all right. Yes.
Can you trace any of your information on the Greys back to like the Reagan administration? There was.
Oh yes, we were very aware of the. We were working. I was working for a defense contractor around the Beltway in Washington, D.C. when the Reagan statements were made. First two statements, we thought this is just Ronnie spinning an Irish tale.
Yeah.
And then the third time he said it, we all started looking at each other and said, is he trying to tell us something? Fourth time he said it. He said it 4 times. This spoke of the scenario of the United States and the Soviet Union being allies against an alien invasion. We realized it's like he's trying to prepare us for a possible emergency announcement. And not only that, by the way, guys, you got to understand, he wasn't just talking to the human race. He was talking to the aliens also.
So interesting. The follow-up question is, like, personal belief is that the Greys they come in tall ones and short ones, and the short ones are a biological computer or a silicon-based life form that has several different forms.
The coyotes eat them, so they can't be silicon. They must be. I think they're.
Coyotes will eat anything. I'm from New Mexico, and if it smells good, they will try to eat it. So
yeah, they say the vultures and the coyotes eat their bodies. So just like they do for people.
They do smell. They smell. They have a sulfuric.
Yes,
the short ones, but the
and
tall
when
ones are.
I also heard when they die, they get ripe really quick.
Okay.
You know, in an hour or so, they start to really smell even worse.
Do you know anything about the internal biologics or the structures of the short ones, like because the telepathy has got to be technology based, like neuro.
I'm not really privy to that sort of information. I just it is possible that their blood pigment is not based on iron, it's based on copper, which is a hemocyanin, which is found in insects and octopi. And obviously in octopi, it supports a very advanced nervous system. And so that's another solution that nature came up with for how to make a blood pigment that carries oxygen. And that would explain their gray color, because the hemocyanin is not red. It's blue. It's blue to sort of gray, blue to blue gray.
Yeah.
Can I have a couple comments?
Yes. Please, Dan.
You had 2 points that I really kind of wanted to hit on. So I liked what you mentioned about the possibility of the Soviet Union and Russia, or not, excuse me, the Soviet Union and the U.S. kind of being like in a quasi alliance.
Yes.
And that kind of this was my second impromptu thought, and I'm just getting it out of the way quick. It reminded me of the Putin interview recently, where he talked about how he attempted to join NATO in the 90s, but it never went anywhere. So just that's a
yes.
side note. But the thing in your presentation that you that really stuck out to me was your analogy to Liechtenstein. I was wondering if you
no,
could,
it's Luxembourg.
or Luxembourg, excuse me. I was wondering if you could
Luxembourg,
expand
by
on
the
that
way,
analogy a little.
curiously means city of light, just like Paris. And also Brandenburg means city of light. Brandon means like firebrand, like bright. City. Berg means hill or city. So Luxembourg, Lux, as in, luxurious, it means bright city, interestingly enough.
So you essentially mean that we're kind of, in your analogy there, we're kind of like in our own little geopolitical pocket where we're not 100% controlled by any one of these factions. Can you explore that idea a little bit for me? I'm curious.
Well, I mean, if anyone's running this planet, they're doing a terrible job. This place looks very chaotic, very disorganized. It's the human race. It's always, and you'll notice, there were no spaceships arriving in recorded history and taking over places. Maybe very in distant antiquity, there was apparently a nuclear war in India between two rival groups on Earth. That's one reason they believe, and that's recorded in the Vedas or the Bhagavad Gita. And that's one reason they say Oppenheimer knew an atomic bomb could be built, is because he'd studied the Sanskrit of the Hindu documents, the Bhagavad Gita, and there's a depiction of what looks like a tactical nuclear weapon, brighter than 1,000 suns, being used on a Bronze Age army. It's just terrible, a terrible depiction of the effects of the blast, and also then the aftermath, the radiation. And so he was very aware of that. And they say that when the first atomic bomb was set off, he commented, "This is the first time in modern times we've had nuclear weapons." That's a quote that that is attributed to him. So I guess have I answered your question?
Yeah, no, I appreciate that.
Yeah.
Shiva's got a question.
Hey, so I can't be the first one to notice this, but have you watched Stargate SG-1, that whole long series? Because there seems to be a tremendous amount of overlap in what you're saying and what was there. So was that like a disinformation thing where they're like, hiding the truth in plain sight? Because, these different...
Shiva, there is so much smoke and mirrors out there. And,
that one, the Grace of the Good Guys.
What's that?
Oh, the
Asgard.
The Asgard, yeah, and then in SG-1, the Asgard are good guys. The Greys are the good guys in that one.
Yeah.
Okay, well, in the Lord of the Rings, they're the orcs, basically.
There.
Yeah, the orcs are apparently modeled after the Greys, and it's just one way to hide a penguin is to a particular penguin is to put it in a room full of other penguins, and we're dealing with people who sit up nights trying to fool the public, and in fact, Winston Churchill put it this way. He said, "In wartime, the truth is so precious, it must go everywhere, accompanied by a bodyguard of lies." And the people involved in the core of the UFO cover-up view this as almost a war situation. So it's at least a Cold War situation. So they take pride in these clever things they come up with.
So here's a question: do you believe in that syncretic, idea of all these religions, like the giants, the Jotun, and all of the Aesir gods, or there's always these two sets of gods, like the Olympians,
yes,
like that. All of them are references to something that's like Atlantis and Lemuria, and that all of these stories are all based on something very ancient, where they're just kind of abstracted it and given them different names, but they're all the same story. And then you can like find all these characters and these ancient gods and Babylonian myth and going all the way back.
Absolutely. You know,
are these real historical characters theoretically?
One of the things that fights Shiva against, you know, us ending a cover up is the human love of embellishment. And, you know, people have asked me, well, I wrote the science fiction novel where I put all the stuff I'd heard into the science fiction novel, where two beautiful women who are journalists, they bring down the UFO cover. They're very brave, by the way. Both of their lives are ultimately in great danger. And, but anyway, it's actually, it's Athena and Aphrodite. Those are the archetypes. I only discovered that after I wrote it. And I was watching Flash Gordon, the original Flash Gordon series, and you got a dark-haired Princess Amora who's after him, and then you've got, of course, Dale Arden, who's this blonde damsel in distress. And but anyway, I'm just saying, the human race, if it has a blank area in a story, it just fills it in with an embellishment. And of course, all information regarding the UFO cover-up is fragmentary. I complained to a friend of mine who was editor of UFO magazine, and I said, his name's Don Ecker, former Green Beret, and I said, Don, the problem with ufology is there are no facts. There are only reports.
Hey, by the way, Aiden wanted to give a shout out to Michael Stratt recently has done a breakdown on the Greys.
Oh, great. I'll be looking for that. Where can I get access to that?
I think it's on his public YouTube channel. I don't have it memorized.
Stratt?
Stratt, yeah. He was
Stratt.
SCHRATT. Michael Stratt.
Okay. Here, let me write that down.
He's been in ufology for a while. He was worked with Mark McCandlish. He knows the ins and outs of Lockheed Skunk Work, so he's one of the technical guys. So his
okay, could you give his last name again? It's
Stratt.
S.
I wrote it down in the chat here, but also, yeah, I mean, just from my perspective, he seems to have one of the most comprehensive databases I've seen on like the UFO reports that are the credible ones.
That's Marler.
Oh,
I think the cover-up is more like an earthen dike, and it's starting to spring all these leaks. And the more it leaks, the more it leaks. You know.
Yeah.
There'll be finally an outrush of data as everybody decides, well, they can't kill all of us. You know, and they'll start talking.
Yeah, Michael Stratt's data has some of the more actionable details that I've seen.
There you go. Actionable info.
Actionable details.
Yeah.
There is a branch of intelligence, by the way, that's called rumor intelligence. And that's how they found out about the V2 rocket during World War II before it was ever launched, is they'd heard rumors of it. In the French resistance had heard rumors because of these German officers talking in French bars about these wonder weapons coming and stuff like this. So the British and the Americans were alerted to the possibility of giant rocket weapons.
Yeah, and then these days they have conditional responses. So you like think about things as a chess game, and you're like, if this case is true, then here's our optimal response. If this, it ties into game theory and all that.
Yeah. Yes.
Like companies use this, nations use this, but yeah, you're like, okay, here are the set of likely possibilities for each of these. What's our optimal play? And then when one of those scenarios happens, then you choose that response, and you don't like just decide, oh, this is the case or that's the case. You say we can narrow it down with reasonable probability to this set of things, and then you choose your response accordingly. And at the individual interpersonal level these days, people should be doing that a lot more too. But it's mostly at the current time, it's mostly just nation states and things, unfortunately.
Sure. instead of consulting the Oracle at Delphi, we have these elaborate AI systems now that we're consulting, and
Pretty
I
much.
don't want to get into how I feel about that, but that's okay.
Yeah. Hey, John, have you seen Person of Interest?
No, I have not.
It's that one's got a surprising amount of documentary stuff in it at this point too. It's a TV series about some people who make a predictive AI like that.
Sure.
Check it out. It's a good show.
Well,
I will. By the way, I will also say there is another factor in this that must be discussed. According to what I've heard, and I don't know how reliable these reports are, but based on what I've heard from people I used to work with in Washington, D.C., and the various import-export agencies and stuff, is the U.S. government does not feel completely free to end the cover-up, because some of the alien groups who are taking advantage of it have said, if you end the cover-up, we'll consider that a hostile act. Now, they could be bluffing. They don't have enough to have a real war here, and especially because they haven't planned on one. And but that's one problem, is the government may be being blackmailed by some alien groups, the hostile ones, that if you end the cover-up, terrible things will happen.
If you can figure out how to cause vacuum decay, you can always just say you figured out how to cause vacuum decay, and then what can they do at that point? It's just like, oh, we'll just decay the universe. That's the ultimate dead man switch.
Oh, well, there's all sorts of dead man switches. The Russians were famous for having one that would basically just detonate all their.
Crazy, man.
What's that?
Dead hand? No.
Yeah, the dead hand, the Russian dead man's hand, and because they're afraid a first strike would decapitate their entire command and control system, so they were just going to detonate all their weapons just in their silos, and the radioactive cloud would kill us. So yeah, there's it's this Dr. Strangelove sort of stuff, and anyway, but I don't think that's going to happen, because that's in no one's interest, not even the hostile aliens. They want the planet and us intact, and otherwise they would have wasted all of this resources for 80 years to capture a frozen radioactive wasteland. That's no good to them. They don't want that to happen. And so it's just it would also be very noisy and would attract attention from their powerful neighbors. And so no, I think we have a good shot of getting through this by hook or crook, and God, guts, and guns, and we'll end up being the Luxembourg of the galaxy, and that's what I truly believe, that everything's going to be fine in the end for us. We'll have our own starships, and oh, by the way, one of the other things that's going on is there are factions in the government fighting. There's factions that want the cover-up to end. It's my understanding the CIA, believe it or not, and the Defense Intelligence Agency, DIA, and also the Navy wants the cover-up to end. And part of it is the Navy wants to be the Deep Space Service. Guess who's lined up to be the Deep Space Service now? It's the Air Force. And you'll notice the Air Force has been utterly silent about all of this stuff. But all of the stuff like Gary Nolan and everybody who's connected with the Navy has been talking about, and all the videotapes, they're all Navy tapes. The Navy is releasing all this stuff. The Air Force, though, silent as the Sphinx. There are no UFOs. There are no aliens. If they were,
Yeah.
we'd tell you about it, right?
Well, guys, it's 5:45.
5:45. Very good.
Should we keep? Okay, but do you guys want to go into? So John's. It's been about a half an hour. So because you started it, I think.
Yes, yes,
4:15.
and I
Okay, well,
thank you all for being so gracious.
Yeah. Well, let's put our hands together one more time for Mr. John Brandenburg.
Thank you very. I'm just doing my
John,
job. I'm just doing my job, guys.
No, you are amazing. You are amazing, and you were legendary. So again, thank you so much for presenting and for doing the Q&A. And I want to get our schedule back on track a little bit and try and finish up our lab updates. And that was so okay. Well, who wants to go
By the
next?
way,
for lab?
I'm very active. I'm very active on X now because
that's good.
And so that you guys can join the dialogues on X. I try to respond to people's comments and with my own comments and make it a discussion. Also, if you want to find out more about Mars, you can have a look at blueplanetred.net, blueplanetred.net, written all as one word. And that is a documentary they made about Mars, its biology, its culture of archaeology, its biology, its archaeology, and the nuclear holocaust, or whatever happened. There's another theory. It was some kind of freak lightning discharge between planets. By the way, that happens in big nuclear weapons explosions. By the way, it triggers massive lightning bolts. So it's anyway. So Blue Planet Net, and check out the big rockets discussion going on X. No one's called me a chimpanzee on a rampage yet, but that's coming.
Yeah, and John, I'll put a subscribe intent. That's just a simple link. People click on that, they can subscribe. I'm going to put mine up too. Here, I'll put mine up right now.
Oh, very good, very good.
Yeah.
Yeah, I'm PhD Brandenburg.
Ah, okay. PhD Brandenburg.
Anybody have any other quick questions? David, you look like you've been itching to ask a question. Have you got a question?
Yeah, I was actually curious. Are you aware of any maybe black projects of humans that might be related to sort of blackmailing governments? Do you think it's possible? Is it just aliens?
Sure there's my understanding is during the Cold War, they had so many black projects that were compartmentalized that there was some worry that there were projects out there that that didn't report to anybody, and nobody knew what they were doing, and no one could find out either. It was,
So how do you like subject those sorts to ITAR? Do you just do they just hide them in shell companies and ship them off Earth?
I was never in any part of any deep black programs. All I heard was these stories of people opening up black compartments, and people are trying to reinvent the wheel in there. It's just crazy stuff that was going on. There was no technical oversight. There couldn't be, because that means you'd have to have some smart people get security clearances, and that it just there's in my novel, one of the heroines asks the hero, he's part of the UFO cover-up, he's part of special forces in the cover-up, and she says, is the situation in the snafu situation in the UFO cover-up? And he says, oh, we passed out a snafu 10 years ago, he says, and we're far beyond FUBAR now. If you know what those acronyms mean. He says, we're in a nameless place now, because the people in the special forces, the military people, feel like the whole situation is spun completely out of control. They don't know what's going on. So anyway, Tim, thank you. It's been a pleasure and honor speaking to all of you and being on the APEC conference. So yes, I will now just start watching whatever you guys are going to do next.
Awesome. Well, John, thank you again. So let me see. If we're going to lab updates, who wants to do a lab update first? What I'll
Lab
do is-
update.
I guess I could show you a few things.
Okay, yeah. Michael, I'll put you on solo.
Yes,
leg.
Michael, I've been promising you a theory of superconductivity here for a long time. I'm going to finally produce it here.
Hopefully, yeah. I mean,
Okay.
we have vacuum furnaces. We can make stuff. If you have a hypothesis for us to test, we can make that material and try it out. So yeah, at the moment, we just got this thing assembled, very simple setup, and it simulates explosion welding on the small scale. Because like all these people were saying, oh, the bismuth magnesium material, humans don't know how to make this. But I've worked on cold spray, I've worked on other technologies, and like we can definitely make it. So it's all it is just a block bolted to some wrought steel, and then you have a pin here that's made of machine steel of the appropriate hardness, and then yeah, you put your layered bismuth magnesium samples in there, and you hit it with a hammer. And Aiden built this thing, but we had this sort of thing at another company I worked at previously for testing cold spray capabilities.
That's my original piece from back in the summer.
Aiden also made this with forging, but I don't know.
I heated it up, and that's what you're seeing. Some of the little things that's given Michael.
Yeah,
we need to get to the aqueous stuff soon.
Yeah, we should because we have the capability here to coat magnesium with the bismuth, like nanopowders and stuff now. So we'll be getting to that soon, and micro powders as well. So, but yeah, once we have that, we can put it right in here, hit it with a hammer on top, or we'll just like pull a weight to a set height, so it's always the same amount of kinetic energy. And yeah, then it's just like the amount of energy in there, since it's a small cross-sectional area, is similar to explosion welding, and you get nice compacted layers. It disrupts the oxide layer, and the metal bonds before the oxide has time enough to reform again. So yeah, I mean, we'll make bismuth magnesium layered materials. If anyone wants to test those out, we'll probably just put them on the eBay store, since it's easy enough to just crank out a bunch of these for anyone who wants to test this stuff. Supposedly, it's a terahertz waveguide. We will see. What else is there? Yeah, just like here's a deep eutectic solvent. So we dip the magnesium in this bismuth chloride deep eutectic solvent, and then depending on the do you mind turning off the sound there? Thank you. Sorry, Aiden's also watching the thing. So, but anyway, what was I saying? Yeah, so you get the deep eutectic solvent with the bismuth chloride, and you just shove the magnesium metal in there. It slightly corrodes, and you can control the corrosion rate with corrosion inhibitors and surfactants and all sorts of things. And you can tune the shape, the size, and the smoothness of the bismuth coating that you end up getting at the end of that. So what else can we show at the moment? We're still playing around with Bahianite. I don't know if that fellow who's going to make the spaceport is around, but yeah, this if John Brandenburg's still around, so this Bahianite material, there is a deposit of carbonado diamonds that's about 2.2 something billion years old, which appeared on Earth around the same time as the Great Oxygenation Event on Earth. And this Bahianite mineral also appears with that carbonado diamond. We know that carbonado is extrasolar because, well, someone did some isotope testing on it, so it's not from the solar system. And the Bahianite, it's relatively common minerals. It's a common elements. It's aluminum, antimony, and oxygen, hydrogen. What's interesting is it seems you can make it as a concrete, except it's got the hardness of sapphires. Also, interestingly, it has an ultra-high emissivity, and it very, very slowly evaporates at high temperatures. So it would make an excellent heat shielding material for reentry. So what I'm hypothesizing, and what I recommend, John, if you're interested in investigating, I'm hypothesizing that these carbonado diamonds are traces of potentially an ancient terraforming probe that may have introduced photosynthetic life to Earth in that time frame. And if that's true, we should be able to find traces of gene drives or gene editing in blue-green algae from that time period, if we can have any confidence in the stability of its genomes over that scale of time. But yeah, it's interesting. And what else can we show off? But yeah, for if someone's playing around with hypersonics, try this as a heat shielding material. Why not? It's super structural, at least until it starts evaporating on the surface. So I don't know. That might take some iteration in design, like development. But yeah, it's interesting. We are also trying to sinter boron nitride for various high temperature applications. That's in progress. Not too much else that's fun to show. Yeah, I think that's it for now. Any questions?
And Michael, thank you. I don't have my earphones in because I'm recharging them. Let me put those back in.
Shiva, did you have a question?
There we go. That way we won't.
Actually, that was just me trying to get my my camera to actually focus.
John had a question for you. John, go for it.
Go ahead.
Yeah, let's see. I just wanted to make sure I understood the chemical you're looking at for the heat shield material is carbon.
That's carbon. It's called bahianite because it's originally type locality mineral from Bahia, Brazil, which is in this case extremely. It's very close by to the Carbonado deposit. Although I think the
I'm sorry. What is Carbonado?
Carbonado is a special type of diamond that's highly polycrystalline. And we actually looked at some of the Carbonados from Brazil ourselves, and those have small acicular grains of what appear to be titanium. And other people have reported vanadium and chromium, all excellent nitrogen getters. So it looks artificial. And like all those nitrides, they'll get the nitrogen so that it doesn't interfere with the diamond sintering process, and then all of those nitrides structurally reinforce the polycrystalline diamond. So it looks engineered.
Yes, it does.
Yeah, it's worth a look if you have resources to look at it.
Amazing.
Yeah, 2.2 billion years ago, someone might have been here seeding photosynthetic life on the planet.
Well, by the way, I'll tell you a little debate. And thank God it was a short debate. Somebody was saying, this or that group on Earth is extraterrestrial, and I said, we're all extraterrestrial. I mean, if you believe panspermia, we owe all of our genetic material from outer space. And, and then of course there are the recent stories of, I said, claiming that Irish are extraterrestrial is ridiculous because they have red hair and green eyes. I said, we're all part of everything. I'm sorry. The way the human race has always been, in fact, I say, the human race, whenever it encounters a new ethnic group, there's always the tingle to mingle, as I call it, because the exotic is erotic.
Well, we have to keep it clean, though. APEC is family friendly. We're mostly.
Please. I'm sorry.
Yeah, I have to slap John on the hand again.
There's my hand.
He gets too excited as a writer.
Anyway, guys, I'm in the middle of packing to move to Oregon, so I'm going to have to.
Yeah, no, John,
I wish I could spend more time at your wonderful conference, Tim. You're just doing a commendable
John,
job bringing us all together.
Thank you so much. Thank you so much for joining us.
Thank you so much for letting me come and speak.
Well,
all right, you guys, onward and upward. Live long and prosper, all of you.
Let me go to Jared, if that's okay. Jared, do you want to do a lab update on the Graviflyer?
Yeah, it'll be real brief. We can go to Curtis right after that.
Okay, Jared, I'll stay until you give your brief thing.
So, new Graviflyer, bigger. Old Graviflyer, smaller. That's the same size as the one that the original inventor said that all of his that he made. But the center disc on it was thicker because it was all I could get. But this one, all the thicknesses are the same as what he said it should be. The difference is that the diameters are larger, so it has more flop as it runs, which is a really good thing because latest breaking news, part of the reason why I might have seemed a little tired today is because I stayed up all night reading this book on Tesla coils because I'm realizing that the Tesla coils that Alexa uses are very, very out of tune. They're detuned almost to the max. And when he says that he hears a sound, special sound coming from the Tesla coil right before it's getting ready to take off, it looks like all my calculations are suggesting that that is the primary coil on the Tesla coil actually electrically and physically vibrating at the same frequency that the edges of all these discs are vibrating at. So the edges of all these discs, they vibrate. They got lots of charges on them. So that changing capacitance, that changing frequency, just so happens to be at the same frequency that the primary is also changing at. So you get this massive buildup of energy that when you turn off the ultrasound to make it lift up, that ultrasound is damping the vibration of these discs. So you turn it off and all of a sudden the discs can start vibrating at the same frequency that the primary is vibrating at. And so you get this big release of energy that ultrasound was also damping for the power transfer from the Tesla coil to the Graviflyer. So all that said, last part, 20 minutes to an hour before APEC today, I went to my local ham fest, my local ham radio fair. I highly, highly recommend that all experimenters should go visit your local ham fairs when they come around because you can find absolutely insane deals. For example, this is a capacitor. This thing, this 20-pound thing is a capacitor. This is a 45 kilovolt, 30 to 600 picofarad broadcasting station capacitor. It's got a lot of kilu volts on it. Anyways, so my hope is that I can optimize and maximize the Tesla coil power transfer deal that I think is going on here. To, in the words of the great Todd Desiato, I don't want to see this thing just bounce up off the ground. I want to see it shoot through my roof. So if I can make a Tesla coil that gets its power transfer factor more optimized to the changing capacitance and vibration of the discs, we should be seeing some really cool stuff. So that's the latest and greatest that I got.
Awesome. Jared, thank you. Thank you. Sorry about that. I lost my control there for a minute. Okay. So let's go to, if it's okay. And Curtis has been, Curtis was hiding. Curtis, my apologies, sir. Curtis, do you have a lab update for us? Do you want to do one?
Sure, but it looked like John had a comment.
Oh, yeah, John, go for it. Oh, John's muted again.
Get back to this packing business otherwise. So I just wanted to ask Jared, okay, have you got anything to duplicate the behavior in those videotapes, which was quite remarkable?
Yeah, so there's about 20 different effects of different kinds and different things in different places that she said you'll see. So I've gotten, let's say, at least 75% of those replicated. Unfortunately, the last two things to replicate are overdriving the severely detuned Tesla coil to make it sing and then the lift that happens right after that. So the most important 2 steps, the last 2 steps, I haven't gotten those yet, of course, but I have gotten everything else up until
All right.
that.
Keep trying, make it fly. Guys, and I'm afraid I'm going to have to depart because of this. Moving is chaos, as you know. So, and I hate doing it, but I have to do it. So anyway, live long and prosper, you guys, and you guys take care. I got to go, unfortunately. So let's see, leave studio.
Okay, so let me see. So let's go back to Curtis now. Curtis,
Sure.
go for it, sir.
Yeah, so let me share I uploaded this present slides. There we go. Is it presenting? Okay, here we go.
There we go.
I see it now. Okay. Right. So lab update. So I basically reduced the vacuum system piping as much as I could. Currently, we got all the rubber pieces out. So basically, all the planned updates are complete. Before, we were only able to get down to a few millitorr, and that's not low enough. So right now we're getting 10 to the minus 4 torr. So we're getting in the kind of like in the range where we feel comfortable that, okay, it's something we can say, okay, that the air is probably not causing any of the effects. We are waiting on another part, a mist eliminator, but basically at this point, there's no further upgrades that we can do that won't be a major cost. So there's nothing else planned at this point. But like I said, we got to the vacuum levels that we needed to actually kind of skim by there. So let's see here, next slide. So the upgrades to the device, I kind of mentioned these before, but one of the things I want to point out is you can see here, this device has updated bearings. The bearings are kind of this little part in the center, that kind of a brass piece in the center of these 2 aluminum pieces. There's like an ear sticking up, and you can see a little the rod going through it, and there's a bearing there, and that bearing is a composite bearing. We recently got some samples, and I just ordered today. I ordered a bunch more because we're going to be using these. So we put 2 on either side. It kind of sandwiches in there, but even with these, and even with the small ball bearing bearings we were using, the device does have some play to it, and that is a problem because when you have a little bit of play, you have the potential for the thing walking, or when you get something vibrating, it can do something often called stick slip. Okay, so that's we're trying to get away from that. But even with these, even though they're composite on metal, and you wouldn't expect stick slip, it's still possible because of that play. So what we're going to be doing, there's the other upgrade to the devices we're using, I mentioned here, is I want to mention something else about this, is that all the bearings are on one plane, and that plane is a horizontal plane. So mechanically, that's not a very stable condition, right? You can get play everywhere. So here's another sample. This is with metal on the left, with the metal bearings, ball bearings. It can be quite smooth, but when it vibrates a lot, those metal bearings actually can scour the rods. And so we've seen that where the rods will be scoured, and you can see the little channels where the balls will like cut into the metal rods. So they're metal ball bearings. So on the right is what the new configuration is going to be. You're going to see, at least on the other side, there's at least one other bearing support to reduce that play significantly. We basically want to get rid of that. The other thing about the setup on the right is that now in the experiment, we have, on the left here, you have an aluminum plate. You can see that round plate on the left, and then you got that brass reaction mass. And so there's an asymmetry there that, in theory, is going to exhibit the Mach effect. Now, what we're going to do on the right is that shows two brass reaction masses of the same mass on either side. So that's a configuration of a null device. So what we're going to do is have devices where we can take off one side and replace it with basically an aluminum side where you don't have the mass sticking out. It's basically going to be a plate with the ears and configured, so it's just one change. So that's kind of like a more controlled experiment, and also mechanically stable, where you're not, getting the torsion and getting that potential walking. So yeah, that's something that's going to be coming up. We have that one sample here, and we do have a brass plate that's machined that we can use to replace this. But we're going to, instead of using brass, we're going to be using aluminum. It's much lighter, so that way we can compare aluminum and brass, and then a null device with the same device. And ideally, we'd be able to get consistent performance in the lab and be able to send them out for testing. So, in the past, there's been a lot of problems because of the metal, the scouring. So many things can go wrong. And we're hoping that this will solve that and allow us to get, repetitions and verifications. So I want to kind of remind, this is a reminder of last time I talked about this. This was the large positive signal that we got. We haven't been able to do this again yet. That device was with the metal bearings, and we are working on getting something more stable, because even with this, it could be that this is just happened to be pushing at the right time. But looking back at the videos, it's still a promising thing. There's still something that's kind of popping out, and we're really optimistic. So yeah, that's the current status. Replications in progress. We're trying to get it where it's replicable, and we know, okay, there's a path there we can take. We can rebuild it and have several of these, and they all work. Okay, it's not just one-offs and it happened one time and there's a story about it. So there we go. So that's most of the lab update. I did have some kind of remarks on physics. One of the things I'm going to be doing is investigating the molecular thruster in terms of the theory. That's something that I'm going to be working on, and yeah, I'm still going at it. And another thing is, once we get the thing replicated, we're going to be going for some funding. I think once we get some replications, it'll be a good time to do that.
Curtis, thank you, man. Well, I think that's everybody. Drew, do you have an update for us? I know Drew has some breakthrough stuff he's working on, but he's hush hush right now, and that is totally cool. So
yeah, I because we ran late, I went ahead and shut my system down about 2 hours ago.
Okay, no worries.
One interesting thing I did do is when it was at full blast, making about 4 millinewtons of thrust, we unplugged the high voltage lines and we ran in perpetual motion for about 30 seconds until it started bleeding the charge off. That was kind of cool.
That is cool. Well, guys, why don't we do this? Let me see. It's 6:15. Why don't we go until 7 tonight? That'll give us about 45 minutes or so for open discussion. Are you guys cool? Open discussion? Let's do that. Okay. Yeah. So I guess open, and let me see. I'll bring in. Yeah, that's everybody who's here. So what I'm going to do is, let me see. Oops. Okay. Yeah, I can't take out some of these slideshows, but that I can take out. Okay. Yeah, that's everybody who's here. So yeah, I would say if you guys want to go, I said one of the things that I've been really interested about, and I've been corresponding with Shiva about this, is this hydrodynamic model of physics that he's been working on. I think that's conceptually, the model is really amazing. Like last time you were describing, like basically what was it? How electrons cluster around an atom in certain spheres, right? And you were saying, okay, if you put something into a wave pattern, it's going to naturally do that over time, and it doesn't require complex orbitals or anything like that. So,
well, the orbitals themselves are they're spherical harmonics. Okay, so when you look at the Schrödinger wave equation and the various lobes you see where you find the electrons, that is spherical harmonics, and so it's already a wave-based system. And so just the issue is like, well, then why is it found in different locations within that area? And that's just that's handled by a level of granularity and complexity to space. In other words, so you have to have a space that can have characteristics which are complex at a minute level, which we already have. They call them quantum fluctuations. In space where you have particle antiparticle pairs. There's a variety of different ways we already described that. We just don't have anything other than randomness. Whereas what we would be proposing with any kind of fluid dynamical basis would be something that is actually deterministic, but it's just chaotically deterministic, just like we find with John Bush's Walker system, where the Faraday wave mode gives you these areas where things are more likely to end up, but that's just because you're looking at it over a long time period. And in the case of looking at electrons and orbitals, it's happening so fast that our most minute time period is gargantuan, in its scope compared to how fast things are moving, at an atomic scale. So there's a variety of directions to go in in any kind of fluid dynamical view. But we've kind of been discussing that in the background here in our private chat. So if there's anything anyone wants to talk about, problems you have with the ideas, etc.
Oh, Shiva, have you taken a look at J.P. Vigier's work with his stochastic quantum mechanics? I think it might tie to the fluid dynamics models, because he was thinking that there is a nonlinear chaotic equation that describes the motion of these electrons, and just like with weather patterns, we just can't get precise enough info to predict those motions.
That's exactly the model. So what we're talking about here is once again, all I'm doing is talking about the research that has been done since the late 19th century and has been present all throughout physics this entire time. It's just people aren't aware of these points where you have a perfect analog for our current physics found in a fluid dynamical or hydrodynamic analog. They're just not aware that there are analogs because we've got so much complexity that we're handling with virtual particles, for instance. Okay, like just talking about virtual particles, a lot of people don't understand is the idea of a virtual particle. You can have that with phonons, for instance. Phonons are just collective excitations happening in a crystalline lattice. They are mechanical waves, but we can quantize them because of just the various ways in which that is a useful system for dealing with the transitions between between the various parts of the lattice. And in other words, it's just we have this idea that we can quantize something, and then that makes it real, but it's not real per se any more than a gallon is real in a pool. It's not a real thing. It's a useful way in which something occurs. And what I like to say is, for instance, I could come up with this concept of a what's the word I use? Instead of a shrew, because we have a mole. So if I were to say, there is an exact amount of energy I can come up with that is required to go from freezing to boiling in a mole of water, and then I could call this a shrew, and then I could add a number of shrews to a mole of water and cause these phase transitions that are discrete. But all I'm doing is talking about thresholds and where those threshold boundaries occur, where you have a phase transition. It's not a real unit. It's not a real thing, though it's hooked to something real about the points at which we have these phase transitions that occur. So it's hooked to reality, but the fact that it is discrete is not does not grant it a separate reality. There's still a continuum there that is present, that we're just simply noticing these transitional points within the continuum that are useful and valuable to us when we're as for a variety of reasons.
It's like an emergent pattern. Have you by the way seen the hydrodynamic model that they were talking about at the Unlab?
I haven't heard of that, but I've been tracking John Bush's work for the past decade or so, and
that might be I'll see if I can look up the video and I'll post it in the thing here, and maybe Tim can post it on YouTube. Let's see.
Check that out, because there's just been so much, like for instance, just a couple of papers that Bush has come out with recently. He really delves into so many different aspects of quantum mechanics that you can find in this model, where you've got a droplet vibrating on top of a fluid bath, and so you basically have like a 2.5 dimension system there that you're looking at, and the way in which you can transform that into a 3-dimensional system is based upon one of the only real things that I add to any of this is just noting that the cavitation is something that occurs that has to do with overcoming the elastic threshold of a medium. When you overcome
the analog in space-time would be the Schwinger limit, right?
That sounds right, but I'm more of a historian of physics than I am a physicist.
Gotcha.
So there are things here and there that I'm going to. I just don't remember that specific part of it.
Got you. So yeah, I mean that's. I also looked up the video. That's John Bush's work for sure. So that's interesting. Well, David, that's definitely one to look at. John Bush.
Yeah, definitely. Yeah, I've heard about his work.
Yeah, excellent.
Yeah, because he's doing.
Shiva, I have a question. Have you looked at Carver Mead's presentation?
That's familiar. Is he the fellow who? Wait a minute. I think I saw that just recently. Can you remind me a little bit about it?
So I just found this out like in December, but I gave a short. I mentioned it briefly. I think at this talk, but basically Carver Mead was the guy that proved, back in the Moore's law when all that semiconductor stuff was coming out, he basically figured out. He's a Caltech guy, right? So he figured out back then that if they reduce the transistor size, you get you need less power and you get way more performance, and that allowed for this revolution in computing that happened. And it's interesting. He gave a talk last year.
Yeah, I did watch his presentation, and I also watched a very recent interview of him with Unzicker. If you're familiar with his channel, he's got another channel. He did an interview with him that was very recent, and he had a falsifiable prediction that was then falsified. But I felt like it was a very narrow interpretation of what he was doing. And what he was describing, in other words, there was an over narrowness to the prediction that I don't feel like it just falsified just one small area of what he was predicting in a much larger set of concepts that were not also simultaneously falsified. And a lot of times people get confused about what is actually falsified whenever you have a certain test. Things like just when it comes to whenever you're trying to measure the two-way speed of light, there's a big difference between trying to measure if there is a difference, or in the one-way speed of light, based upon direction, and measuring the actual speed. Those are two different things that are so closely related. People completely conflate them all the time, and it's crucial that you don't conflate them. So I think that was. Last I looked in it was very interesting, but I still am trying to stay the course specifically on these are the points you can follow through history. These are the researchers. These are the their quotes. These are the in other words, I've got a very
exactly. So the reason I bring it up is so he did predict something about gravity waves, Okay, that's quite a stretch for a guy that's dealing with matter. And here's the the fundamental thing about what he did, which is if you look at one of the things that people point at for the success of quantum physics is they point at our technology, right? They're taking credit for all this semiconductor stuff. And here's Carver Mead. He's one of the guys that did it. And if you hear him talk, what he says about quantum mechanics, how it's taught versus what they really did, it's a completely different thing. He makes a strong point that matter is waves. Matter are waves. Electrons are a wave. You can stretch it out and compress it. It's a really different understanding. And I think that we need to listen to him and really understand, because it falls along with what you're saying in terms of this analogy. It has really strong correlations.
I was saying, it's like I can see how it's like, okay, yeah, that's just another way of describing this. That's another way of describing this, which is why I was pointing out that he was only falsifying one very narrow interpretation of a much larger set of ideas. And I kind of didn't like that he was trying to predict something so finite. And then, because it's like, okay, well, you're probably going to get falsified trying to be that finite about it, instead of sticking with, here are the ways in which this is a useful model for us to understand what's actually occurring. And so, that was, it is funny. One of the things that you'll always run into is that engineers are forced by the designers and theorists and things like that to accomplish something. And a lot of times the theory is very disconnected, especially in condensed matter physics. And, you'll find that condensed matter physics, the engineers are saying, yeah, what you guys in theory believe is true about physics is not what we're doing. We're doing things, and it's not matching what you're saying. But we see how there's a lot of close analogies and things like that. So there's always a way. There's the same thing happened in quantum computers, where they have these expectations of how it's supposed to work, but then the engineers are like, well, okay, we have to make something that does something. And when you're talking about, I can compute in multiple dimensions simultaneously, it's like, what exactly does that mean? I have to make it do something from actual mechanical principles. I can't just wave my hands about it. It has to do something. And so what ends up happening is they start moving towards analog computation. And I pointed this out, well over a decade ago, that that's going to be the revolution, and it's happening right now. So,
and his, the key points he was trying to make, I think, are very important. The matter is there's a wave nature, and this whole particle idea that we're trying to, shove down everyone's throat. That's just something that we're thinking that it's not, sure, there's discrete interactions, but that's an interaction. You don't get discreteness unless there's an interaction between two waves.
This is a threshold. Let me point out one other thing. So there's the idea of, like, for instance, with the dual slit experiment, you've got this idea that, okay, once it hits the actual plate, then what's happening is there's a number of ways you can look at this. You can have it as only at the point of interaction. It causes the transfer of energy, and that transfer of energy becomes discrete because it's only capable of crossing the threshold of spinning up an electron of one of the particles that is there, and then that we get the signal, and that's how we have this one point at which it's activated, because it crossed the threshold. It's just like if I've got a bunch of, one of the examples I use all the time is if I've got a bunch of those Easter Island statues half submerged in the ocean, and they're all at the same in a line. There are waves that can come up to it, and they wouldn't go past a certain point. In other words, there's an amplitude of wave that wouldn't knock over any of them, that would just reflect off of them. However, you just simply change the shape of them, and then they will add together and knock over the final one. And what you'll have is a discrete amount of energy that was held within that wave across an area that was relative to the transition of this statue, that one statue falling over. So that's a way in which you can have that. However, there is the point that you have to look at things like what's happening in a what's it called, the fog chamber, where it seems as though there is a particulate nature along the path. Well, that can be multiple interactions occurring along the way. The one final thing, though, I will give you is that instead of that, there may actually be a particulate nature that occurs in the vacuum, where it is a it is an emergent effect. And so the way in which this emergent effect happens in a fluid is if you were to have a vortex in a fluid, it could be spinning at a certain rate. We have and the center of that vortex is somewhat, given how complex fluids are. That's the center is a bit it's a bit dodgy to say exactly where the center is. But when a wave passes across a fluid, it will pump it in a way that makes it rotate. Well, so the thing is, what you can actually do, and you can do this in an experiment, just simply put a tube of water and then pump it with waves, and you can cause it to cross the threshold of the elastic threshold of the water, and it will tear open, and you'll have cavitation. So in other words, I could have a tube with a vortex in it where there are no holes, there's no vacuum in there. Then I pump it with a wave, and what you'll find is there will be cavitations occurring because it's increased the rotation to the point at which it crosses the threshold and causes the cavitation. So you can do this experiment today and show that there is only the wave plus the energy that is present in the fluid. It's the combination of those two things that causes the crossing of the threshold in the medium. And so that is a way in which you would have an electron occurring as waves are going through an ether that is struck through with vortex filaments, which is of course the naturally emerge from any view of continuum mechanics where you have a superfluid as the continuum. So it falls out naturally that you have these vortex mechanics and threshold crossing mechanics that occur if you simply understand the idea that whenever we talk about cavitation in water, a lot of times people are like, oh, it's just because it creates a gas. It's not the gas pressure from the inside causing it to open up. It is ripping it open. It's the centrifugal force that is I know that I'm not supposed to say centrifugal. I'm supposed to talk about centrifugal, but it is the centrifugal force that is causing it to overcome the elastic threshold, because there are issues of the way in which it's the forces that keep the fluid together. You were going to say something there, Dan. You had
we talked about this last time, and I didn't want to get hung up on it last time. You talked about how when water cavitates, the bubble it's a vacuum in the bubble, and
partial vacuum. I mean, that's the thing. There's going to be particles that rip off, just like anything else. That's fine.
It is. I looked this up, and I went down a kind of a deep rabbit hole on this, and I don't want to get too deep into this, but those cavitation bubbles, at least in water, they are water vapor.
Yeah, though there is water vapor in there, but it is not the vapor causing. Okay, what is causing
the natural chemical?
Is it just suddenly a gas is created from what? How?
It's just a low pressure zone. The low pressure zone is changing the boiling point. That's
okay,
it.
so it's reduction of the pressure. What is reduction of pressure when you're talking about a fluid? What does that mean?
The pressure is reduced because of the forces pulling, like the water's flying apart.
Is it pushing or pulling? Exactly. That's the point. It's pulling, not pushing. The fact that there are still particles inside there that have broken off from a surface that is extremely energetic, it's irrelevant. It's not the gas that is causing the expansion. It is the fact that there is additional energy there that is ripping it apart. It is absolutely the energy from the outside, the waves that are causing it to rip apart. It's not suddenly the spontaneous production of a gas pushing it open. That's ridiculous. So it's yes, I know that they talk about it being a gas inside there, which it's just an irrelevant point.
It's just causing the water to boil.
Say again?
It's just causing the water to boil because the pressure differential.
Okay. What is boiling? In other words, what is happening when
the water is boiling? It's going from a liquid.
I think what he's saying is that there's a shear effect, right? That's causing the low pressure, and then the boiling just happens to fill in the gap. I think that's there's
a centrifugal effect.
Right. It's just like whenever you're talking about creating a defect in a crystal, if you were to cause it to in some way be misaligned, then you can actually have a way in which it could open up, and there would be a cavity in the center if it's significantly, I guess if there's enough energy for it to be damaged or something.
Or the tensile strength of the water is being exceeded.
That's what I'm talking about. We're talking about exceeding the tensile strength of the water, and so that is what's occurring. And so yes, I understand that the commonplace understanding of it. But we're talking about advancing, our understanding, not going based upon whatever some guy came up with at one time and everybody's like, oh yeah, I'll agree with that because it goes with what I believe about everything, and then everybody just goes to that one idea because it has momentum. It has mimetic momentum, and it doesn't matter. I don't care that idea has mimetic momentum. If you rationally go through the mechanics of what's occurring, you can look at the idea and say, okay, well, what is boiling? What causes it? There's additional energy present, and particles are coming off the surface because of their speed. That's the same thing I'm talking about here, except there is an opening that's occurring that's not from internal pressure. That's why it continues to collapse. Why does it immediately collapse? Why does it open and collapse with the wave? There's a variety of ways in which you look at it that make it obvious that there is the input of energy from the outside is what's responsible for it overcoming the elastic threshold of the fluid.
Well, it does. Generally speaking, it does collapse along with the driving wave. So, like if you have externally driven cavitation, it'll phase match the driving pressure wave.
Okay, but so my question would be, how could you design an experiment to leverage this for, some kind of potentially energy production or propulsion or something along those lines?
We're talking about a model of physics that down to the in other words, where does matter come from? So what we're talking about here is how is matter created, and why is it why does mass impact space? All of these things are tied together, and you have to have a creation mechanism. And basically, what I'm describing here is that when energy is great enough, you cause a phase transition of ether of this fabric of space, and that phase transition is what basically mass is. In other words, this is the way by which mass is created in a fluid dynamic model, and it matches perfectly with the bouncing of the droplet that we see in the experiments by Yves Coudet, John Bush, etc. And so, of course, it's a perfect analog for those things.
Yeah. No, I really like this model. Obviously, I know the guys are they'll kill me on the math part, right? And I haven't done math in so long, but yeah, but like conceptually, I think things like this are really valuable. I think that being able to reframe these things conceptually is really valuable. And to be honest, that's one of the things, like, I know Dan does this, David Chester does this hardcore, like, is being able to do meta-analysis on different theories. And that's really awesome, because I have met so many different physicists and engineers who are kind of like, okay, this is my thing, right? Like, this is my tool and I'm selling it, and that's all I'm going to ever talk about. And it's not invented here syndrome, right? And one of the things that, like, David has done this consistently is, like, he'll go through and he'll say, okay, well, here's how they explain it in this model, but then in this other model, it's explained like this. And then, here are 3 more, and here's this collection of thought. And for me, that's really cool. That's like next level science, and it's where it needs to go, right? When you're pushing the boundaries like this. So,
and let me point out one thing, just going back in an analogy to something I said earlier. Just because I favor this cavitation model doesn't mean that there aren't other ways in which there's a change to the characteristics of space that is an analogy here that doesn't have to rely on specifically the cavitation model that I prefer, but simply, crystalline defects being are actually something that John Bush more focuses on. And, so there's phase vortices, things of that nature is something he's more focused on. This is my pet aspect of this that I believe to be necessary for a few other things. It ties together a wide array of things, going all the way down to deterministic entropy, to understanding, the surface of a black hole. All of these things, that they're all tied together into one system, which is why I like this specific idea, because it allows us to go from end to end.
Yeah. No, that makes sense. Well,
yeah, there's other ways of looking at that hydrodynamic thing as well. Like in terms of the energy required to get the particle, you can think of it, and this is somewhat self-referential because you're starting from the particle masses and things anyway. But if you think of like virtual particles, you have some time energy uncertainty, and for a given energy density of space, that corresponds to a volume of space-time in a Minkowski diagram. So you have like when the particle-antiparticle pair is created and when it's destroyed, bounding some volume in space-time. And when you have sufficient energy density that these volumes in space-time overlap, then the virtual particles can interact with each other, and that introduces a nonlinearity into electromagnetism, which is the electroweak unification, probably. And then so there's many ways of looking at these things.
Right. There's various analogs, and the value here is being able to find some unifying ideas that we can test that allow us to connect a whole model from end to end, and have, because one of the reasons why it's like some of the problems people have with the with Bush's work, for instance, they can't wrap their head around how is it that this is valuable? How does this describe anything? Just because it acts like quantum systems in every conceivable way, they have a hard time understanding how that actually tells us, well, here's a mechanical way that we can have determinism back in physics again, and that there's a deterministic way by which all of these things occur. And so it's like, well, how does that actually, how do I map that in my head? And that's basically part of what I attempt to give people, is a way you can understand how these experiments relate directly to our knowledge of quantum mechanics.
And the next level is, if it's deterministic, is there any way that we can make it computable, like maybe with weak measurements or something?
The computable part of it, well, it's like, well, are we going to solve perfectly predicting the weather? I don't think so. But we can get closer and closer. That's the thing. People give up instead of attempting to get closer and closer. And it's like, yes, there's a certain level of complexity that we will always have to use statistical, mechanics. We'll have to continue to have to use statistics to describe these systems, but we can narrow the statistics more and more. It's like, yes, there's too much information there, too much complexity. You can't track every quantum particle back to the beginning of the universe and the entirety of the universe, and or even for 1 second, you have to track everything that's happened within 1 light second. To be able to compute that level of complexity is absolutely absurd. So yeah, we're going to have to continue using statistics, even when we believe that those statistics are only an approximation of what's really actually occurring. It's just like whenever you're trying to model a droplet bouncing on the surface in these experiments. You cannot exactly determine it, yet it is deterministic. You can't exactly determine it because your tools and your knowledge are the weakness, not because the system itself is magic or randomness, which are directly equivalent in my mind.
By the way, I want to mention this year there is actually an experiment that's going to get high enough energy to test the vacuum. So we talk about the Schwinger limit, but that really that limit is actually being reached. So
you talking about the birefringence?
It was Sabine Hassenfelder did a YouTube video on it back in December.
And they're reaching it the exact way I was saying they should be reaching it. They're using particles as well as photons. And they're using the fact that the particle has a very large energy density in space on its own, and then when you accelerate it, it has even more, and then you add the photon into the mix.
Yep. Yeah.
Does this have potential to destroy the world, like the last?
No.
Okay, now I remember the Schwinger limit. Okay, yes, the point at which it becomes nonlinear. Right. Okay, yeah, it does seem like if you're going to have any kind of soliton dynamics for the way in which particles work, which is actually something that a lot of people in the fluid dynamical, models, the people who are developing those things, there is a requirement of nonlinearity happening at the quantum scale for you to be able to have a soliton. In other words, you can't have solitons without that, right? So yeah, there is some point at which the energy density actually passes the Schwinger limit for matter to occur.
Well, yeah, and it seems to me if these models are fluid mechanic models, this is a strong argument that matter is a field, right?
Yeah.
And
Well,
it's a wave.
More fundamental. I agree.
Like my understanding is that it's kind of in some ways almost like a self-reinforcing field, right? Like a vortex. Like and I've seen this conceptually, not math, but I've seen conceptually people speak to particles basically being self-sustaining vortices of time space. And now again, I don't know why some of those would have mass and others wouldn't. I mean, that is beyond me, but I like that idea. And one of the reasons that I like that is you can pull particles out of the fabric of space-time, right? If you have a powerful enough photon, you can knock an antiparticle out of space-time. Well, where does that antiparticle come from? Either space-time is composed of them or it's composed of something that can become them, right?
Yeah. Yep.
So then it's like, okay, maybe they're the same thing. These are just self-sustaining vortices or something.
And here's the thing, right? So we know, in physics lab, upper division, one of the things I had to do is take a scintillation detector and detect positrons. So every now and then there's a gamma ray that hits the Earth, and there's electron positron that break apart, and you can detect them. And so this happens all the time, right? I mean, you can get gamma rays, and this experiment's going to do it in a reproducible way. So the stuff is there in the vacuum. Now, that's why I go back to Sachs's theory and what he did, which is predicts all of this stuff. I mean, it's always there. The quaternion stuff he used way before Penrose and before Eric Weinstein and all those guys. I mean, it's a field theory. It's a unified field theory, and it might not be correct in terms of like everything, but there's good reasons why he's doing that. And then the fact that matter at high energies is nonlinear. I mean, you look at the problem with the sun, right? The spectra of the sun is continuous, right? That's kind of a problem because we treat it like a gas. That's not really, gases don't have that spectra. And so, with Sachs's theory, that's all fine. And there's a lot of things pointing to, okay, there's a sidestep here where our assumption of X, Y, Z, and T is maybe too simplistic, right?
Well,
it could be that things are that space-time is complex in a way where we got to give that up and just look at the data and see what it tells us.
This is why I'm.
Which Sachs is this again? What was the first name again?
Mendel Sachs.
Oh,
yeah. This is why I'm really excited about the advent of AI, and I'm hoping in the next decade or so that it will be able to go through this, because to me it feels like we are reaching the point where it's going beyond any human mind in terms of number, years of history, number of experiments, a number of contributions and papers by various scientists, different philosophical paths. And, and it's not like we don't have enough, people are like, where's the next Einstein? There are people who are just as smart as Einstein out there today. There are probably several of them in this room. That's not the problem. The problem is, like, Einstein had a lot to work with. Okay, so add another 100 years of thousands of Einsteins, I mean, there's something like, was it 1 million different PhD level graduates, if I remember right, in science and engineering fields. And most of those, many of them are doing papers of some kind or another. I think several 100,000 of them are just physicists, if I remember right. So, like, we're reaching the point where to be able to have that kind of machinery to, if nothing else, narrow it down would be really helpful,
Yeah, well, and even just getting a bird's eye view in the first place, even of the set of knowledge that will be useful for figuring it out, like even getting that bird's eye view is difficult these days. And I just hope that we can figure this out before the body of human knowledge and maybe all the stuff AI creates just completely outstrips like the complexity level that humans can mentally deal with. I hope we can get to a unified field theory before that limit.
Yeah. Well, and then the other thing too is a lot of this stuff, like you've got people contributing in different languages. English is the primary language, but before that it was German, and China is doing papers in Chinese. And so, yeah, Shiva, I didn't mean to interrupt you, sir.
Yeah, I was just going to address something Jared asked earlier, which basically there's always this comes down to this philosophical question about determinism. It's like, isn't that just a isn't that just some sort of commitment to a philosophical artifact that doesn't have any good grounding, or there's a variety of reasons why people are like, well, why do you need determinism? Why is that even a thing? Why would you prefer it? And a variety of questions around that. And I have to point out that, well, first of all, there's a point at which we have to imagine that we're not all just butterflies dreaming we're a man, or any of those kinds of that you all aren't just a figment of my imagination. There's points at which you have to back away from the very bottom of doubt, which is I doubt, therefore I think, therefore I am. There's a point at which you have to start building back up and choose some level at which you're willing to say, okay, this is the point at which I don't know what's underneath it, but I'm at least going to try to go deeper than where we were before. So the answer to that question of why determinism is because what is the impetus in science? What gave us science from religion? Because religion was our exploration of the data available to us to try to understand and even predict or deal with the world around us. And then we got science. And what was the categorical difference that really changed it? Was it just experiment? No, they had all these different ways in which there was this miracle and that miracle, and lots of people saw it. And so yes, some of it is methodology, but one of the singular things was the no magic theorem. In other words, this is not the spoken thing, but there is this base idea at the very heart of what started the scientific process, was that there is no such thing as magic. There is only mechanism. There's only mechanics. And
is that true, though?
Say again?
Is that true, though? I mean, science came more from alchemy than religion, and alchemy was all about magic, essentially. And so, I mean, it's about consciousness.
That's an interesting point. That's an interesting point. I was going to say, like, before, when John said, like, oh, they didn't listen to me about Mars or give me credit because I said these other things, I was thinking about how Newton, nowadays we would have ignored Newton because he did some alchemy. The
thing is, with alchemy,
some people refer to him as the last magician.
Because they were attempting to find a way by this thing leads to that. In other words, so that is a good point. So what exactly is mechanism? It is that there is cause and effect. In other words, that cause leads to effect, and there's not just things that happen without cause. In other words, there is a causal chain, and that was part of what the impetus in alchemy. That was the first steps in saying, okay, this causes that. If I take some antimony and some mercury and like mix them together, maybe I'll get the thing that I don't really understand exactly what it is because it's beyond me, like the Philosopher's Stone or what have you. But there was still this basis of cause and effect, and then we refined that cause and effect through what we found was an analogy to mechanics, which is math. Math is an analogy of mechanics. It only happens a specific way. And it happens because this goes into that in a very particular way. And there's a reason why Babbage's difference engine and the advent of computers happened with mechanical things. In other words, there are gears that can make math happen. And that is actually a better representation of what math is a machine. And so it is this machine-based view of reality that things occur because there is some mediating factor. If there's a distance between things, but all things have some sort of cause, and then there is an effect, and that there is not just a causal events. And that's what randomness, by the way, which is why I call randomness magical thinking, is because it is the idea of a causality coming back into science. And that's one of the reasons why I prefer I'm just explaining what you will eventually say is a philosophical commitment, but you have to kind of I have to put
Isaac Newton's theory of gravity wasn't like that.
Go ahead, Jared. So I think it might have just been a miscommunication in the question. What I was trying to ask was when you said deterministic, right? There's layers of reality, right? And at our layer of reality, you start out with Newton, right? And you're like, whoa, calculus is awesome. That's amazing. F equals ma. I love it. And then you step up to Einstein and you're like, oh, hyperbolic space. Okay, well, stuff just got interesting, right? You're starting to get these different time factors, the space-time, right? It takes on a whole new meaning. And so we've gone from the mechanistic thinking to the, okay, well, it's still mechanistic, but with added flavors, right? And then after that, we get the quantum theory, and the quantum theory starts saying, well, wait, no, it's not necessarily mechanistic, because now you have these probability spaces, you have these probability states, right? And to make it collapse in the way that you want, or to make it do the thing you want, is really hard, because
that's reification of concepts, though. In other words, that's go ahead. You wanted to
okay. But after that, then the philosophy started coming in, like you were saying. But when you look at what creates probability, what things rely upon probabilities, and you go into the math world, non-physical side of things, you look at transcendental numbers, you look at fractals, you look at a lot of these other things where it seems as though these are entities on their own. You know, math is being discovered, not invented types of things. Mm-hmm. In the physical side, it looks as though at that very fundamental level of probability spaces, you can unpack that even farther into what kinds of probability spaces they are, what shapes they are. You can start, understanding the relationships to the other probability states. And then from that, you can start inferring an even deeper mathematical underlying, which then has even deeper connotations on the metaphysical, which then,
and then all of those are ways in which you spin off into numerology. In other words, that is modern numerology. Numerology has a basis, where you can come up with, and you can find these things that are patterns within numbers themselves. Yes, there are patterns within numbers themselves. The base 10 system is going to have a certain set of patterns, and so is the base 12 system. And all of those are just aspects of the repeating nature of it, and the fact that they are sequential.
And some of those patterns.
Oh, looks like you got cut off.
He cut out. Yeah, okay, well, so I have kind of this is something that's been brain teasing me, is in a deterministic universe, and I'm not saying it doesn't happen. I'm saying
I froze there for a second. I was going to say, and those patterns are useful, because that's what some of those patterns are, because that's what gets us algebra back in the 1600s or whenever earlier.
Mm-hmm. So in a deterministic universe, how could you explain something like quantum communication or quantum computing? And one of the things that I've wondered is maybe there is some kind of a higher dimensional component to that. Maybe it is deterministic in a higher dimensional space.
Okay, so
that's more or less what Sachs is bringing in. He's bringing in a quaternion. Basically, you have a quaternion for time, quaternion for each space. So you get 16 components. So it's a whole different way of looking at things. It's not string theory. It's a little different thing. But the other thing is, in terms of deterministic or when you say quantum, see, here's the problem we have. We're looking at these theories, and we can't tell which of these concepts are something we should base and hold. So we're talking about Hilbert spaces and probabilities like they're fundamental. We're talking about all these things that are all like they're fundamental. They're contradictory. They can't both be true. You got to kind of pick one, or pick some kind of thing that's off to the side. It's really difficult. It's really difficult to make the choice. And going back to the rational basis, like if you look at something and you say, well, I can do something that is, I might not feel comfortable that, okay, space-time is not, it's not linear. It's not the real numbers. It's could be complex numbers to describe it, or more fundamental, or octonians. As I go higher in energy, maybe those break down and it comes back around. It could be geometric algebra. But if we have to let go of something and let nature tell us what it is my point of view.
Yeah, but then you also get it. That's exactly what every religion did as well, is they let nature tell them, and it's because they have a fundamental filter on the way in which they interpret what nature is telling them. They believe certain things about it, and that, of course, can occur in when we do not recognize that we ourselves are going through the same process today that they were going through then. We just happen to have more tools and more information. So, but going back to your question about determinism, so there was two things that you said. There was determinism. And what was that exactly your question? It was in a deterministic universe. What was it, Tim?
Oh, well,
communication.
yeah, I was wondering about some of these quantum events, right? Like quantum
Okay,
communication.
that's right. Extra dimensionality. So yeah, there is a way in which you can. There's two things I want to talk about when it comes to determinism. Is first of all, our ideas of determinism are typically very fundamentally linear, and that's like we think there's one cause, one effect. It's one to one. So in other words, so we come up with these fundamental errors of logic where we believe that a straw can break a camel's back, and we believe that the last snowflake is what causes the avalanche. That ignorance of the situation is actually something that Bell talked about a lot when talking about Bell inequalities in these various discussions. So let's just say right now that any idea of determinism that is based on that old version of determinism falls to Gödel incompleteness. There's a problem of the linear computation way in which we do things that doesn't match analog computation, which is basically fundamentally simultaneous, or what's the word that they use for computing? It slips my mind at the moment. So, but then let's go to the other thing you talked about was extra dimensions. There's two ways in which you can think of extra dimensions. There's external and internal. And that's a very, very important thing to know about extra dimensionality. We use many additional dimensions whenever we're treating fluids, and we don't believe that there is extra realities in the fluid. We're simply keeping up with the ways in which these various things, even after they're twisted and changed, still maintain some semblance of what they originally were because of it. You can take these relationships and alter them. And so the idea of an additional dimension can be another way of slicing the pie, or you can have something that is external to me, where you get the whole idea of flatland, and a person from a four-dimensional reality, when they pass through, they appear and disappear and all of that stuff. That actually has no empirical basis. There is the idea of space-time conjoinment, which Minkowski gave us, has no empirical basis. Because it is specifically encoding isotropic light speed constancy. That's what space-time conjoinment is. And there is no evidence for that. There have been, and that is something we've talked about before. That is the kind of the dividing line between the fluid dynamic model and that was there and present in 1905 through Lorentz and Poincaré, and the what we adopted, which was basically a sort of metaphysics. It is not empirical to say that space and time are conjoined. That the evidence, if you want to use the evidence of the Michelson-Morley experiment, you already have a way in which you do not need to promote the dimensionality of reality and allow for infinite additional realities. So that's what it is. In other words, you're promoting with space-time conjoinment, a single moment is 4D. In other words, a single moment of time. That's just like saying that the difference between a single sheet and infinite possible sheets is the difference between 2D and 3D. The difference between a single moment being 3D and 4D is infinite possible simultaneous realities, versions of. So it is kind of an intrinsic adding infinite realities to our current reality without an empirical basis. And that's very important.
And then the other thing, I was teasing you about this in email earlier, the other brain teaser was, what if quantum is only quantum in our simulation? What if higher level, what if the higher level world, the one that created us, is actually deterministic, and quantum is just a shortcut to save processing power?
Yeah.
Why wouldn't quantum be deterministic?
There's
so,
analogy.
So Tim, I'll give you a math idea that might help with this whole. Okay, well, quantum communication, nonlinear. So there's something in complex numbers called the Riemann sphere. So you imagine a plane, right? Okay. And you have infinity as far away in the plane, and you can actually, that plane of complex numbers can be modeled or can be thought of as a sphere, where you take the top point and you shoot a line through, and every point on the sphere maps a point on the plane. And if you go, of course, the top, you go off to infinity, right? You can't go anywhere. Now you could take that sphere and imagine rotating it. And now infinity is no longer infinity. Now infinity, that old infinity, is now a point on the plane. Okay. And that's something you do in complex variables when you're trying to solve something and you get infinities. You can do a transformation. you can transform the infinities out.
Yeah.
It's a very powerful mathematical tool that you use to solve partial differential equations and other things.
I would need therapy if I got that level of math.
I would
swear to God, I would have therapy for that.
So let's think about, okay, that's a real plus imaginary number, and then the theory I'm talking about, which is Sachs's theory, is using quaternions. So it's a real plus two imaginary numbers. So there can be a similar type of thing that you can imagine, where you get in infinities that can be transformed out. And so you look at a theory like quantum electrodynamics, where they run into infinities, but somehow like, oh, we're going to renormalize. Somehow that works. Why does it work?
Oh, God.
That's a good question, right?
Torsion fixes that. Gravity fixes that.
See, so yeah. So there is the reality is telling us there's a lot more going on than our kind of naive notions of comfortable. I'm moving left, right, up, down, back, forward. Space is more complicated. Matter is more complicated, fortunately or unfortunately. And and the whole quantum stuff there's the reason why I don't like it in terms of like treating it like fundamental is that it's kind of like hand waving. It's like, hey, sure, it works in a low energy, you get some good results, but that's not necessarily telling us what's fundamental there, right? And there's a lot of proof otherwise.
Yeah,
right?
truth
Just
and limits.
like, yeah.
That's what people don't understand is you can have an analogy that works and it doesn't have to represent reality. It can actually be that, so you have a whole view of reality that you use to deal with reality that does not accurately represent reality. I always refer to that as the spirit of the fishing tree.
Yeah, like if we're like a holographic projection of stuff that's on the edge of the universe or something, we still use our three-dimensional senses to navigate the world, even if we're on a 2D sphere projection or something. I don't know. Like,
yeah.
I'm going to be the odd man out here.
That's Michael Talbot. That's the Michael Talbot book.
Now let's talk about computation, because that's something, Michael, you brought up. So the universe being computable is not necessarily something that we need to impose on the universe or reality. It would be nice for us.
We do for
right?
practical purposes.
Right.
Like in everyday experience, if it's computable, then we can use it for stuff.
Yeah, it'd be nice if we could, right? It's a nice to have, but it's not. There's no empirical evidence that we can say it has to be computable. In fact, if you look at Penrose's work, right? He talks about has a lot of work where he's discussing, reality is not he argues that reality is not computable because there's human consciousness and because of the things that we can think of, and he's trying to find a mechanism in the brain that does that, right? He has a whole hypothesis on that.
Stephen Wolfram as well. He's got this idea of computational irreducibility too. So it might be computable, but it might not be reducible.
Well, now
this idea of computable is also a problem, by the way.
I guess the part that I would add to this is, philosophically speaking, I went through a big series of essays. This was years ago. It was after The Matrix came out, right? And everybody was questioning their reality. And one of the philosophical takeaways was that, and this goes, Michael, to what you were saying about maybe we're two-dimensional objects in the edge of the universe that represent three-dimensionally. What they were saying was, philosophically, if it's indistinguishable from real, it is real. And so in a sense, you could have nested realities, right? What they were saying was the Matrix is real, because it's indistinguishable from the real world. Now, if it's not, if half of it's missing or, it doesn't work like it's supposed to, then obviously you're in a simulation. But
well, I mean, if you think about it, Tim, the conscious qualia that we personally experience as the world around us is holographically projected on all our neurons. So an external observer in principle could read that hologram. And I mean, we're getting to that point where AI can do that now too. Like AI can recreate videos out of people's heads and stuff. It's kind of crazy.
Yeah, Carnegie Mellon was reading words, over a decade ago, and now they've gotten full sentences
They're way
It's a,
beyond that. They get full video now. You can have a picture of what someone's looking at, or even a video of it, right out of a person's head.
Yep. A lot of people don't know
Kind of
about
wild.
I'm noticing that it seems like a lot of our different ideas and theories might be predicated on slightly different interpretations of quantum mechanics, but we're kind of doing that in a Straussian communication sense, so we're not putting it forward. We're just saying, oh, well, based on quantum mechanics, so and so and so and so, but we're not being hyper specific enough of, based on this interpretation of quantum mechanics, then A and B might be true, but C might not necessarily be true. Like I know Shiva likes like Bohmian mechanics. I would assume a lot of you probably worked with like Copenhagen. I mean, like, so we're probably going to need to do a talk on just.
Yeah, I think more specificity would be helpful to this conversation too. Yeah.
Yeah. Yeah. And Dan, just to be clear, I don't think quantum mechanics is fundamental. I mean, I do understand that it describes matter, but it doesn't go far enough.
This is why I wanted to talk to you specifically, because you're at the opposite end of the spectrum for me. So I really want to try to understand your ideas more.
Sure.
I think David wanted to say something.
Oh, I don't know, a few things, but yeah, I mean, at this point, with the interpretations, at the end of the day, the mathematics is what it is. So that's what makes the predictions. So you can have different interpretations, but unless the interpretation inspires some new theory, then, I mean, at the end of the day, yeah, you can just take a practical perspective and say, well, we get these solutions. It's kind of interpretation independent. If you want to believe that quantum mechanics is describing reality, then maybe you want an interpretation. But, science is always progressing over time. We always think that whatever we've discovered today is the most fundamental thing. And then, 100 years later, it changes. So, or we could go back 100 years prior and be like, no, that was the right picture. But I mean, at the end of the day, it's probably all wrong,
David,
Yeah,
I don't think we'll ever get there. The human species has domesticated itself, and the stories we tell ourselves are the fence around our pasture. So the interpretations really they enable some extra creativity potentially.
Well, let me give
potentially, yeah. But like, what examples what new theories have we gotten from different interpretations of quantum mechanics? I mean,
like Bohmian.
There's been a little bit with Bohmian, but other than that, it's just all trying to argue what quantum mechanics is saying philosophically, so to speak.
I think Bohmian mechanics is our best example of because that gets towards the fluid dynamics stuff.
I can tell you guys what I think. Okay, I think the reality is the world is so going back to what John was bringing up, that we need to toughen up, because if this whole thing is really true about the UAPs, we can't be a weak society. We got to be able to stand on our own feet, and that's really true. I mean, the world is essentially a PvP game, right? You got your buddies that'll help you, but really we're all on our own fundamentally.
That's old school game theory.
Yeah.
You have to look at evolution game theory. That's why nature has ultra and a variety of other things.
Yeah. But really, so the thing is, this whole thing about quantum and everything, like I personally, I was really indoctrinated like the rest of us that did physics, and I felt like the whole Copenhagen thing and all the other many worlds and all these other things, they really didn't feel like I was doing physics anymore. It was a different thing. I had
that's because it's philosophy.
Yes. I went back and thought, okay, what is really going on here? And we, there's got to be something different. I really agree, what Einstein said. This whole thing about the interpretation and the Bell's theorem and all these things, where even the stuff that happened in the experiment, and you look at what people say now, it's a completely different thing. It's like they're talking a different language, and the fact, and I was kind of when I found Carver Mead, when I found his talk on, early last year and his work, I really began to realize, okay, this whole quantum thing, he's throwing it under the bus. You guys, if you guys go look at his talk, he throws it aside.
Well, so did Bell.
That's significant.
But let me give one clarification point on this thing, because it is really important to a lot of people. They're like, oh, this is all philosophy. It doesn't matter. Shut up and calculate. Because people really still are on that shut up and calculate train. They're like, what's all this philosophy going to do for us? What does it matter which one of these they're all wrong or they're all right, or maybe it doesn't really matter. It's just interpretation. That's not accurate. And specifically, I can hone it down to an example where you can understand the difference between truth within limits, which is the spirit of the fishing tree, as I started earlier. And that is, there's a tribe in Papua New Guinea. They pray and sing to the spirit of the fishing tree, and it is empirical science. You can go and watch them. Fish will rise to the surface over and over. They've performed this experiment. Their theory is right because it's got empirical evidence. Wrong. It is not right. It is a neurotoxin that is only damaging to the fish and not to the humans. And they can actually extend their theory even. In other words, their theory of the fishing tree, they'll extend it to become, well, it's actually the theory of the food tree. And they'll go and burn some of the root or something by accident because they're testing everything, throwing stuff at a wall to see what sticks. And because neurotoxins are extremely damaging to insects, it would be extremely effective at harvesting, honey from, hives and things of that nature. So it's even an extensible theory. But idea that is a neurotoxin is far more extensible. So one is actually valuable to them. The belief in the theory of the spirit of the fishing tree is an analogy to something that is replicable science to them. It is empirical evidence of their theory. However, it is a truth within limits, and there are limits that can grow, and you can gain additional engineerable abilities by having something that more closely matches reality. And the idea that it's a neurotoxin more closely matches reality. How do we know? Because then we can extend the idea of neurotoxins we could take that same root and then make something that perhaps helps with nerve pain or a variety of other things. It extends our ability to engineer and change reality, and as we get closer and closer to a accurate model of reality. So interpretation isn't nothing. It is everything. It is extremely crucial. The only thing that separates us from old school AI is our ability to use analogies and our ability to do this thing that is interpretation. It's not the math. The math, computers surpassed us on math so long ago. Let's give up that idea of intelligence. That's not intelligence.
Shiva, the way I would put it, kind of,
actually,
basically
the tool AI that can do that sort of thing.
Yeah. So the tool we really have is like logic and physical intuition, like training yourself to understand physics, understand how reality works, right? That's kind of what we were supposed to be trained as physicists. But then here comes quantum, and it doesn't make sense. I liked it because, okay, I'm solving a partial differential equations. I hated chemistry because why am I memorizing these stupid numbers? Where do they come from? Oh, there's a partial differential equation I could solve, and they all pop out. Okay, that makes sense. But why this partial differential equation? Oh, it's a probability. And I'm like, well, can we use a moment generating function instead, or what's going on with that? There's no answer. And that, it's like, oh, that's the limit. And, all this hand waving. And so that's where there's an uncomfortableness, right? And a decision to be made, right? Go back to logic and reason. And why doesn't relativity and quantum mechanics, why aren't they based on the same number system? Well, in Saxon's theory, they are, right? So that's what fixes a lot of things. But that might, like I said in my talk, that's not necessarily the last answer or the best answer, but I think we need to go back to logic and reason and look at what's fundamental, right? Okay, we have Noether's theorem. I'm not going to you can take that out of my cold dead hands. I'm not going to give that up, right? The principle of relativity, the laws of physics should be the same. There's certain fundamental things that we can all agree on, and that's probably what we should build. Without
pursuing quantum field theory, Noether's theorem would have never been found. It's like we learn more about classical mechanics by studying quantum mechanics.
Yes.
Here's the thing. what is nature doing when it creates a bunch of species in a rainforest that are doing silly dances and using lots of resources for what seems to be waste? It's not waste. It's exploration of the infinite. And as you have more available resources, it is a system. I mean, nature is a cold, dead, system, when you look at it from a long enough timeline, right? It's just trying to find the way for life itself to survive. So it's attempting to find ways to avoid being eliminated. And the only way to do that is to search through all the infinite, possibilities. And you do that by doing new things. Well, so of course there are ways in which wrong theories and wrong ideas you eliminate them prematurely, because they can still be a way in which you can discover new things. It's my contention that the whole reason why we discovered relativity is specifically because of a misunderstanding about the Michelson-Morley experiment. It was non-null. It detected 10 kilometers per second, by the way. It showed a dual sine wave of readings, exactly as you would expect of an ether wind. But the thing is, he only looked at
it wasn't what they expected. I mean, you can argue that there's a slight angle.
It's 1/3.
I mean, they're expecting something a lot bigger. Yeah.
No, it was 30 kilometers per second, and they got 10 kilometers per second. But yes, what you're thinking of is like you're remembering the report of 1/40th of the expectation. That's what's coming to your mind right now. And yes, I'm aware that was what was reported. But you go back and you read the actual thing. He was only looking at what the east-west component of it was. And Dayton Miller's work, which he did tens of thousands of replications of the Michelson-Morley experiment, and nobody else has replicated the Michelson-Morley experiment because they're not doing it with full spectrum light. They're doing it with monochromatic light, which has a lot of problems that I don't want to go into right now. But nobody's actually, other than him, replicated the experiment, because it has to be done in open air, because of the only way in which it would have actually detected something is because the air itself acts just like in the Fizeau experiment. There is what Fresnel predicted in the Fizeau experiment, which was the coefficient of ether drag, which is a partial ether drag. He predicted it. It was exactly what he said it would be in the Fizeau experiment. And that is a very large basis for relativity. But of course, relativity existed for 15 years before 1905, special relativity. All the equations were of the kinematics. The kinematical part were well established and well understood. You had length contraction, time dilation. All those things already existed at that point of well before 1905. So the point is that all of those things wouldn't have necessarily been discovered had they not reported the experiment as actually null, even though it was not. Apparently, you can go look at it yourself, go plot it on the graph, change there's a simple a temperature variation where it slowly goes from one end to the other. So long as you understand exactly how the experiment works, he got the same results as Dayton Miller's tens of thousands of experiments performed by different people at different times with different devices at different elevations. And all of them came up with the exact same evidence of a dual sine wave of readings that were approximately between 8 and 12 kilometers per second. But also you have to understand there's a nonlinear relationship between the reading, in other words, how far the fringe shifts, and what it actually means in kilometers per second. And that's one of the other misunderstandings why you might get something like the idea of, it was only 1/40th. There's two different layers of error in that reporting. And Michelson, the first American Nobel Prize winner, never stopped believing in the ether. And he did tons more experiments, like especially the Michelson-Gale experiment. Understand that, and you understand something that I believe is still a secret that I don't want to talk about. But there are a variety of things that point out that there is this the hydrodynamic view has been there all along. But yes, there are mistakes you can make, and those mistakes still play a very important role. And sometimes they lead you in the right direction for the wrong reasons. And so, yes, I believe that Michelson being reported as null actually led us to the truth by accident.
I think we've driven poor Michael to drink. I see that going. I don't know. Did you see that going on in the other frame? I've never seen that before. He's drowning his sorrows.
It's apple juice. It's apple juice.
It's
apple juice.
Lapsang Souchong tea. It's actually kind of smoky, like a scotch, but not a scotch.
It's not a scotch. Is there scotch in it? Did he just kind of secretly tip over?
No, it's just smoky.
Well, we're gonna find out with this experiment, right? When they when they get to the Schwinger limit, we're gonna find out what? What's the prediction? So,
I mean, it's kind of just
it'll give Born info electrodynamics.
The way they're doing it with the Bright Wheeler process, isn't that just? I mean, it's basically just Bremsstrolling off of particles, isn't it? No.
Yeah.
So I don't know how much new stuff we're gonna know based off of that.
Go ahead.
Well, but for me, things like this goes back to like Jared's Graviflyer experiment and some of the stuff that Mark is working with, right? Is what happens if we do get results and they defy expectations, and I mean, now it's entirely possible. I would even say likely that someone who is more excuse me. I'm going to mute myself out for a minute.
Okay, no problem, Tim. So one of the things, the reason I bring that up right after Shiva was mentioning the potential of an ether, right? So Sachs's theory has a background, what he calls a background pair. You can call that an ether, which is positrons and electrons coupled, maybe even protons and antiprotons coupled. So you could, in this experiment, you could potentially see a difference in what's expected from quantum mechanics with what's expected with this kind of a field theory. Although I don't know if Sachs really actually made a prediction about what would happen, like what the density
predicted some masses wrong. I mean, it was kind of close, but you got some masses wrong. I don't know.
Masses of
elementary particles.
Oh yeah. Well, yeah, I mean, he like I said in my talk, his calculations weren't necessarily strictly that robust because he did a lot of approximating. So he was doing things.
Yeah, I mean, it was really cool work though, overall.
Yeah, there's order of magnitude guesses in there, and to do the computation, what he was doing, to do that correctly, would require a lot of computing power. We could probably do it today. But back in the 70s or whatever, he was doing a lot of assumptions that it's not going to work, right?
Maybe we can see it, go do that and find a good computer, see what we can get for those.
Yeah, that's possible.
If they're accurate. That would be good. Because if they were just inaccurate because of the approximation techniques and the lack of compute power back in the day, then that would be an excellent double check to do.
Yeah. Oh yeah. Yeah. That would be an interesting thing. But in his work, right? Like I went over it, he predicts the mass of an electron and a muon. Yeah, that's in there explicitly. But that again is done with approximations, right? In there.
But that one's easier to approximate, I imagine.
Yeah. That's a low hanging fruit that everybody has to do. The other thing he did is it did the Lamb shift, right? He predicted that with that theory, which is you normally can't do that with
the symmetry of asymptotically flat spacetime at the boundary of infinity, which I mean it's really like a precursor to holography from the 1960s or so.
That's pretty cool. I didn't know he got that far.
Yeah, there's this infinite dimensional symmetry group on the boundary of the universe in general relativity.
Definitely gonna have to read up on Sachs's work then.
Can you say that one more time? Sorry.
Definitely gonna have to read up on Mendel's work then.
Oh no, sorry, David. About the
Bondi Metzner Sachs group is this infinite dimensional symmetry group. Penrose calls it scry. Plus or minus, you follow a light cone to future or past null light cone infinity. And then so you get this sphere. You land on a sphere, basically. And there's this infinite dimensional symmetry group that implies an infinite number of conservation laws. Just like, okay, so what does that mean? No one really knows.
Interesting.
It's, yeah, I think Bondi said it was like the most important thing in his life.
What?
Yeah, Penrose has talked about. I mean,
infinite dimensional.
Is that what Mendel
got an
Sachs?
infinite number of parameter in the group. It has an infinite number of generators. It has these it has nothing to do with supersymmetry, but they're called super translations. And then around 2010, the super rotations were introduced by a couple people, and that has also been discussed by Andrew Strominger at Harvard a lot. And that stuff actually kind of related to what maybe helped Hawking change his mind about information loss to some degree.
Yeah, no, this sounds really similar to some of the work that came out of Bekenstein with the information being coded on the surface of a black hole. The infinite dimensional kind of space at the boundary of the observable universe, that sounds really similar to me to the dimensionality of the Hilbert space of the observable universe being defined by being proportional to its area, which I'm making connections in my head. That's really interesting.
It's probably a little different, but yeah, I mean, it's just like it
seems a little different.
It has a number of generators. I wouldn't think of it as like space-time dimension, but yeah, I mean, a Hilbert space is different as well.
Yeah,
I mean, it's a purely.
So David, you're talking about
Hilbert spaces in classical mechanics as well. So,
are you talking about the group that Mendel Sachs used in his quaternion formulation?
No, that's just other work that Sachs has done. I mean, Sachs has just worked on general relativity as well, and the BMS group is
just kind of trace
one of his
thinking
more important
go ahead.
contributions overall.
Yeah. So yeah, that's right in general relativity. So in his formulation of general relativity, you had a quaternion. He called it a quaternion group, but. Yeah, and who was the other fellow? You said Sachs, and who else?
Bondi, Metzner, and Sachs. But I mean, this wasn't related to Sachs unified field theory. This is just straight general relativity.
Right. Okay, I'll have to look at that.
What would it mean for it's a really interesting idea. What would it be like for an infinite amount of conservation laws to be the case? Infinite laws of physics?
Yeah, I mean, I don't think anyone has
sort of kind of
great intuitive understanding of that, but the Poincare group is found inside of it, so it does relate to energy and momentum conservation. But oh man, I used to have better intuition for what the super translations were. I mean, the rough idea is kind of like if you sent light across the entire universe, and you integrated out the information from the bulk, you wouldn't really know what matter it went through. So you can have these super translations that kind of allow to have these different shifts based on what was actually there in the bulk.
Interesting. Yeah, so I come from the diametrically opposed camp to this, where basically, the idea that string theory has as many solutions as there are atoms in the universe. And it's like those types of things, I find them to be like, completely no longer having any merit because the amount of noise drowns out the signal by, infinite orders of magnitude. And so but
this is completely different than that.
Well, when you're talking about infinite dimensions, there's you're already starting to get into.
Well, I mean, you could say there's an infinite number of space-time. Like it's just fundamentally different. I mean, string theory has this landscape problem, which is talking about 10 to the 500 different theories found at low energy. This is talking about a symmetry found in one theory. It's like completely different.
Well, yeah. Maybe I'm wrong here in feeling like it's similar, but I was just going to explain something that I feel like I think that people can kind of agree on, that there is I come from a background in software engineering where I did that for over a decade. And one of the things that happens whenever you're developing a software package over a period of time is you have to keep changing it because there are new requirements. You build it, there's new things that it has to do. Well, that's very much like any kind of knowledge system where you're attempting to explore something of the unknown, is you have to keep building onto it. But the problem is whenever you start from a basis, you start to have to build on and build on, like building a building from you create this foundation and then you keep adding onto it, and pretty soon it's this pile of garbage that you eventually have to destroy. But you don't want to completely destroy it because there's still a lot of value you're getting out of it. There's still people living in it. There's still a variety of reasons not to utterly destroy it. So you have to have the ability to gain something from it. So same thing is true of like redeveloping a software package. What you do is you go back to your basics and try to eliminate absolutely everything that is not absolutely necessary and start building from there. And you whenever and any time that you can find something that is not absolutely 100% necessary, you try to eliminate it and integrate all that it might be able to do from the basis of your redevelopment of the software. So that's how I feel that is what I'm trying to promote as the way forward in physics, is rewriting it like you would a software development thing. You don't continue adding on to something that is already fundamentally failing with a huge range of ways. What you do is you take all the things that it represents and all the things that it does, and you go right back down to the basics and try to absolutely eliminate everything that you can that is not 100% absolutely required for you to take the next step forward in accomplishing your task, which is, in this case, it's not the software package being physics, is describing reality. And so that's kind of what I've been attempting to say is like, can we try to head towards that? Can we try to eliminate absolutely everything that we possibly can and build from scratch?
As long as that theory has better predictions than our current one, then with actual math, and yeah,
that's the whole goal. Obviously,
yeah,
that is absolutely a requirement.
So by the way, that's one thing I have been kind of contemplating is, because Penrose did bring up this important problem of consciousness and what he argues is non-computability, and that any theory needs to have account for that or allow for that at least. And so, having some infinities in there might be actually a thing we expect, right? If that's something that we're going to take as one of those things that, like Shiva said, that okay, we do need in Noether's theorem or symmetries and conservation laws, they're connected, right? That basically, or principal relativity or general relativity, right? Covariance. There's a few other things, correspondence principle. So there's some things fundamentally we want to hold on to, and is it going to be, we expect reality to be computational? Probably not, but maybe we expect it to be have a non-computational element, because
like
that's
strong
what we see in
emergence, maybe.
ourselves. Yeah.
Like the notion of something being greater than its parts has two interpretations. One interpretation is to isolate the parts and then say the part that's greater than its parts is the interactions between those parts. But that I would refer to as kind of a weak emergence in a sense. But let's just say you thought that a proton was conscious, right? Like what if there was inherent information? If you do a conditional probability where you remove all the information of the pieces, including all the interactions, if there was something left in that macroscopic system, then you fundamentally can't predict anything about it. It's borderline unscientific because like all of science is kind of based on the idea of reducing to its pieces, figure out how the pieces interact, and then put those pieces together, to figure out how everything works. But, if it turns out that there's something about combining matter where eventually there's some strong emergence where, what it means to be a human being, like, isn't uniquely encoded by all the pieces inside of us. I don't, it's still an open question.
Right.
Does our DNA alone, determine our conscious state of reality? Or is it kind of, is there this infinite scope of possibilities that, what it could mean to, have a personality? Maybe it's inherently unpredictable.
Yeah, it could be deeper, and the matter we're made out of interacting with space-time in some way. And so one of the things I want to mention is the whole thing Shiva was saying about, deterministic versus computational, right? Those are two separate things. So something like you can look at, things that are, we might say they're simple systems, but they could be non-computational, right? You can't compute them.
The word computational right now is actually kind of violated by all of those things which seem to solve the P versus NP thing, like how slime molds can solve the the traveling salesman problem, and there is a disagreement with what we are finding in analog computation. Whenever we talk about computation, we're basically completely not paying attention to this huge part of how the rest of reality works, how our brains work, how all of these things are massively parallel. And it is the ability for it to be massively parallel that causes a different sort of computation that is not part of what we specifically, whenever we talk about, is this computational, is it computable, etc. We're talking about a linear type of computation. And it is, that is a fundamental problem that goes to the heart of quantum physics. Is something that John Stuart Bell was trying to get across to people in a variety of ways, and somehow the message didn't come through.
So think about this way. There's the three-body problem, right? It's a simple way of looking at, okay, we have two bodies. Okay, add the third body. We can't compute it. We throw up our hands. We can't compute it exactly. It's like, what are you talking about? Okay, sure. Okay, we can't compute it, but what she was mentioning is the analog computation, right? These fluid models. I mean, reality could be deterministic. Doesn't mean it's not. It is computational. We got to separate those ideas. Be very clear.
Idea of computational. Right.
Yeah, that's a whole separate thing. Being computational in terms of ones and zeros.
That's the same miscategorization of deterministic. In other words, people think of deterministic as that this does this does this does. No, that is not at all what determinism is. Whenever we look at these complex systems, all of the things are happening simultaneously, and they all are that gestalt that David was kind of talking about, where there is this requirement of coordination. Like, for instance, whenever we're looking at the way the brain works, we're starting to see the data aspect of coordination dynamics. In other words, there is data in the way in which signals in the brain are, the timing with which the signals are occurring. That is data carrying. In other words, it's not just the relationships between the neurons and just their firing in a linear fashion. There is also the collections of the neurons, and when they arrive, that are very, very much part of the way that the computation is occurring. So in other words, there is a massively parallel aspect that is data carrying that we are completely ignoring over the past century. In other words, the way in which we look at things is because language itself is mostly, we're partially communicating various simultaneous things, but only a little bit. And so our conscious minds that have this sort of linear this to this to this to this, that is part of language. That's part of a certain paradigm that, that's why we have such a hard time with ideas of the artistic expression. Basically, simultaneously communicating many things, and how there is a level of seeming ambiguity, but it's not ambiguity, it's multi-channel communication. And so there's things like, for instance, in holography, one of the things I like to point out there is, with a hologram, the closer you get to the surface, the more precise you are, the more you actually lose the information. In other words, your precision actually eliminates your ability to see the picture that the entire hologram creates on the eye. Because of your precision, you lose accuracy. And understanding that principle of holography is very important when we're talking about this difference between basically what's linear computation and the more analog, massively parallel types of computation that is about to take off right now. This year, there's huge investments in these analog chips. It is going to be the conversation of this year.
Yeah, and that's actually good, because that might be a way to do the calculations at Sachs. I mean, Sachs's theory is a nonlinear, right? Each matter field is interacting with all the other matter fields in the universe, maybe less than more, right? Depends how coupled they are, right? How much energy, how close they are, what the fields are. But it's really difficult for a theory like that for us to make predictions because of the computation problem. And so having a analog method of computing those things and seeing if that theory, maybe it does give us better answers, that would be something that we might be able to make progress, because right now that is like a limit. It's more of a limit to our knowledge of how to compute things than it is, all this theoretical understanding, because, all these roads have been kind of explored, right? And, Sachs went this way, everybody went that way. but computing this stuff is really, really hard. I mean,
Yeah,
I
Goodell
can't
incompleteness
express
comes
it
down
enough.
to this sentence is false, right? So,
Yeah.
it's the linearity of this sentence is false that allows it to vacillate back and forth. It's because it lacks parallel computation that you have that kind of problem. And so the problem that Gödel was trying to tell us about was exactly what I'm talking about here, which is our idea of computation, our idea of determinism. Those ideas are this one-to-one little linear line of the way that we think of reality, when it's actually this branching, interconnected, set of things all happening simultaneously that are data carrying in their synchronization, which is also, very, very strongly has a lot to say about space-time, but I won't get into that right now. But there is I think that this conversation about, linear computation, linear thinking, linear steps in the way in which we do things, that's going to really come to a head this year as, like Sam Altman just, he's kind of in trouble for investing in RAIN, I think is the neuromorphic chip company that he's just had OpenAI put a ton of money into. Yeah, it's because they're moving towards analog computation. And this has been coming for so long. And it's going to be huge.
Yeah.
For everybody and everything.
Yep.
Nice discussion, everyone. I think I'm going to head out. Have a good evening, everyone.
Have a good one, David.
David, thank you. Thank you very much, man. Thank you very much. Maybe we should close things down. We've gone about 45 minutes over, I think, what we anticipated. This has been one heck of a discussion, guys. Should we wrap up shop for this evening?
Yeah, I think so.
Okay, well, thank you all. Thank you all for participating, for the open discussion, for getting ideas, changing minds, getting new thoughts out there, right? And I think that's super important. So, and this kind of open discussion is really what APEC is all about. So, okay. Well, guys, this has been APEC for February 17th, 2024. We're doing good. We're doing good. Have a wonderful evening, everybody.
Thanks for putting it on, man.
All right. Thank you. Have a good one.